So hello, everybody. I'm Dr. Rick Bedlack, professor of neurology and director of the Duke ALS Clinic. I'm also in charge of education and outreach for the CREATE Consortium, which is part of the NIH's Rare Disease Clinical Research Network. CREATE is a clinical research consortium that's focused on therapy development for ALS and related disorders. CREATE tries to help overcome some of the barriers to therapy development with the goal of improving the success of future clinical trials. Today's podcast is part of a series we developed to help non-scientists understand some of the work that our CREATE team is doing. I'm pleased today to be joined by Dr. Nadia Sethi. Nadia is a dentist by training. She's been involved in several ALS research-related initiatives in the past 5 years. She lost her husband to ALS in 2020. In this podcast, Nadia and I will interview the authors of their recent publication called Extreme Exercise in Males is Linked to mTOR Signaling and Onset of Amyotrophic Lateral Sclerosis. We're joined today by Dr. Jonathan Cooper-Knock. Dr. Cooper-Knock is a neurologist and clinical lecturer at the University of Sheffield, and his research focuses on the genetic causes of motor neuron disease. So welcome, both of you.
Thanks, Rick. Appreciate it.
Thanks so much, Dr. Bedlack. So let's go ahead and dive in. Could we start by talking a little bit about gene-environment interactions? And Dr. Cooper-Knock, can you explain how gene-environment interactions work? How might a genetic predisposition to a certain biological pathway interact with the environment to potentially increase disease risk?
Yeah, absolutely. And thanks for having me on the podcast. So first thing to say is that, about 10% of ALS is maybe all genetic, but most of it is, like a lot of complex diseases, driven by what we think is an interaction between a genetic predisposition and then things you encounter in the environment. So to give the context of exercise, how might that work? So I like to think of it as if you have maybe a genetic break, you've got a mutation in a gene, it's causing a problem in the system that affects your motor nerves, which of course are the cell that die in ALS. And then as you exercise, perhaps you drive throughput through that break more and more. So the more exercise you do, the more effect that break can have, and that might potentially predispose you to ALS. Now, that's a very, very simplified version. And, of course, there's multiple factors involved in this. And most people who do lots of exercise do very well, as I think we'll discuss later in this podcast. But that's to kind of give you a simple idea of how I think about it.
That's great. That was really helpful. And your work for this particular publication used different techniques and sources of information. Can you elaborate on all the different sources of info that you pulled together and maybe share in simple terms the role each of these played in your study?
Yeah, of course. So where we were at in our research, I think previously we've looked at exercise in ALS and we've tried to sort of gather evidence. And what we concluded in the past was that there might be a link in some people between exercise and risk of ALS. What we did here is to try and take it further and say, using multiple different methods, try and get to sort of subgroups of people. So not just everybody, but, can we sort of narrow down the search base a little bit? And you're quite right. So we use different techniques, all of which have different advantages and disadvantages. So we use Mendelian randomization quite a lot. Mendelian randomization, what you're effectively using is you're tagging an exposure like exercise with genetics. You're using genetics as like a little hook to kind of tag it and then move that measure around. And it means that you can get very large sample sizes because I can look at a group of thousands of people with ALS and I don't actually need to know how much they're exercising. All I need is to be able to measure my little tag of exercise and then I can get an inference of how much exercise each person might be doing. I hope that makes sense. So MR is powerful, you get big sample sizes, and it allows you to talk about causality, all right? But where it fails is that genetics is not actually exercise. It's an indirect measure of exercise, and therefore you need to support it with other measures as well. And that's what we did. So we used some questionnaire measures, which have, smaller sample sizes, but is closer to a direct measure of exercise. Obviously, we could, wearables and things are other options that we sort of thinking about down the line. We also used a prospective study. So, I think what we're really seeing at the moment is population scale data sets like UK Biobank are allowing us to find people before they develop diseases like ALS and start to say, okay, they filled in a questionnaire about exercise 3-4 years ago. What happened next? And we used that as well and showed that there was a link between, the exercise they reported years before they got disease and then how quickly disease followed. And then we also I really wanted to get into what's the mechanism? If we're going to turn this into something useful for patients, a drug or a protective drug, something, We need to get at the molecular basis. And so we did a genetic study of what drives extreme exercise and how can we think about modifying that.
Jonathan, these types of real world studies, observational studies where you get your data, I mean, they're obviously really important. It's hard to think about doing a trial of this magnitude in people, a prospective trial where you have control of all the other variables. But isn't it possible when you start with data like that there's something else correlated with the exercise that's really the driver? Like, could it be, for example, consumption of energy drinks? Or could it be people who frequently get their pulse rate over a certain amount? Or people who frequently have, the traumas that we see in sports? How do you tease that apart from the extreme exercise itself?
It's a really good question. So firstly, you can't. And that's why we need a prospective study of some kind, before. And I've got some thoughts on that. But you're quite right. That's a really practically difficult problem. But of course, for the vast majority of people, exercise is really good for you. And so I think, I just want to say right now, I don't want to come on here and tell anybody to not exercise. We'll probably talk about how we linked, extreme exercise. But most people who do extreme exercise are some of the healthiest people alive. I think that's really important to outline. Could there be correlated factors? Some of the relationships we identified, it wasn't just sort of binary. We looked at a sort of a correlation. Some of the measures we used, like this strenuous sport measure, that wasn't head injury. And so I think that the fact that we saw a relationship with strenuous sport dose goes against it being something like just head injury, for example. A lot of the exercises we included in there, there's very little risk of head injury, and yet it still seemed to have the same effect there. But obviously, again, it's extreme exercises, particularly once you get into sort of professional athletes, might have all sorts of exposures, chemicals, etc. But again, they might be different across different sports. And I think our measures, what we attempted to do was isolate out that kind of exercise dose. I hope that makes sense.
Yeah.
That was great. And how did you define extreme exercise and other exercise that you included in this study?
Yeah. This strenuous sport and other exercise, which was our basic measure in UK Biobank, we actually borrowed from somebody called Jan Clementidis, who was in Arizona. And he devised this sort of as a measure that captures kind of really leisure time anaerobic activity. That's what we're going after with that, really. We defined extreme exercise. We basically took the whole of UK Biobank, 500,000 people, and we took the top 5% of that, roughly equivalent to people doing more than 6 hours of sort of very, very strenuous anaerobic exercise a week, or more than 12 hours of any exercise a week. So it's quite a big dose. Maybe this is a good point to mention. There's a study from Fang Fang, who's a researcher in Sweden, who produced this excellent study a few years ago of a particular ski race called the Velocipet. I think I've pronounced it right. I might not have done. Fantastic study. So, there's this big cross-country ski race, more than 1,000 people doing it every year. And what she showed is that the people at the very top of the race, the fastest people, probably they have about a 4-fold increased risk of ALS. So they are at higher risk in that study. And again, not so much at risk of head injury, perhaps. This is cross-country skiing. This is not downhill jumping off mountains. But the rest of the field, they were at reduced risk of ALS. So their risk compared to the background population was about half. So I think, again, that brings out some of the complexity here and supports our idea that it might be extreme exercise, but actually even goes further and says that kind of moderate exercise might actually be protective. And I think that's a really interesting idea as well, and fits with some other of our work in terms of the mTOR signaling.
Yeah, and that ties very well into my next question, which was kind of about the protective effects of moderate exercise versus the potentially toxic effects from the extreme exercise. And if you can get into mTOR a little bit more, how could this same biological pathway have such different effects depending on the level of activity in somebody?
Yeah, it makes sense. So we borrowed quite heavily from the work of Smita Saxena. So she published a paper a couple of years ago where, very sort of cell biology heavy paper, and she's looking at motor neurons derived from patients. And what she showed is that there is a mTOR signaling at the neuromuscular junction. So that's the key kind of junction between a motor neuron and then the muscle it's sort of controlling. She showed that mTOR signaling at the neuromuscular junction that is triggered by activity at the junction. So the motor neuron fires, it activates the muscle, but at the same time, it triggers this mTOR response, which then protects the motor neuron from excitotoxicity. Take riluzole. Riluzole, we think, works by protecting against excitotoxicity. So I think that fits with some other things. So she says that mTOR signaling at the neuromuscular junction is protective. And what we showed in our genetic study of extreme exercise, so not in ALS, just in extreme exercise, that there's an association with a genetic inhibition of mTOR signaling. What this means then is you've got a group of people doing the most exercise, I think from Smita Saxena's work, mTOR signaling is almost like a brake. The more activity you do, you fire the brake, and that protects you from the potentially toxic effects. But if you take the brake off, you can go faster. But then you've sort of taken that safety off. That's how I like to think of this. And therefore, the people who are kind of the most vulnerable because the brake has been taken off are actually the people who kind of most need it. Does that make sense? Again, I just want to stress that's an oversimplification. That's a model for how I explain what we've found so far. And I think hopefully it's going to guide our search as we start to think about neuroprotective compounds, etc. But most people who do extreme exercise are very, very healthy. Until we can offer individual level recommendations, nobody should reduce their exercise as a result of our work.
Okay. And you talked a little bit about correlation versus causation. This paper showed a potential link between extreme exercise and ALS in males, but not in females. Why is it important to be so careful and not say extreme exercise causes ALS based on this study? If you can go a little deeper into the difference between showing a potential link and then proving a cause.
I think the big difference is group versus individual. So most individuals who do extreme exercise don't get ALS. Now, at a group level, I think we've shown that there is a link, in my opinion. If you take a population of extreme exercises, particularly in males, there will be a higher incidence of ALS. But what we don't know is who's going to get that exercise-associated ALS. And until we can sort of tell you who, then, I'm not going to tell anybody to not exercise because we know exercise is good for you. And we know that reducing exercise in most people would be bad for you. So, the last thing I want to do is harm by asking somebody to stop their exercise when they might not be at risk. To offer that kind of recommendation, we need to be able to talk about individual level risk rather than group level risk. I think that's the key distinct. Does that make sense?
Yeah, it does. It does, for sure.
And I think,
Jonathan, let me ask one other question here in this section. So the idea here is that this particular risk factor is not by itself going to cause ALS in everyone. You've said that several times now, which I appreciate. So there's got to be some sort of maybe genetic susceptibility to it. What if there's already a group of people who are at elevated genetic risk for getting ALS, like the so-called pre-symptomatic ALS patients that Dr. Benatar has identified? Should they avoid extreme exercise?
So I don't think I can say that at all at the moment. As part of our study, we looked at the genetics of extreme exercise and compared them to the genetics of ALS. So when I say the genetics of ALS, I'm thinking about some of those risk factors that Michael Benatar has been looking at. And actually, there was almost no overlap at all. I think we interpreted that in two ways. One is that it's not that the genetic drivers of ALS and exercise are the same thing. And actually, all we're seeing here is that they're the same set of people measured in two different ways. If I'm predisposed to exercise, I'm also predisposed to ALS. I don't support that from our data. So in this study, we don't find a significant overlap between the genetic basis of exercise and the genetic basis of ALS. And so I think if you're a person with one of those risk factors, there's nothing here that would tell you that you are a specific risk from exercise. Does that make sense? I think, again, that's got to be really clear here.
Yep.
I'd pick up on the male and female thing. I think you mentioned this. So our data would support a relationship in males and not in females. However, we were underpowered, I think, in females. And so I think we caveated that in the paper and we sort of said, look, we didn't have as many extreme exercisers with females. So it is possible that we just didn't have enough statistical power there. The other option is that, we've published previously about estrogen and lots of other people have published as well, that estrogen is neuroprotective. We know that females before menopause are relatively protected against ALS, whereas after menopause, sort of the sex difference disappears. Again, there's probably things to learn there. We can't go around treating everybody with estrogen, but I do think there are things to learn there.
Okay. And how did this work tie into other studies you've done on exercise? I know there were several in the community that had participated in a virtual survey that you had sent out recently. Are there results from that tie into this in any way?
Yeah, so the virtual survey is ongoing. I think basically, if I want to sum up our research, we're trying to narrow down who's at risk until we can get to an individual level. And I think the survey is sort of trying to do that a bit more. But no, I don't have any data from that yet. The analysis is ongoing at the moment. But yeah, we started a couple of years ago looking at sort of everybody. Here, we've tried to narrow that down to extreme exercise in males more than females. If I could have my dream outcome in, however many years, would be that we could say each person, we could say, your risk of ALS given this level of exercise is this, and then you decide what you want to do with that. And ideally, if you want to exercise, we can give you something that protects you against the effects of exercise. But, exercise is a personal decision. There's tons of benefits. I think what we want to do here is we don't want to stop people doing something really positive. We want to provide them information to make decisions.
Now that we have this study, these results, what are the next steps that you see that you might want to look into? What are the next potential things that would help define the causal relationship?
I think, Dr. Bedlak hit the nail on the head when he said prospective study. That's what we want. We want a prospective study. We want to say, okay, take this group of people, we say, you do this level of exercise, you do this level of exercise, and then can we predict the outcome in a way that, again, gets round of any potential confounders? That is very difficult. And I think perhaps the opportunity will come through larger population scale data sets. I wonder about sort of, maybe doing a study specifically on those who are doing extreme exercise. But I don't have an answer to that yet because of exactly what Dr. Bedlak said at the beginning.
Jonathan, could you see a role for AI in this type of research? I mean, if we can't ever do the prospective study because it's going to be so hard to get people to do the same amount of exercise, throughout decades of their life. I mean, could you see a role for AI where you plug in all the genetic information and all the exposure information and it spits out interactions?
Yeah, it's a fascinating idea. I think you're always worried about what you said. You're always worried about confounders, aren't you? You're always worried about what's the thing that's correlated with what you're measuring that you don't know about. Yeah, that's the tricky thing. I wonder if where we go is, there's quite a lot of work in the field narrowing down subtypes of ALS at the moment. I'm thinking of some of the work out of NYGC. Maybe way we get to this is we sort of can narrow down to a smaller group of people. Thinking of Brian Trainor's paper a couple of weeks ago, looking at predicting onset of symptoms. Our study in UK Biobank, that questionnaire was done, it wasn't 40 years in advance of disease, it was just a few years in advance of disease. And yet we were still able to see a relationship between the amount of exercise and the timing of onset. So I wonder if, targeting a specific subgroup of ALS and looking at those where we've got a predicted timing of onset, maybe that's the way we do this. Because you can see in that scenario where you've already got a prediction about when symptoms might occur, then intervening and altering exercise for a shorter period of a few years might be more reasonable. And if you could see a clinical impact, if we could delay onset of symptoms based on the prediction from their AI model, then maybe that is a way forward. But I'm thinking off the top of my head here.
So there could be some lifestyle modification that occurs, or could there be some sort of therapeutic intervention that would happen in advance of ALS or during ALS? I'm just, trying to get an idea of what people could expect.
Yeah, I'd really like, again, the reason we went to the genetics of extreme exercise and started to think about mTOR signaling is because I'd like to turn this into a drug, a neuroprotective compound. How can we leverage what I think we understand about exercise to turn it into something that can be then a neuroprotective compound that could then be useful for anybody that has been predicted at risk? Or, can we somehow turn this into something that's just net positive and allows people to exercise as much as they like?
All right. Dr. Bedlak, do you have any additional questions?
No, I just have to say, Jonathan, I love that study that you talked about, that particular race. I think that may turn out to be the key to understanding things like this, is to take a cohort of people that are all engaged in the same behavior, maybe a cohort of marathon runners, or even within marathon runners, the ones who do the triathlons or the Ironmans, follow them for decades and figure out what's different about the ones that get ALS and the ones that don't. Because you're sort of normalizing the exercise variable. You're taking all extreme exercisers. You might have a better chance of finding that underlying gene that's interacting. But it's really cool. I mean, it gives me hope. I've been so sad thinking about Dr. Trainor's paper from a few years ago, where he talks about the prevalence of ALS increasing by 70%, in the next 20 years. I don't know how healthcare systems around the world are going to be able to handle that, to be honest with you. We're already straining. So my hope is that people like you will be able to figure out why people are getting this, and maybe we can knock that back. So thank you very much for joining us today. Nadia, thanks for the great questions. Jonathan, keep up the great work, and we'll see everybody next time.
Thanks, guys. Cheers.
Hi, I'm Ted Burns. I'm a neuromuscular doctor at the University of Virginia, and I'm talking today with Richard Bedlak. Richard is an ALS specialist at Duke University. Richard, among other things, heads up the ALS Untangled group, which we will discuss today. Let me mention that this podcast is supported by the CREATE Consortium, and very briefly, CREATE stands for Clinical Research in ALS and Related Disorders for Therapeutic Development. And the major focus of CREATE is to advance the science that helps with the development of therapies for ALS and related disorders. And there are currently 15 clinical sites on 3 continents and many other collaborators. And CREATE is part of the NIH's Rare Disease Clinical Research Network. Okay, Rick, let's talk about ALS Untangled. Can you start by telling us what's behind all the work you and your colleagues do for ALS Untangled?
Sure, Ted. So I realized early in my career that a lot of the patients and families I was seeing were self-experimenting with things that I call alternative and off-label treatments. I abbreviate these as AOTs and define them as treatments that are advertised to slow, stop, or reverse ALS without what most scientists would consider to be very good evidence. As you probably know, the internet is full of these things, and there's really no fact checkers there. So people selling AOTs can say pretty much whatever they want about them. They often refer to them as proven or perfectly safe, and these kind of claims might be backed up by flawed data. But non-scientists are not always so good at recognizing the flaws. So I decided to put together a team of clinicians and scientists from all over the world that would systematically review these AOTs and try to help patients and families make more informed decisions about them.
Okay, thanks, Rick. It's a great service that you all provide, not only for the patients and families, but for us who are trying to take care of these patients and counsel them. And let me just mention that the FDA does not address any of these alternative or off-label treatments. That's correct still, right, Rick?
It is correct. So most of the things that are being sold on the internet in the category of AOTs fall into something called generally regarded as safe, GRAS, by the FDA. So that means that the FDA looks at them and says, this is probably something safe, and the company that's selling it is not trying to make any therapeutic claims, so we'll just let them have it, as opposed to a prescription medicine, which has a label that says that it works for XYZ.
Oh, okay. So how do you and your colleagues decide what unproven, off-label, alternative supplements and or treatments, prescriptions should be analyzed?
Good question, Ted. So patients and families suggest AOTs to my team through either face-to-face meetings. So one of your patients might ask you about something and you'd forward that on to me, or through email or through Twitter. And whenever I hear about one of these things that I didn't know about before, I put it on our website under something called Open Reviews. Our website is www.alsuntangled.org. Turns out we've accumulated so many of these open reviews that I realize I'll probably never get to all of them in my lifetime. So I added a vote button next to each one. And a person that goes on our website and looks at some of these things and has a few that they're interested in could just click that button. It doesn't cost anything. And you'll see that that particular AOT moves up on the list. We try to prioritize our reviews by the number of votes each one gets, but there are some other factors too, such as the availability of disclosable information. If we can't find any disclosable information about an AOT, we really can't write anything about it.
Mm-hmm. That makes sense. And anybody can vote, and presumably they're mostly patients and families, loved ones. Is that right?
Yeah, I don't have any way of knowing who's voting. We did build a filter. We realized early on that we didn't think of something. Actually, a patient suggested to us that somebody could just go on there and just keep clicking the button next to one of the AOTs over and over again. So one person could account for 1,000 votes for something. So we figured out how to keep that from happening. So you're only allowed to vote for each one of the AOTs once. We've got a filter built in that detects what computer you're using. You can vote for several different ones, but only for one particular one time.
Okay, great. I mentioned this earlier, how much I appreciate these publications because they really help me in my clinic when it comes to making recommendations and counseling the patients. As we all know, we don't have a cure right now for ALS, and ALS is a terrible disease. So there is a willingness for trying alternative, off-label, unproven options, and I think that willingness is appropriate. So helping us navigate that with these ALS Untangled publications really strikes me as extremely important. And I want to talk about how you all grade based on 5 things. I really want to talk about the outline of your publications, I guess. I found the text to be very helpful, but in the end, you grade based on 5 things. And I want to talk about each of these. One is mechanism of action. Another is the preclinical evidence. A third section or category is cases. Fourth is trials. And fifth is risks. And so I thought we'd just talk about each of these. So Rick, what is mechanism of action and how do you grade that?
Yeah, so this section of our reviews focuses on what the AOD is proposed to do. Is this something plausible, or are we going to have to rewrite the physics and biology books to account for it? Also, has this AOT, ever been shown to do what it's supposed to do in human beings? So to give you some examples, energy healing is something we were asked about. This gets a poor mechanism grade because there's really no proof that a human being can generate any kind of healing energy from their hands. On the other hand, methylcobalamin gets a really good grade because it has been shown to lower levels of a neurotoxin called homocysteine in human beings.
Rick, I have a friend who practices Reiki, and I think she'll be disappointed with what you said about energy healing, which I think is Reiki. Is that right?
It is, and it's important to recognize that just because something gets a poor grade in one of these categories doesn't mean it wouldn't be a useful treatment. You know, science evolves, right? So 100 years ago, we thought epilepsy was caused by evil spirits, and, we gradually learned that that's nonsense. And maybe someday somebody will prove that certain human beings can generate healing energy. But for right now, we have to give that a poor mechanism grade.
Right. That actually raises another issue here, and that is what the outcome measure you're trying to improve. And you guys aren't talking about improving quality of life. Reiki may help with quality of life. Some of these things may help with quality of life for whatever reason, but you're speaking about altering the trajectory of disease progression, right?
Exactly, Ted. So, we decided early on not to focus on symptomatic therapies, which we all agree are important. We decided to focus on things that were being claimed as slowing, stopping, or reversing the progression of ALS.
Okay, perfect. So that was mechanism of action. Can you comment on what preclinical means?
Yep. So here we're looking at whether the AOT has ever been used in any kind of ALS model, like a cell culture or an animal model. The more rigorous the studies in the models, the better the grade in this category.
Great. And the section and grading on cases, could you talk about that now?
Yeah, so in my opinion, this is probably the one where we usually have the most information, and probably the one that's most influential to patients and families is what happened to other folks that were trying this. So here we're trying to compile all the stories we can find of individual patients who reported taking this AOT. And we give a better grade when we can actually get medical records on each of these folks to prove that they really had ALS and that they really improved on some objective outcome measure.
Okay, thanks. And what about trials?
So here we're compiling all the different human ALS trials involving each AOT. Unfortunately, as you know, it's very rare that there are any human trials of these things. Many of them are not owned by a company that has any sort of financial interest in them, so there's not a whole lot of interest in putting them through a very expensive clinical trial pipeline.
Okay, and lastly, could you talk about the section dosing, risks, and costs?
Yeah, here we're trying to give folks some idea of the severity and the likelihood of the different side effects that might be seen with this AOT. So an AOT that could cause death or hospitalizations or has a high frequency of side effects in general would get a low risk grade. Also here, we're trying to let folks know how it might be dosed for ALS and how much dosing it that way would cost. So some of these AOTs cost hundreds, some cost thousands, some cost hundreds of thousands of dollars a month.
Okay, and that's all pretty self-explanatory, that last part at least. So as I'm reading your publications and thinking about the patient and what I might recommend, especially if he or she were to ask, I'm also considering to some extent the convenience or inconvenience and the impact on quality of life, or my estimated thoughts on impact of quality of life of that treatment. And I can think of one of the treatment regimens that involves about 45 things, and we'll talk in another podcast about that one, many of which seem inconvenient to me and I would think could negatively impact quality of life, or certainly would have the risk of impacting quality of life. So do you factor convenience or inconvenience in your analyses?
We do, in terms of trying to give people an idea of how complicated the dosing regimen is. But I think that ultimately only a patient and family can decide, how much they're willing to put up with. So our real goal is to try to give them information, enough information to make an informed decision on whether they want to try this thing, not to make the decision for them.
Yeah, that's a really good point. Okay, Rick, any final comments?
Yeah, Ted, we're always looking for ways to improve our program. In fact, it actually looks a lot different now than it did when we started 9 years ago. And a lot of the changes that we made were due to suggestions from patients, families, and colleagues around the world. So these podcasts are an example. This was actually a suggestion from another physician. And we hope, that these kinds of changes will make the program easier for patients and families to use. So if anybody listening has any other ideas, just feel free to email or tweet them out to me.
Okay, Rick, thanks. I think it's terrific right now, but I'm glad you're open to other ideas. So in our next interviews, we will focus on a few specific treatments or unproven alternative treatments. Again, I've been speaking with Richard Bedlack from Duke University. Thanks, Rick.
Thank you.
Hi, I'm Ted Burns. I'm a neuromuscular doctor at the University of Virginia, and I'm talking today with Richard Bedlack. Richard is an ALS specialist at Duke University, who, among other things, heads up the ALS Untangled group. Let me mention this podcast is supported by the CREATE Consortium, and the major focus of CREATE is to advance the science that facilitates development of therapies for patients with ALS and related disorders. Rick, before we begin, let me also quickly mention to please listen to our introductory interview that provides background on the ALS Untangled project. Could you just give us a quick reminder of the rationale behind the work of ALS Untangled?
Sure, Ted. So ALS Untangled systematically reviews alternative and off-label ALS treatments, things I call AOTs. Topics are suggested by patients and families. Our international team of investigators has a very regimented approach to how we gather, summarize, and ultimately report on all the data we find. All of our reviews are available to patients and families for free on our website, www.alsuntangled.com, and we hope that these will help patients and families make more informed decisions.
Okay, perfect. And today we're going to discuss one of the ALS Untangled publications, and this one is publication number 41, which is about a treatment regimen referred to as the Eric is Winning treatment. Before I ask any questions about that, Rick, I've read these publications in the ALS Disorders peer-reviewed publication, but are they all available online?
Yeah. So every one of them is available on our website. So if you go to the alsuntangled.com website and just go under completed reviews, you'll see the names of all the ones we've published and you'll see the grades. And if you just click on the name, it opens up a PDF of the review itself for free.
Okay. And the one we're going to talk about today is number 41, the Eric is Winning treatment. So first, Rick, could you give us a little background on Eric Edney and the Eric is Winning regimen?
Absolutely, Ted. So this was one of the first treatments that we were ever asked to review 8 years ago. It took us a while to get to it because I thought, one of the key parts of this was actually finding Eric, or at least finding his medical records. And we eventually did learn that Eric had passed away, not from ALS, but we did find Karen Tussler, his daughter, who was nice enough to send us his medical records. And so we learned that this regimen is a large cocktail of different things invented by Eric Edney, who himself was not a scientist or a doctor. He was an insurance agent, and he put these things together based on his own research to treat his own condition. And the medical records that we received, we were able to confirm that he really did have ALS. There was enough there for us to be sure that he had it. And he certainly did have a very slow progression. He lived with the disease for 21 years.
Right. And could you comment on that length of survival with ALS?
Yeah, so lots of folks think that people with ALS always have a very rapid, straight line progression in the disease where every day they're a little worse than they were the day before. But that turns out not to be the case, and it creates a lot of confusion. So the natural progression of ALS is very different between patients. Some folks have this disease for only a few months before it takes them, and others have it for many decades, like Stephen Hawking. And progression in an individual patient is also variable. So sometimes it can spontaneously slow down. Sometimes it can stop. Like I've got some patients that don't seem to have changed for a few years. And sometimes it can even reverse with some improvements in motor function, at least for a short time. So it's really impossible to look at something that happened to one person with ALS and know that it was the result of any treatment they might have taken. It could very well just be the natural history of the disease. One of the key things about our ALS Untangled review of Eric is Winning is Eric's progression rate was very slow before he ever started his complicated regimen. And there really wasn't any clear evidence that the progression rate changed on the regimen. So I think this observation casts even more doubt on the assertion that his regimen was in some way responsible for his slow progression.
Okay. As you mentioned, there are many components to this regimen, and I think the way you all tried to handle it and break it down makes sense to me. And it just seems like the only way to discuss this regimen is by focusing on some of the specific treatments. And so that's what I want to do. Some seem more plausible in terms of efficacy than others. I mean, I feel that way, and I think the ALS community would feel that way. And I wanted to start by talking about one that I think most ALS experts think is less plausible, but still something out there that's often discussed, and that is metal exposure, such as mercury exposure from dental fillings. Could you comment, Rick?
Yeah, so we actually reviewed this topic previously in one of our reviews, and this was one where we actually went out and investigated a specific chelation clinic to see what was happening there, but also took on the whole idea of metal being able to trigger ALS and the utility of chelation. And in that review, we say we found no evidence that any kind of metal exposure, including mercury from amalgam fillings, could really cause a condition that looks much like ALS, and therefore there's really no plausible way that chelation could help. And in fact, in looking at some of the patients that were in that chelation clinic, we really saw no evidence that that treatment was changing the trajectory of their ALS in any meaningful way.
Yeah, I want you to comment a little bit more on chelation and detox, and if it's appropriate, maybe we'll do an entirely different podcast interview on that. But could you make some general comments on your thoughts and the group's thoughts on detox and chelation in general?
Yeah, well, so chelation is a way of taking metal out of the body. And so the only way that would be a reasonable treatment for ALS is if there was some evidence that metal could cause ALS, and there isn't. So it doesn't really make any sense to take on a treatment like that, especially one that's known to be associated with risks, including death, when there's really no plausible way that it could work. And the same thing's true of detox. There's really very little evidence for any sort of toxic cause for ALS, at least not one that could be easily removed from any kind of detox protocol that's out there. So if there's no plausible mechanism for it, we really don't recommend that people use it.
Now, let me ask one more follow-up on that. In my experience, I've had a few patients who have done chelation, but it's a small number, but it's been really, really tough on their bodies, and it's something that they regretted down the road. Could you make a comment on what your experience has been? And I'm not talking specifically about the ALS Untangled view, but I'm talking about, Rick, what your view is as an ALS doctor for the last two and a half decades.
Yeah, so I've seen now more than 2,000 unique patients with ALS in my career, and I would say I had a small number that I know of that were attempting chelation or detox or both. And by a small number, I mean less than a dozen. And again, I saw no positive benefits, no obvious slowing, stopping, or reversing of their ALS associated with those things. Now, I don't recall any of those particular patients having side effects, but certainly if you look in the literature, chelation can be associated with some pretty severe side effects, including death.
Okay, so Rick, could you talk about what seems like one of the most mechanistically plausible parts of the EIW or Eric is winning regimen, and that being the B12 injections?
Absolutely. In fact, we wrote a previous ALS Untangled on this specific treatment as well. But there's quite a few ways that injected methylcobalamin, which is a form of B12, might help a person with ALS. So these include modulating inflammation and oxidative stress and lowering circulating levels of a neurotoxin, which is called homocysteine.
Okay, so Rick, how did you guys at the ALS Untangled group grade B12 injections? Or could you talk a little bit about the data or your thoughts?
Yeah, so in our prior review of injected methylcobalamin, we gave it really high marks for mechanisms and also for safety. A mediocre preclinical score and low scores, unfortunately, for cases and trials. And this is because, in our opinion, the human trials that were done over in Japan have several major flaws which really limit what we can learn. And these need to be replicated with a much better design.
Okay, and I've had a few patients request daily vitamin B12 injections, and I have a fairly limited experience with it. But if I recall correctly, the treatments were very expensive, and I had trouble with the insurance payers, their willingness to cover the cost. And I'm really not sure about that now, but could you comment on the cost of B12 injections?
Yeah, so in our review, the cost of injected methylcobalamin at the dosages used in the trials would be about $300 a month, and we think it's unlikely that insurance would cover that.
Okay, and when you say methylcobalamin, that's fairly synonymous with B12, just to be clear.
Yeah, it's like a B12 precursor. Yeah.
Yeah, okay.
That was actually studied, over in Japan.
Right. Okay. So should we worry about toxicity from B12? And while I'm at it, should we worry about toxicity from the other vitamins mentioned in the EIW regimen?
Yeah, it's a great question, Ted. So I think many people think that vitamins and, natural products are perfectly safe. B12 probably is quite safe, but large doses of other vitamins definitely carry risks. So for example, there's a vitamin called B6. If you get too much of that, you can develop a really painful neuropathy, problem with the nerves in your hands and feet. Vitamin A, if you get too much of that, your brain can swell, your bones can thin, your blood pressure can drop, and you can damage your liver. And vitamin E, if you get too much of that, you can have trouble with your blood clots, and also you can have trouble with just generalized weakness. So, there's a lot of vitamins that are not perfectly safe in large doses.
Okay, and I want to talk about what other items or components of the EIW regimen may be worth considering, but I want to start by just asking you to comment on probiotics, or what are called in your paper natural antibiotics like garlic and oil of oregano.
Yeah, I don't think there's much data to suggest that garlic and oregano would be very useful, but there are several other individual components of this large Eric is Winning regimen that are interesting that we think have potential. Those include vitamin D, alpha lipoic acid, glutathione, growth factors, exercise, and even a positive mental attitude. All of these things have some data suggesting that they could be associated with an improved progression rate, but of course they all need to be studied further individually. You asked about probiotics, and that's actually something I'm becoming more and more interested in, the possible effects of the microbiome, the family of bacteria that live in the gut, on ALS progression. So there's now pretty clear evidence that alterations in the microbiome can cause GI illnesses. And there's some really interesting data, including some that I just saw at the International Symposium in Boston a couple of weeks ago, suggesting that the microbiome could influence neurodegenerative diseases like ALS. I think we're going to hear a lot more about this in the next couple of years. I know, for example, that there are several groups that are gathering stool samples to look at the microbiome of patients with ALS to see if it's any different than the microbiome of healthy patients.
Okay, we should probably talk about some of this, if not today, then in the near future. But let me mention we are recording this on December 20th, 2017, so that's worth keeping in mind. So as I'm listening to you, I'm thinking, gosh, should my patients be taking vitamin D? Should they be taking probiotics? Are you in a position now, Rick, where you could give a December 20th, 2017 comment on that or recommendation?
Well, I'm pretty convinced that there's enough efficacy and safety data on vitamin D to justify our checking it in every patient with ALS and supplementing it if we wind up with a level that's low. So there are now several papers that suggest the relationship between low vitamin D and faster ALS progression. And those come on top of data that we knew about for years that tell us that people with low vitamin D who fall are much more likely to break bones. And, vitamin D is cheap. It's easy to take. There's really little chance of any side effects if you keep the levels, within the normal range. So, typically what I do is try to get people in the 30 to 50 range. And so oftentimes when I check the vitamin D levels, if they're a little bit low, I'll start people on either 2,000 or 4,000 units of vitamin D3 a day. But it is something I've started to do in all my patients with ALS now, check their vitamin D levels and get them up into the normal range.
That's a really good point. I don't know if we all do that, but that's certainly something that we should all be thinking about. And what about probiotics? What if I were a patient or loved one and said, should I go to the grocery store and pick up some probiotics?
Yeah, it's not something that I'm currently recommending because I really want to see if there's any, plausible mechanism. And it's kind of like what we talked about, with metals and detox, right? So this would have to all start with a finding that the microbiome was different in people with ALS, or at least people whose ALS was progressing faster. I think if that gets established, then all of a sudden there's a plausible way that things that alter the microbiome, like probiotics, could work. But right now we don't even have that, first piece in place. We don't have a plausible mechanism yet.
Mm-hmm. Okay, so we've talked about some specific components of the EIW regimen. And now, Rick, could you summarize your grades and conclusions for the entire regimen, the EIW Eric is Winning regimen?
Sure. We gave it a mechanism grade C because we thought some parts of it were plausible. We gave it preclinical and trial grades of U because this thing has never been tested, either in animal models or in people with ALS. We gave it a cases grade of D because we could only find the one person, Eric, that tried this, and it wasn't clear to us that it helped him. Again, his progression before he ever started this was very slow. And finally, we gave it a risk grade of D because at least one part of it, chelation, can result in death.
Okay. Any final comments?
Yeah, so you didn't ask me about cost. We estimated that if you wanted to really follow this complicated regimen, it would probably cost you around $40,000 a year. And again, it's unlikely that insurance would pay for any of this. So putting it all together, we really didn't find much to justify the use of this difficult, expensive, and potentially risky treatment for ALS.
Okay, thanks, Rick. I've been speaking with Richard Bedlack at Duke University. Thank you. Hi, I'm Ted Burns. I'm a neuromuscular doctor at the University of Virginia, and I'm on the phone today with Richard Bedlack. Richard is an ALS specialist at Duke University. He heads the ALS Untangled group. Let me remind listeners to listen to our introductory interview that provides background on the ALS Untangled group if you have not yet done so. This podcast is once again supported by the CREATE Consortium. And briefly, CREATE stands for Clinical Research in ALS and Related Disorders for Therapeutic Development. And the major focus of CREATE is to advance the science that helps with the development of therapies for patients with ALS and related disorders. And it's made up of currently 15 clinical sites on 3 continents and then many other U.S. and international scientists and collaborators. And CREATE is part of the NIH's Rare Diseases Clinical Research Network. Okay, today we're going to discuss one of the ALS Untangled publications, and this one's number 42, and it is about Elysium Health's BASIS therapy, and BASIS is spelled capital B-A-S-I-S. And this product is marketed and sold by Elysium Health. Rick, before I ask you some questions about it, remind us how patients and other listeners could read your publication number 42 on this product.
Yeah, you bet, Ted. All you have to do is go to our website, www.alsuntangled.org. And if you want to see the reviews we've already published, including this one on BASIS, just go to the section of the website called Completed Reviews and click on the name of the AOT, the alternative and off-label therapy that you're interested in this case, BASIS, and the article will pop right up for you.
Okay, thank you. All right, so BASIS, again, sold by Elysium Health, and it is made up of 2 main ingredients. One is called nicotinamide riboside, and the other one is pterostilbene. Okay, so those are tough words, tough for me at least. And I might shorten nicotinamide riboside to NAR for the purposes of this podcast. And while I'm at it, let me mention that pterostilbene is spelled Pterostilbene, and that's not an easy word for me either. Okay, Rick, what's the purported therapeutic mechanism of NAR and the mechanism of pterostilbene?
So NIR turns out to be a precursor to something which is called NAD+. NAD+ in turn is involved in cellular energy production, and also by influencing other chemicals in cells, it can change the patterns of genes that are turned on and change how the cell responds to oxidative stress. Pterostilbene is a naturally occurring antioxidant which is found in blueberries. So all of these things that the ingredients of BASIS do, they're all plausible. I mean, they have plausible mechanisms, but they've not yet been proven to be part of ALS progression.
Okay, and so how did you grade the mechanism? I forget how you graded it.
Okay, we actually gave it a D, and that's because it acts on a biological mechanism, but it's not clear that this mechanism is relevant in ALS.
Okay. All right. Rick, are there any cases online or any trials using this BASIS supplement that you'd like to mention?
Yeah, so this is one of the few times, Ted, when we found absolutely nothing as far as preclinical data or case reports. Nobody out there was taking BASIS, at least that wanted to talk to us, and we found no clinical trials in people with ALS.
Okay, and when was that published? Do you remember what month you published this?
It was published September 18th, 2017.
Okay, and we're talking December 20th, 2017. Okay, what about safety and cost?
So there was a small short duration trial that was done in healthy volunteers by the company, and it showed no deaths or hospitalizations. So that's good news. But remember, it's not been studied in people with ALS. So we really don't know what the side effects might be in that population. Good news is it doesn't cost very much. It's $1 per capsule. And the company says their recommended dose is 2 capsules per day.
Okay, your last comment raised a point that we haven't made, and I don't want to pick on BASIS to make this point, but I do think it's an important point. You know, when we think of some of these alternative treatments, we think about whether they help or alternatively do nothing, but I guess it's possible that some of these treatments may actually speed up disease progression. There's no evidence of that for BASIS, but could you comment on that worry that you all may have?
Yeah, so if you look at the history of ALS trials over the past 100 years, There's only been really 2 drugs that are associated with even a single positive ALS trial, right? So Riluzole has multiple positive trials, and Radicava has 1 very small, highly selected, short-duration clinical trial. Most of the other trials that we did either didn't do anything at all, or in some cases made people get worse faster than patients on placebo. So I can think of 2 trials that just happened in the last few years. So minocycline was one and topiramate was the other, where patients who were taking those actually got worse much faster than patients on placebo. So this is part of why we worry. I mean, minocycline and topiramate, they're drugs that we've been using for a long time in people, and we didn't think they would possibly do anything bad to folks with ALS. We thought they were pretty safe. And it turns out, we learned something surprising when we actually gave them to people with this disease. So the lessons I take away from that are we never know until we try it in people with ALS what it's going to do.
Right. Thank you. My understanding is that Basis is a tablet or some sort of pill, and it should be pretty easy to take for the patients. And I think you mentioned it's recommended twice a day by the company. Can it be given by feeding tube? Do you know?
It's a good question. The answer is we don't know. There isn't any person out there that I ever found that was taking it that way. I didn't see anything, on the website saying that the company studied it that way. And, one thing that does often come up with these sort of recommended dosing regimens is, well, how did the company decide on that? And in this case, they decided on it based on a study that was done in healthy human volunteers. So at that dose, they were able to measure that it did actually elevate NAD plus levels in the blood of these healthy human volunteers. So at least there's some rationale behind the dosing regimen here. Some of the other things, there really was no rationale. It was just sort of started this way, and that's the way it's recommended.
Okay, and so what did your group conclude about Elysium Health's Basis?
Well, we think it has interesting potential mechanisms, and it's not very expensive, but there's just too many unknowns. There's no preclinical data, there's no case reports, we really don't have any trials. So in the end, I personally would not recommend that people with ALS try this. I mean, I know that we all have different ideas, and I would say if there's somebody out there who was more impressed by this and they were going to offer it to their patients just based on the mechanisms, I would hope they would at least convince their patients to systematically gather, safety and efficacy data, maybe on a website like Patients Like Me, so we could learn more about this AOT and maybe update our review in a year or 2.
Yeah, that's a great point also. I was going to ask you next if I called you and said, hey, Rick, I'm thinking about this treatment. Would I be crazy to recommend it to my patients? I think you've kind of answered that. But if you do have a patient who comes to you and says, I'm doing this, do you, or whatever it might be, whatever this alternative treatment might be, do you ask them to consider putting their information on Patients Like Me?
I do. I think that, it's easily understood why people with ALS self-experiment. That doesn't bother me. What bothers me is that we don't know the results of most of the self-experiments that have happened, out there in the past 100 years because nobody ever recorded them. And the only place I know of right now where it's really easy to record an infinite number of individual patient self-experiments is on the website Patients Like Me. The infrastructure is all there. It's free for patients to do it. We can come back in a year and we can say, okay, how many people with ALS actually took Basis and recorded their information on Patients Like Me, and what did they say about it? So I think, it would be a tremendous resource for the whole community of clinicians, scientists, and patients if people would actually record the results of the self-experimenting that they're doing.
Right. I think that's a great point. Okay. Any final comments about the Basis alternative treatment?
No, I mean, I was pretty excited when I saw the mechanism of action because I've not seen another AOT that has this proposed mechanism of action and also has biomarker data from healthy volunteers. But as I said, it was disappointing after that. We really didn't find much of anything to hang our hat on. So hopefully if we come back in a year or 2 and look at this again, there'll be more out there.
Okay, let me try to pin that down a little bit more. So when you say maybe a year or 2 from now, there'll be more out there on it, are you speaking of the patient-reported websites like Patients Like Me, or do you think the company might do a trial, or do you think the NINDS would support a trial? Where do you think this evidence, or real-world evidence at least, may come from?
Yeah, I mean, I know that there are going to be people with ALS who try this. I just hope they record what happens to them somewhere so that we can find it. And yeah, I think it would be terrific if the company decided to do a trial in patients with ALS.
Yeah, I guess as I'm listening to you, Rick, I'm thinking if Patients Like Me reported fairly good data, promising data, that maybe then a randomized control trial would be performed by others. But so you're right. I guess it may I don't know if it starts with websites like Patients Like Me, but it certainly could facilitate us all understanding better what we should or should not be recommending to our patients. So
yeah,
really
like we talked
point.
about, Ted, I mean, it's happening, right? Self-experimentation is happening. Most of our patients are self-experimenting, but they're not recording their information anywhere. So I think this is something that ALS docs need to get better about is, opening up the avenues for discussion, helping patients to understand that we know they're doing it. We're open to it. We're open to talking to them about it. We're open to working with ALS Untangled, and we hope that they will record their information somewhere so that everyone can see it.
Yeah, I'm sorry, I'm still stuck on this. You're absolutely right. And you raise another good point that we probably need to remind patients that we're open to discussing or to them trying various things. Sometimes I think patients are afraid to tell us. Has that been your experience?
No doubt about it. And again, when I first opened this clinic, I felt like I had a really good rapport with my patients, but I was surprised when I learned how many of them were actually doing this and not telling me. And I think it's because they've had bad experiences in the past. I mean, I still think that many doctors handle these AOTs in a very paternalistic way. They just kind of, look down on them and say, this is a bunch of garbage. And the reality is, how do you know that? I mean, unless you actually test these things, unless you put them under the microscope like we're trying to do with ALS Untangled, how do you know? Maybe there is a pearl in all this somewhere that really is helping people. And it's disrespectful. It's disrespectful to patients to have that attitude. I mean, patients and families spend time trying to figure out what they want to take. And, they come in, they have an idea, and you shouldn't just shoot it down without really doing the work to see if it means anything or not.
Great. That's another really important take home, I think, from this. Okay. Thank you, Rick. Again, I've been speaking with Richard Bedlack from Duke University. Thanks so much. Hi, I'm Ted Burns. I'm a neuromuscular doctor at the University of Virginia, and I'm on the phone again with Richard Bedlack. Richard is an ALS specialist at Duke University, and he heads the ALS Untangled group. If you have not yet listened, please consider listening to our introductory interview that provides background on the ALS Untangled group. And once again, this podcast is supported by the CREATE Consortium, which is focused on advancing the science that facilitates the development of therapies for patients with ALS and related disorders, and we appreciate their support. So today we're going to discuss one of the ALS Untangled publications, and that's number 43, which is about copper. And Rick, really quickly remind the listeners where they could read the details of this publication.
You bet. So all of our reviews are available for free on our website, www.alsuntangled.com. Just go to the section that says completed reviews and click on the name of the alternative therapy that you're interested in this case, copper or copper ATSM.
You said .com. I think you meant .org.
You can use either one. So we own the domain names for alsuntangled.com, .org, and .net.
Okay. All right. So let's talk about copper and a copper complex called CuATSM, which would be copper ATSM. Rick, first about copper. Before we get into it, are we talking about copper by mouth or intravenous copper?
So, Ted, we were specifically asked about and therefore focused on oral copper. But as far as our conclusions go, I really don't think it would make a difference. And I'm sure we'll get into that in a couple minutes.
Okay. And is the same true for the copper complex?
So copper ATSM is a very special copper complex that would be taken by mouth.
Okay. All right. Well, let's jump into the potential mechanisms of action. And let's start with copper and why that might be of interest to the ALS community.
Yeah, so copper turns out to be a really important mineral for the nervous system. Severe copper deficiency can cause the death of motor neurons, and that creates a picture that looks a lot like ALS. And because of that, many of us check copper in the workup of ALS, and unfortunately, it almost always comes back normal. But some people with ALS might not have copper deficiency. They might have copper dysregulation. In other words, although their copper levels were normal, this metal might not be going where it's supposed to go. Now, why would this happen? Well, some might have it because of mutations, like mutations in the SOD1 gene. Others because of problems with their copper transporters. So it turns out that the regulation of copper in the central nervous system is very complicated and depends upon a whole bunch of different transport proteins. When copper doesn't go where it's supposed to go, proteins in neurons might misfold and form clumps. And the mitochondria, which are the power plants of our cells, may fail, which would then cause impaired energy production and increased oxidative stress. So given the complexity of this problem, I hope you can see that just simply taking plain old copper, either orally or IV, is pretty unlikely to help people with ALS who have normal copper levels. All that extra copper is still not going to get where it needs to go if the problem is dysregulation.
Okay. And could you talk about copper ATSM?
So copper ATSM is like a copper smart bomb. We've got evidence from human beings that this special molecule that the copper is attached to actually allows it to target cells in need within the brain. So it can actually get into the most abnormal motor neuron regions in the brain where it might actually be able to do some good.
Okay, that sounds promising. You wrote that there's no preclinical animal model evidence for copper supplementation, but what about this copper ATSM?
Yeah, so it turns out there's a lot of studies. There's actually 6 studies published in which copper ATSM was given to animal models of ALS. And in every one of these, the compound was able to delay disease onset and prolong survival, sometimes really dramatically. So because of this, we gave copper ATSM a very high preclinical grade in our table of evidence.
Okay, how about any human trials for copper or copper ATSM?
So nobody's ever tried plain old copper supplements, and again, for good reason, but there is one active trial of copper ATSM out there. It's going on in Australia, and we don't have any efficacy results yet. We do have some safety results, and again, those were just presented at the International Symposium in Boston in December 2017. A very small number of patients, 24 patients that were on dosages of up to 72 milligrams a day, in some cases for a few months or less, but there weren't any serious adverse events that were thought to be related to the treatment. So that's good news.
Yeah, that does sound like good news. Okay, and let me mention we are taping this on December 20th, 2017. So that's pretty recent data that you're talking about. And so that's what we know about the risk of copper ATSM. What about copper? What do we know about risk of just copper supplementation?
So copper supplements themselves are probably safe as long as they're in a reasonable range, like in the 1 to 2 milligrams per day. There is some evidence that very high doses of copper, like in the 30 to 60 milligram per day range, especially over a period of time, like 3 or 4 years, can really damage your liver.
Okay. So certainly the copper ATSM sounds somewhat promising. Let me ask you about the cost now, and then I kind of want your thoughts as they exist on December 20th and what your conclusions were from the ALS Untangled. But one of the disappointing things that I read in this publication was about the cost. Could you comment on cost?
Yeah, so oral copper is cheap, less than $1 a month if you want to supplement, in the range that we talked about, 1 to 2 milligrams per day. But copper ATSM, so far it's really been manufactured in small batches, and that's because it's not ever been used as a medicine before. It's used as an imaging tool to image tumors, to look for hypoxic regions within tumors in the central nervous system. And so because it's only made in small batches, it's very expensive. So if you wanted to take this in a reasonable dose, it would probably cost you in the range of $9,000 a month or more. And again, I don't think any insurance company would pay for somebody with ALS to take this right now because there just isn't any data that it works.
Okay, yeah, that is disappointing. So if I'm listening to this interview in 2018 and I don't have $9,000 a month for copper ATSM, knowing that it's not been shown to be efficacious yet, but at least there's some excitement with regard to mechanisms and I guess side effect profile. What should I be on the lookout for? Do we have any idea when a trial might be, the information may be published, or was that trial designed for efficacy, the one in Australia, or was that only a safety trial? What can you say, Rick?
Yeah, it is. So it's ongoing, and I think we are going to be able to get some hints of efficacy. The one thing that I didn't see from that trial, which is a pretty important question, is whether this is going to help people with and without SOD1 mutations. So this, as we talked about, has really strong preclinical data from the SOD1 mutant mouse model of ALS. We don't know that anything that we do in that model translates to people. We don't know, especially if it translates to people who don't have SOD1 mutations. And, the strongest biological evidence for the role of copper is in the SOD1 protein, where loss of copper from that protein causes a massive problem with misfolding. And so we just don't know. I think one of the things that I wanted to see from that trial is that they were enrolling a certain number of people with and without SOD1 mutations. And it wasn't clear to me from the presentation that I saw recently that that was true. So I guess, time will tell. I actually think that this has so much exciting preclinical evidence that you may wind up seeing another group do a copper ATSM trial. I would certainly be interested in doing one if I had the money.
Okay, now you talked about SOD, and if I were a patient or a loved one and I'm listening and I'm thinking, gosh, do I have an SOD mutation? Could you first comment on how often patients do have SOD mutations and maybe break it down to people with what we have called sporadic ALS in the past and patients who seem to have a family history of ALS?
Yeah, so about 10% of the patients in our clinic have a gene that's causing their ALS. And, we used to call that familial ALS, and now there's some debate about that term. Maybe genetic ALS is a better term because not all those people have family histories. The rest, 90%, we don't have an obvious genetic cause for their disease, although we do keep discovering new genes. It seems like now every few months somebody discovers a new ALS-causing gene. So, we may eventually move from 10 to 11 or 12% of our patients that we can explain by an abnormal gene. So, there's a lot of discussion right now about should we be offering genetic testing to all of our patients? What should we say? So Ted, in my practice, I do offer it to everybody. And the way that I present the option is I say, look, it's really quite easy to do genetic testing now, and it's not even very expensive. There's companies out there, who pre-authorize it with your insurance, and, they'll call you if the cost is more than a couple of $100s, and you'll have an option to bail on the test if it's too much. There's even groups out there like Create who are offering protocols where patients can get free genetic testing. And we're talking about the Cadillac of genetic testing, whole genome sequencing. And so why would a person want to know this? Well, I think we're on the cusp of having specific treatments for people with different mutations. So I think you're going to see antisense therapies for very specific genetic mutations. I think you might eventually see a CRISPR study where we can rearrange a gene. And I think this is another example. Copper ATSM might wind up being a treatment that works great for people with SOD1 mutations and maybe not so well for everybody else. But I think, we're at a time when it's easy to get. It gives you a lot of information about why you got it. Families are interested, and it prepares you for the next couple of years when we're going to see some treatments for specific subsets that I think could be quite effective.
Yeah, and I took you on a detour here, but I think it's a really important point. I think another really important point is deciding when a genetic counselor needs to be involved before genetic testing is done. And could you walk us through what you do, Rick, at Duke, and both for symptomatic diagnosed ALS patients and for, say, the patients who may be at risk because they have a first-degree relative with ALS?
Yeah, it's a great question. I don't think anyone has the answer yet. So I can tell you, I offer every one of my patients the option of genetic testing, and they can get it either through a commercial lab, or I explain to them that there are studies around the country that are open that they can enroll in and get free whole genome sequencing. And I say there's pros and cons. The pros are you have the potential to learn why you have ALS. Your family has the potential to learn what their risk might be, and you have the chance to get ready to know what subset of ALS you might have and get ready for some of these treatments that are coming out that I think are going to be very exciting. The downsides are, if you do this outside of a research study, you will get a bill. The bills are much cheaper than they used to be, but you probably will get a bill. And two, right now, it doesn't change the way we manage things. And I would say the majority of my patients, after hearing that conversation, do opt for genetic testing. So the great majority of my patients now, I know what their genotypes are. Now, it's a whole different story if you don't have ALS yet. If you're a family member or there's another patient with ALS, the risk-benefit ratio is different. So the potential benefits, they're uncertain. So some of these genes don't have complete penetrance. So if I do this and I find out that you have a gene that might cause ALS someday, that's a big load psychologically when we really don't know for sure that it will. And two, we don't know that the drugs that we're developing are going to be useful in preventing the disease. That's a different question. Slowing or stopping the progression is a different question than preventing the disease. We just don't know yet. And at the same time, there are much bigger risks to an asymptomatic person. So not only the psychological risk, but, now that information is out there, and it is possible that if you came down with ALS in 20 years and someone went back and got your medical records and said, hey, you knew in 2017 that you had an ALS causing gene, but you didn't tell us, we might classify that as a pre-existing condition and not pay for any of this now. You'd hate to see that happen, but it's possible. So I think there's a lot more to think about. And yes, the best person to have a conversation with patients is a genetics counselor. Unfortunately, a lot of us don't have that. So I don't have an adult genetics counselor that I can refer my patients to at Duke. I have to have these conversations myself.
Okay. Yeah, there's definitely a shortage of genetic counselors out there. But all that's very important and worth discussing here. So let's conclude by getting back to copper and oral copper ATSM. Let's take copper first. What were your group's conclusions on copper? And then would you tell us what your group's conclusions were for the copper ATSM?
We definitely don't recommend that patients with ALS take plain old copper. Even though this is cheap and it seems to be pretty safe at low doses, we just don't see any plausible way that plain old copper supplements could help. We think the problem is much more complicated. Now, copper ATSM is much more interesting. As I said, we've got some pretty amazing preclinical data, but we need better safety data, and we still don't know whether this is going to be useful for people both with and without SOD1 mutations. It might only work for people with SOD1 mutations. So, as exciting as it is, I think we're just going to have to be patient and see what happens with this copper ATSM trial.
Okay, thanks, Rick. Any final comments?
Yeah, I'm incredibly excited. If people ask me sometimes, what are you most excited about in terms of ALS research? And it's the antisense therapies and it's this copper ATSM trial, because I just think it's got such a cool mechanism and it's got such great preclinical data. I think it's got an awesome chance of working.
Oh, that'd be great. Okay, thank you, Rick. Once again, I've been speaking with Richard Bedlack from Duke University about copper and copper ATSM and their publication in the ALS Untangled project, which again can be found online at alsuntangled.org, .com, or .net, I believe were the three you mentioned. Thanks so much, Rick. Hi, I'm Ted Burns. I'm a neuromuscular specialist at the University of Virginia, and I'm talking today again with Richard Bedlack. Richard is an ALS specialist at Duke University. Richard, among other things, heads up the ALS Untangled group. Let me remind our listeners, this podcast is supported by the CREATE Consortium. Today, we're going to discuss another ALS Untangled publication, and this one is about the supplement inosine. This one is number 37 for anyone keeping score. Okay, Rick, let's start this interview by having you talk about inosine and urate. And urate's also known as uric acid, which is a known antioxidant. And while you're answering or telling us about inosine and urate, do you mind talking a little bit about two neurodegenerative diseases, that being Parkinson's disease and Alzheimer's disease, and the story of uric acid with those two diseases?
Sure thing, Ted. So inosine is a naturally occurring over-the-counter oral supplement, and what it does is increase urate levels in the body. So what's urate? Urate is a naturally occurring antioxidant, and people got interested in this as a possible neuroprotective agent when researchers noticed that high urate levels were associated with a lower risk of developing Parkinson's disease and Alzheimer's disease. Interestingly, naturally occurring high levels of urate are also associated with slower progression in Parkinson's disease. And I can add one more thing to this that's come out since the article. Just in the past month, somebody did a meta-analysis. So they looked at 11 previous studies, put them all together, and concluded that these studies provided strong evidence that patients with ALS have significantly lower urate levels than people without ALS, than healthy controls. And also, patients who have ALS who have higher urate levels have longer survival. So I think this is becoming a pretty big story now in neurodegenerative diseases just in general.
Wow, that's interesting. We are taping this March 23rd, 2018. So what might uric acid or urate do in the body that is potentially a good thing for people with ALS?
Well, as you know, the biological mechanisms that cause ALS are not completely understood, but most of us think they do involve damage to motor neurons from something called oxidative stress. And this is supported by a wealth of autopsy and laboratory studies. It follows that antioxidants like urate or agents that increase the levels of these, such as inosine, might be neuroprotective in ALS. Beyond just neuroprotection through urate elevation, there's some very recent work that suggests that inosine itself might stimulate the growth of axons in culture, might be able to promote sprouting in the cortical spinal tract, and it might even enhance motor recovery after traumatic brain injury. So these observations suggest that inosine might be able to enhance reinnervation in people with ALS, which would give it a second plausible mechanism for helping folks with this disease.
Okay, Rick. So inosine is a supplement that can raise levels of urate in the body. Is there any promising animal model data for its use?
Turns out there is. So across a lot of different Parkinson's disease cell and animal models, elevating urate seems to prevent cell death and improve the animal's function. Urate's also neuroprotective in models of neurotoxicity beyond Parkinson's disease, including cultured spinal cord neurons and models of spinal cord injury and stroke. There's even studies of urate modulation going on in preclinical models of ALS, but unfortunately we don't have any results from those yet.
Okay, thank you, Rick. So could you talk about any ongoing or recently completed trials in humans of inosine for patients with ALS?
Absolutely, Ted. So there was just a small pilot trial completed last fall. In this trial, 25 people with ALS took inosine at dosages ranging from 500 to 3,000 milligrams daily for 12 weeks. And the dosages were titrated to get their urate levels in the range of 7 to 8 milligrams per deciliter. And this study was important because we needed to know if that was tolerable and if it was safe. And so it showed that it was tolerable. 24 out of 25 people completed the study, and it showed that it was pretty safe. There were 3 serious adverse events, all thought to be related to ALS itself, not to the treatment. Most of the patients in this study did have non-serious adverse events, but again, none of these were clearly related to the treatment. So I haven't seen any efficacy data presented for this study yet, but I agree with the investigators who thought, this alone was promising enough to move into a larger, longer placebo-controlled trial, which is now actually open and recruiting.
Great. And where do you learn more about this trial?
That's a great question, Ted. So the database that I use to look for open trials for my patients is clinicaltrials.gov. It's a great resource, but, my patients often tell me that they have trouble navigating that site, that it's not very user-friendly. And so hopefully, folks who are out there listening have doctors who will help them use the website to look for open studies. There's also a website affiliated with a group called the Northeast ALS Consortium, NEALS, N-E-A-L-S, and they've developed what I think is a more user-friendly trial search engine, and you can find that on their website, www.neals.org.
Okay, great. That's good to know. You mentioned dosing, you mentioned potential side effect concerns, you mentioned uric acid, blood levels, and I want to talk about all of that now. And let's start by talking about a starting dose for any patient who might be interested in starting inosine.
So unlike many of the other things we've talked about in terms of ALS Untangled, dosing this is not so much about how much a person's actually taking, but about where their urate levels are. So it seems like the sweet spot as far as urate and ALS progression goes is having a blood level between 7 and 8 milligrams per deciliter. Levels lower than that are associated with faster ALS progression, and levels much higher than that are associated with gout and kidney stones. It turns out there's a wide range of actual doses that people might have to take to get their urate levels into that range, anywhere between 500 milligrams and 3,000 milligrams a day, all depending on their own metabolism.
Okay. And I think the normal range, at least at UVA, the normal range for the blood uric acid, I think is 4 to 8, if I remember correctly. And I have a few patients who have done this. I've tried to get them at least above 6, but I guess you really think that 7 to 8 is really the therapeutic range we should be shooting for.
That's the range that they're using in trials, and I think they have, pretty good evidence now from all these different studies that have been done that at least there's an association between progression rate in that range being better than progression rate at lower levels.
Yeah, that makes sense. Okay, thanks, Rick. So let's talk about risk of kidney stone and gout and monitoring of blood levels of uric acid.
Yeah, it's going to be tempting for people to just go ahead and start taking this, but it really should be done with careful monitoring of the blood urate levels. And that's because if you get them up too high, you're going to get things like kidney stones and possibly even gout, which are no fun. And it's a pretty high risk. In one of the trials that's out there in people with MS, 25% of the folks in the study wound up getting kidney stones.
Oh, that high. Did those patients have high urate levels? Do you remember, Rick?
I don't think they actually were measuring the urate levels in that trial. I think they were just, pushing the dose to see how people tolerated it.
Okay, so do you advise against inosine if the patient has had a kidney stone or has had gout in the past?
Personally, Ted, I would, and these were exclusions for the inosine trials as well.
Okay, and how often are you measuring blood urate levels?
I think they should probably be checked every 3 to 6 weeks, and the target would be to get it in the 7 to 8 milligram per deciliter range. And I think once you have a few that are pretty stable, you probably could back off a little bit on that. But I think, early on while you're trying to titrate this up, it's going to have to be checked more frequently.
Okay, and how about if somebody comes in, you check their blood urate level, and it's, 6.8 or 7.1. Would you advise that person from ever starting inosine?
Personally, I would, because I think they're already very close to or in the optimum urate range. And in that case, I think, the potential risks would outweigh the potential benefits.
Okay, and your manuscript mentions that you recommend monitoring urine pH levels. Why is that?
Yeah, it's even more complicated. So it turns out that urine acidity and concentration are major determinants of the risk for developing kidney stones. We're talking here about urate stones. There's lots of different kinds of kidney stones, but urate stones tend to develop when the urine gets very concentrated and acidic. That means when the pH gets down low. One thing people can do to try to minimize this risk is to maintain good hydration, but even that by itself may not be enough. And in fact, some of the things that people hydrate with that contain lots of vitamin C or things like cranberry juice themselves can potentially lower the urine pH. So it really does need to be monitored pretty regularly, just like the blood levels of urate.
So every 3 to 6 weeks?
Yeah, that's probably what I would do in the beginning until things sort of stabilize. And again, that would assume that a person has a pretty reasonably stable diet. I think if people are going to dramatically alter the amount of things they're taking in that could drop the urine pH, then it might need to be checked even more frequently.
Okay, it's a little disappointing how complicated it might be. Do you ever try to simplify it, Rick, or are you on an off-label basis? Are you really sticking with that monitoring plan?
Well, I'll be honest with you, Ted, this is not one that I personally use a lot in my clinic just yet. So I feel like, there's a trial underway. I feel like it's going to enroll pretty quickly and we'll have an answer very soon about whether this makes any sense to do or not. And it all comes back to the data. I mean, what we have is an association and, we don't know for sure whether that association is a cause and effect thing. Like it could be that there's some other factor, that's in between ALS progression and urate level, and that urate level is just a surrogate for that thing, which is really the driver of progression. We just don't know. So, you might call me a hypocrite because I think we talked about vitamin D last time, and I said this is something where I do, really do check it and try to get it into the normal range, and that's just based on an association too. It's not known to be cause and effect, but in my opinion, vitamin D is a lot easier to deal with than this. All these blood levels and urine levels and things like that to pay attention to. I feel like I really need to have stronger evidence that it's a cause and effect thing before I really start recommending this to all my patients.
Okay, and for any patients and loved ones listening in today, I guess one of the messages is this requires quite a bit of monitoring. It may turn out to be efficacious, but what we know for sure now is that monitoring of blood and urine is recommended. And the point of doing this is to, one, avoid kidney stones or gout, and the other related to that is to adjust the dose of the inosine, as you mentioned earlier in this interview. Can you comment on the cost?
So that's one of the pieces of good news about all this is that the actual cost of inosine itself is not much. It's between $10 and $60 a month, depending on which brand and exactly how much you wind up needing to take. You'd have to probably add into that the cost of some of the monitoring, though, depending upon how that's coded. It's not clear to me yet whether insurance would actually pay for that unless it becomes, something that becomes a standard of care.
Mm-hmm. Well, that's certainly a caveat. Any other caveats, specifically any caveats about buying inosine online?
Well, Ted, as with all these supplements that we talk about, there probably is going to be variability in the purity and also the co-ingredients between the different supplement suppliers. And, without a really detailed comparison of exactly what's in there, it's impossible to know who sells the best of any of these products. So, I'm just honest with patients. And when they tell me they're going to try one of these things that we talk about, I just mentioned to them that for the most part, no one's done the kind of detailed comparisons of all these things that would be necessary to recommend the best brand name or supplier.
Okay, fair enough. All right. Rick, any final comments?
Just that I'm really looking forward to the results of the current trial that's being done. I think this does have the potential to change the way we treat people with ALS in the near future.
And I know this is an unfair question, but any best guess on when we might hear some results?
Again, I suspect that that's going to enroll pretty quickly. They're not looking for a large number of patients for that trial. So I suspect we'll have the results of that by the end of the year, by the time of either the NEALS meeting, which is in October, or the International Symposium on ALS, which is in December.
Okay, great. Thanks, Rick. Again, I've been speaking with Rick Bedlack from Duke University.
Hello, everybody. I'm Dr. Richard Bedlack, Professor of Neurology and Director of the ALS Clinic at Duke University Medical Center in Durham, North Carolina. I'm also in charge of education and outreach for the CREATE Consortium, which is part of the NIH-sponsored Rare Disease Clinical Research Network. CREATE is a clinical research consortium that is focused on therapy development for ALS and related disorders. CREATE aims to help overcome some of the underlying barriers to therapy development with the goal of improving the success of future clinical trials. Today's podcast is part of a series we developed to try and help non-scientists understand some of the work that our CREATE team is doing. I am really pleased to be joined today by Dr. Nadia Sethi. Nadia is the Director of Community Outreach and Engagement for the ALS Therapy Development Institute. He's currently also the co-chair of the NEALS Northeast ALS Consortium Patient Education and Advocacy Committee. Nadia lost her husband to ALS in 2020. In today's podcast, Nadia and I will interview Dr. Mary Louise Rogers, Associate Professor at the College of Medicine and Public Health at Flinders University, as well as the first CREATE pilot project recipient and current collaborator on an NIH grant. Also joining us today is Dr. Michael Benatar. He's Professor of Neurology and Chief of the Neuromuscular Division and Executive Director of the ALS Center at the University of Miami. He's also the Director of the CREATE Consortium. Dr. Rogers and Dr. Benatar are co-authors of the recent publication, Urinary Neopterin, a novel biomarker of disease progression in amyotrophic lateral sclerosis. Nadia?
Welcome to the podcast, Dr. Rogers and Dr. Benatar. We're looking forward to learning more about the findings of the study from you today. The purpose of this study was to learn about urinary neopterin, a marker of inflammation, as a prognostic marker and a marker of disease progression in ALS. This study was really impactful because we need so many different types of biomarkers in ALS. So could you please start with the basics? What are some different types of biomarkers that could be useful in ALS? And more specifically, what are the differences between a marker of progression and prognosis and pharmacodynamics? There's so many different types.
So Nadia, this is perhaps the key question and the most important one, because I think there's lots of confusion about biomarkers. And I think the key is to understand that a biomarker needs to be what's called fit for purpose. So we need to think about how we're going to use it and to develop it accordingly. And so you've hit on some of the key ones. The first is a marker of disease progression. So this is a marker that tells us how the disease is unfolding. And so typically a marker of this sort would either increase as disease progresses or decrease as disease progresses. So it's changing over time, and at some level tells us something about how the disease is unfolding. Another kind of biomarker you mentioned is a prognostic marker. A prognostic marker is what it sounds like. When we measure it once, typically the first time we see a patient, it tells us something about the future course of disease. How quickly or how slowly will disease progress, or for how long will somebody live with the disease? And then perhaps most relevant to development of treatments is a pharmacodynamic marker. And there, again, the clue to its meaning is in the name. Pharmacological drug, and dynamic, changing. So it's a marker that changes in response to the administration of an experimental treatment. And so pharmacodynamic markers can give us an early clue that a drug may be working.
Okay, that's really helpful. So do we have any other markers of progression or prognosis that are currently in use in ALS?
We actually do. So I think best developed are some of the markers of prognosis. And perhaps the best developed, and we had a previous podcast about this, are some of the neurofilaments, especially neurofilament light. And another one that we'll touch on a little bit today, even though we're talking mostly about neopterin, is urinary P75 that came out of work from Dr. Rogers' lab. But other markers of disease progression are much more limited. And in fact, P75 is one of those, and neopterin may be too, and we'll come and talk more about that as well.
Okay, great. So there's some evidence that immune dysregulation occurs with the onset of ALS, and that in people with ALS, our immune system shifts from an anti-inflammatory to a pro-inflammatory state as motor neuron degeneration occurs. So could you describe the shift that happens in people with ALS and some of the inflammatory processes that are occurring?
Thank you, Nadia. There's evidence from previous studies in some animal models of ALS that there is neuroinflammation in ALS, and that starts and spreads from the brain and spinal cord, and also is present in markers in blood. But there is minimal overlap between ALS and autoimmune disease. So actually inflammation is thought to be maybe secondary to what occurs in ALS. That's protein aggregation, mitochondrial damage, and other stresses. So it's debated whether this is a consequence or a cause of disease. So immune cells and macrophages sort of maintain our homeostasis in the immune system. And then what happens is that the microglia in the brain and spinal cord try to deal with the aggregated proteins that occur in ALS, and they sort of become overwhelmed and they start to produce pro-inflammatory factors. And this actually may happen at the start of neuronal loss, and it's sort of trying to overcome what's happening. It's an anti-inflammatory state. And so what they're trying to do is clear all the debris, but after prolonged repetitive damage, this becomes overwhelmed and you get release of neurotoxic factors. And in the periphery, you get a pro-inflammatory cytokine such that actually start to be produced by blood cells. So it's a move from the body trying to get rid of all the damage in an anti-inflammatory way, and this becomes overwhelmed and moves to pro-inflammatory. And that actually may be damaging immune state.
Thank you, Dr. Rogers. So we've had some therapies in clinical trials that target inflammatory processes in ALS. And I think in the paper you referenced NP001 and masitinib and tocilizumab. I'm not sure if I'm saying that correctly. But could a marker of inflammation measure prognosis, progression, and also pharmacodynamics?
Yeah, so I think that's an important question. And I think, at least in theory, it could. So it's important to say, if we're looking at inflammation, and Dr. Rogers has highlighted that inflammation can be protective, but it can also be damaging. And so, if we're measuring a protective inflammatory marker, a high level might be good. If we're measuring a pro-inflammatory marker, a high level might be bad. And so I think there's a lot of nuance in the sort of inflammatory marker that's being measured, and we need to understand, what it is we're measuring and what it reflects. Any of these could, at least in theory, tell us about the future course of disease. If they change over time, they could tell us about disease progression. And if, for example, we're looking at a marker of inflammation and we're bringing an anti-inflammatory drug, maybe we would see a reduction or a change in that inflammatory marker that would tell us that that treatment is having some effect. And if that were the case, then it would be acting or serving as a pharmacodynamic marker. So I think all of those are possibilities.
Interesting. And it's advantageous to have an easy to collect biomarker that wouldn't require a blood draw or CSF collection. Is that one of the reasons that you decided to look at urinary neopterin?
Yes, that's true. So our lab's utilising urine as a source of biomarkers. And as you say, it's relatively easy for people to give a urine sample than, for example, for a CSF draw. And it's quite less complex than blood and simpler for us to identify biomarkers. So we decided to look at neopterin because some of the interesting literature surrounding inflammation, and colleagues have suggested to look at neopterin.
Okay, and then could you tell us about urinary neurotrophin receptor P75 extracellular domain, that's a mouthful, and how it was involved in the study?
Yes, we've investigated P75 ECD as a candidate biomarker for a number of years, and Dr. Benatar has been involved in this. And P75 is actually a receptor, and it gets increased or upregulated as there is an increase in ALS disease. And as the motor nerves get sick, the actual part of the molecule called the extracellular domain, or ECD, is cleaved off and ends up in the urine. We've been the first to show that this has a potential as a disease progression prognostic marker. But in this current study, we wanted to find out if urinary P75 was related to what was happening in neopterin, that's the levels of this marker. So we tested the urine sample from people with ALS and controls for both biomarkers, the same samples, but some of the samples we'd previously measured P75 and published in our 2017 paper.
And Nadia, if I could just add that I think one of the key differences between P75 and neopterin is P75 is sort of more, I think, a generic marker of axonal loss or degeneration. It doesn't speak to a specific mechanism. And as we've already highlighted a little, neopterin really sort of potentially speaks to an inflammatory mechanism. And so both urinary markers, but potentially telling us different things.
That's helpful to put things in context a little bit. So could you tell us about your methods, where the study took place, and then could you share some of the demographics about the participants and their types of ALS?
Okay, so the participants were mainly from Australia, and they were collected from the South Australian Motor Neurone Disease Clinic, and my colleague, Associate Professor David Schultz, who runs a clinic. It's actually on the same site as our laboratory at Flinders Medical Centre, and we had a small study, 21 healthy people with age range 49 to 71, 36 with ALS, with age range 49 to 71 years of age, and 29 of which had given more than one sample. So that was really important. And 4% had a familial disease that had been genotyped, the rest are sporadic. And so it's a small sample, but the information that was collected at the time was age, sex, site of onset, time from diagnosis, and first visit to neurologists at the time of sample collection, the ALS FRS. All of this is recorded by the neurologist, and any family history of ALS.
So, Dr. Rogers, you mentioned a couple of times that this is a fairly small study. It seems to me what you're asking from participants is not very much, not very complicated. CREATE has a huge number of sites, and each of those sites has a very large number of patients that they follow. So why was this such a small study?
Initially, we had involved just what we had biobanked. Hopefully, we will move on to look in a larger cohort, but at the time, that's what we had access to in our laboratory. And neopterin actually wasn't included in the study. Hadn't been thought of at that time in the CREATE. I'm sure it will be, but it hadn't at the time. It was just a study that we thought of in the lab, but we hadn't at the time involved CREATE. I did a bit later. I hope that's understandable.
Yeah, perhaps I can just add that I think, from Mary Louise's perspective, initially we engage in discovery, and then we think we find something interesting. We need to go out and then validate it in a larger cohort. And so I think that is one of the important next steps. And it's one of the ways in which CREATE can help. As you say, we do have a large bank of urine samples from people who've been carefully characterized. And so, together with Mary Louise, that's something that we will go on to do.
That's great to hear. I mean, is there some special way that the samples have to be stored in order to measure neopterin? Because again, it seems like this would be a pretty quick thing that you could do, Michael, with that large CREATE biobank that you have.
As long as we know that they've been collected and stored fairly quickly, centrifuged and stored at -80, we have a protocol which is sort of centrifuging, collection, storage after 4 hours. And we've found that that actually reduces the variation across the samples. And for the neopterin, doesn't really change with storage at -80. So in prior studies, it's found it's quite stable when stored.
And Rick, perhaps I can just add that there are some slight differences in how we standardly process urine samples in CREATE, but hopefully that won't meaningfully impact our ability to contribute this larger resource from the biorepository to help validate these findings. So we try to be meticulous about this because we're always trying to future-proof samples that as promising new biomarker candidates emerge, we've got the resource available to go in and try to validate.
That's great to hear.
So in healthy people, would you expect to find changes in urinary neopterin and urinary P75 as a person ages?
Thanks for asking that. Actually, yes, neuroneopterin does increase with advanced age because inflammation is increased with aging. So we do expect an increase around about over 70 years of age. P75 doesn't really change much, not significantly.
Okay, that's good to know. So what were your findings on baseline urinary neopterin and P75 then?
Baseline levels of urinary neopterin and P75 were higher in ALS than controls, and they were actually correlated to each other. But we also found that actually neopterin is less able to discriminate ALS from controls in our particular samples than what P75 was, but still able to do this, and as it was significantly higher than controls. And they were both correlated to their functional rating scale. And when we actually looked at age, effective age, and those younger than 72 and older than 49, there was no effect of age in the samples that we had.
Very interesting. So what were your findings about the two markers as prognostic markers and the markers of progression?
Yeah, so just a reminder, we spoke about this upfront, a prognostic marker. We can measure it initially and it tells us about the future course of disease. And we actually find that P75 and neopterin behave a little differently. P75 perhaps has more value as a prognostic marker than neopterin does. And important to say that when we're looking at these markers of prognosis, we're not looking at them in isolation. We're asking how they add information to what we already know from what we can tell from just interacting with the patient based on their age, their sex, their disease duration, the speed with which disease is progressing until now. So we set the bar fairly high in terms of what we ask a prognostic marker to do. And I think P75 performs better than neopterin in this context.
Interesting. And was there any previous data from other studies on either of these as markers of prognosis or progression? I think you had mentioned a little earlier, but if you can elaborate on that.
Okay, so first of all, I'll just talk about urinary neopterin as a marker of progression. So it did actually increase over time, and we're able to, using statistical methods, show that there was a sort of a rate per month, as same as what P75 also had a rate per month, and both of them were significantly increased per month. In regards to other studies, there was one other study from Lunetta in 2020 that actually showed neopterin was prognostic, but they actually hadn't done any longitudinal sampling in this study. But suffice to say, they had a slightly different population that they were looking at, and also they used a different, not a specific method as what we had used to look at neopterin. Not to say that there was anything wrong with this study, and they had a larger cohort too.
Okay. So are we at the point where urinary neopterin and P75 might be tried as pharmacodynamic biomarkers in drug trials?
I think we are, perhaps more so for P75, a little bit more established than neopterin. But I think that this is already sort of beginning to happen. We're seeing clinical trialists and companies that are, especially in phase 2 and looking for early signals, interested to reach out to Dr. Rogers and see whether it's possible to show a change in these markers. The challenge, of course, with the pharmacodynamic marker is until we have a really effective therapy for at least some patients with ALS, it's really hard to know whether a change in a marker really sort of translates eventually into something meaningful for patients. And so I think we need to get to the point of having a therapy that works at least for some patients to know that for sure. So I think we're sort of in a transitional state where this is emerging and being looked at more. And I think we'll learn lots more about this in the coming years.
So you had just mentioned phase 2 trials specifically. Is that the best phase to evaluate pharmacodynamic biomarkers? Is that the starting point for somebody who's interested in bringing this into a trial?
That's a great question. I think the answer for me is a clear yes. And the reason is in phase 3, where we're really looking for sort of proof of efficacy and hopefully a new drug application to the FDA and an indication for treating patients, we really must use measures that are meaningful to patients, how a patient functions or survives or feels. And so it's going to be hard to get approval based on a biomarker. But in phase 2, we struggle to know, because we often don't study a large enough number of patients for long enough to know whether those clinically meaningful effects are apparent. But a biomarker, and especially a pharmacodynamic marker, could potentially tell us that in phase 2 and encourage us to go on to do a phase 3.
Thanks for clarifying that. Was there a correlation with the ALS FRSR?
Yes, there was for both P75 ECD and neopterin.
And then was there a correlation with sex or site of onset?
Not in our study.
All right. And then could the results that you found, could they help stratify people with ALS or create subgroups in clinical trials targeting inflammatory mechanisms? So could we then create different groups of people who would be studied in a clinical trial?
That's a great question. I think this has to be tried. I think we won't know until we try. But the premise here would be that if this is really a good marker of a pro-inflammatory state that's harmful, and we're bringing a drug that sort of targets a pro-inflammatory state and dampens that down or reduces it, we might well expect that the people with the highest levels, or at least evidence of a pro-inflammatory state, will be the people most likely to respond to the treatment. So one idea would be that we use it as a selection criteria and only enroll in the trial people who seem to have abnormal inflammation that could be targeted. The other idea would be, as you suggest, to stratify on it with the expectation that there'd be a greater benefit or only a benefit in the group with the pro-inflammatory state. I think that's an idea worth testing, but we won't know until we try.
Okay. And then could you talk a little bit about some other inflammatory markers like KITE1 or MCP1? And how were those typically measured? Were they measured in blood or CSF?
Yes, KITE1 is actually released from microglia and is found quite elevated in the CSF, but it doesn't really change in the blood, but it's quite a good marker if measured from the CSF. It's not really clear whether it correlates with disease progression, and not always with the ALS-FRS. MCP1 appears also in the CSF to be related to faster progression in ALS, but seems to be stable as disease progresses. Because there's lots of studies of this MCP1 across serum, it really didn't find there was any difference in ALS compared to controls in this particular marker in the serum. So there are a couple of markers, but I think the option just adds to the markers that are out there, but maybe better because it's outside the CSF.
Thanks for clarifying that. Okay. And then what were some of the limitations in the study? We talked about sample size. Were there any other limitations that you can think of?
Yeah, as you say, sample size. In our studies so far, we haven't actually compared anything to other biomarkers, and I think that's probably important to see whether any relation to MCP1 and Chitin-1, for example. The type of assay that we're using, I think that could be improved. So we're looking at using an updated mass spectrometry assay. Yeah, so they are the limitations of the study.
Okay. And then we also touched a little bit on next steps already, but if you can elaborate a little more, what needs to happen next to move these markers forward in the clinic or in drug trials?
As Dr. Benatar has alluded to previously, this is more of an exploratory study. It really has to be confirmed in a larger study and compared to other inflammatory markers. If there is a phase 2 trial that specifically targets pro-inflammatory response, it would be good for it to be included. Even if it's a very limited number of people that are enrolled, it would be good to see if it can be used to subgroup people into those that have pro-inflammatory state and that could respond to anti-inflammatory treatment, for example.
Well, it's such an interesting paper. I just want to make sure I know it's fairly complex. Can you please just tell us the take-home message from this study for people living with ALS?
That's the million-dollar question, Rick. And I think we have a long history of clinical trials in ALS not yielding effective therapies for our patient population. And I think one of the important reasons, is that we lack good tools to tease out which drugs are worth studying and which aren't. And I'm a firm believer that the right biomarkers are potentially transformative in this space in terms of guiding us to those treatments that are most likely to bring benefit. And so I think this is adding another biomarker to the armamentarium of markers that we can look at to try to help accelerate therapy development. And so I think that's the take-home message. We study biomarkers that we can accelerate development of meaningfully effective therapies.
Great. I want to ask you one last question, both of you. I'd like for you to weigh in on this. So I'm mostly a clinician, spend most of my time seeing patients. We see lots of biomarkers now in clinical trials being evaluated, which I think is super exciting, as you've said. But when realistically might I have some tools that will help me in the clinic, that will help me to make an earlier diagnosis, that will help me to make a more accurate prognosis, that will help me decide which therapies I should start which patients on? Is it going to be months? Is it going to be years? Is it going to be decades? What do you think?
So I'll have a go at that first, if I may, Mary Louise. I think the diagnostic question, Rick, I don't think we have biomarkers that are on the horizon to help with this, because I think the problem is not a lack of biomarkers. It's a problem in sort of healthcare delivery in our healthcare system. And how do we get patients and physicians to think about the possibility of a diagnosis early on? By the time patients come to see us, usually the diagnosis is apparent. And so I don't think biomarkers are going to yet be transformative in that space. In terms of a prognostic marker, the great news is you have one now and it is clinically available to order. Neurofilament light is that marker. I think it is well established as a prognostic marker, and there are a couple of commercial entities that have now made this available through ClearSpace. So you can order that and you can use that. I think you also asked about pharmacodynamic, and I think we're closer to those. They're not yet in clinic, but I think they're in clinical trials and we're beginning to make decisions based off of them. So I think maybe ending where I started is that how we plan or hope to use a biomarker matters. And so the same biomarker can have different values depending on how we use it. And I think some of these are more ready for prime time than others, but we still have unmet needs that we're working on.
From a patient perspective, would it be useful to have a neurofilament test as a prognostic marker? What benefit would a person with ALS see from getting their physician to order that test?
So I think there is value, but we have to be cautious. So I think what we know is that a higher level portends a poorer prognosis, more rapid disease progression, shorter survival, and a lower level portends a slower progression and a longer survival. One of the things we don't yet know is what's that sort of threshold or cut point for saying a value is high or low. And so I think it's relative. And I think there's still room for us to improve that sort of threshold determination to make that really meaningful to patients. But I think we begin to get a sense as we get more experience with this, what constitutes a higher versus a lower level. I don't know whether that makes sense.
It does make some sense. I'm just trying to think of how I would use it. I mean, there's a lot of things that we already pay attention to that tell us about the prognosis of a patient. The most important being how fast they're progressing up until the point when they come to see us for the first time. I just wonder what additional information it would add right now. Maybe in the future, when we have those numbers worked out, it would add more information.
Yeah, so actually, we do have a little bit of a sense of that. And I'd refer listeners to our previous podcast about this. We show that neurofilament light levels do add prognostic value, even when you already consider things like the speed with which somebody is progressing until now and other clinical prognostic factors. It adds value. So maybe what we need is an online calculator of some sort so people can plug that in and do the math. But we know that it adds additional prognostic value.
I do think that the field of biomarkers is advancing rapidly, and that if you take neurofilament light as an example, it's been around for a number of years, but 15, 20 years, people looking at it, but it really only advanced when the tools got better to measure neurofilament light. And I think that that's going to happen to the biomarkers that are coming up, the newer biomarkers, and having more than one, not just neurofilament light, but others that are fit for purpose, as Michael says, will actually really benefit in the clinical trials and subgrouping people that could respond to therapy and looking at the pre-familial ALS population and trying to help that population get treated earlier. That's the sort of thing. But I do think that the up-and-coming biomarkers will progress when new technology is coming online to actually measure things in a better way, just like neurofilament light.
Yeah, great points. I know I learned a lot today. Nadia, thank you for the excellent questions. Dr. Rogers, Dr. Benatar, thanks for the really interesting answers and context. I hope everybody has a great night.
Thank you.
Hello, everybody. I'm Dr. Richard Bedlack, professor of neurology and director of the Duke University ALS Clinic in Durham, North Carolina. I'm also in charge of the education and outreach part of the CREATE Consortium. CREATE is an NIH-sponsored rare disease clinical research network, and we're a consortium that's focused on therapy development for ALS and related disorders. CREATE aims to help overcome some of the underlying barriers to therapy development with the goal of improving the success of future clinical trials. Today's podcast is part of a series we developed to try and help non-scientists understand some of the work that our CREATE team is doing. I'm thrilled to be joined by Dr. Nadia Sethi today. Nadia is Director of Community Outreach and Engagement for the ALS Therapy Development Institute, and she's also currently the co-chair of the Northeast ALS Consortium's Patient Education and Advocacy Committee. Nadia lost her husband to ALS in 2020. In today's podcast, Nadia and I will interview Dr. Mark Weiskopf, who is Cecil K. and Phillips Drinker Professor of Environmental Epidemiology and Physiology at the Harvard T.H. Chan School of Public Health. He's also a CREATE PI and the author of the recent publication, Occupational Lead Exposure and Survival with Amyotrophic Lateral Sclerosis. Nadia, I'll turn it over to you.
Welcome to the podcast, Dr. Weiskopf. It's great to have you. We're looking forward to learning more about the findings of this study from you today. To start with, could you give us some background? So there's been 2 past studies that looked at lead exposure and its association to ALS that had some conflicting results. Those studies looked at biomarkers of lead exposure in blood and bone, and we have some questions on those studies for later on today. But finding clues to environmental exposures that might contribute to or change the course of ALS could be so impactful. Could you tell us about what made you decide to look at lead in relation to ALS and how evaluating occupational exposures might give us new and different clues than evaluating biomarkers after onset?
Sure. And first, just thank you very much for having me on this. I'm happy to participate. This is great. So yeah, first, just one point of clarification, I guess. So there have been a few papers, also somewhat small, looking at the relation between exposure to lead and onset of ALS. The two you're referring to were specifically looking at survival with ALS among people who already had it. So they came to slightly different conclusions. They both looked at, as you mentioned, biomarkers of exposure, meaning looking at lead in blood, for example, or lead in bone, which we have ways of assessing, to get a picture of what's on board in someone's system at the moment and see how does that relate to future survival with ALS. And the first study found sort of, I guess, paradoxically protective effects of lead exposure, meaning longer survival among those who had higher lead exposure. And the other found the opposite. So that background, along with the fact that a lot of evidence that lead has many neurotoxic properties that can impact the nervous system in many different ways, usually bad ways, that has sort of led to a general interest of whether lead may play some role in ALS. But those two papers in particular kind of spurred our interest. And as you pointed out, we took a different approach, which was to look at assessing whether someone had been exposed to lead by looking at their occupational history. And we can go into how that happens, but we know certain jobs have a risk of lead exposure. And so we can sort of at least crudely classify people into folks who are likely to have been quite exposed versus others who have not, and see whether they differ in their progression. And that introduces some advantages over biomarkers that we can discuss that lead measures in blood or bone. It also has some disadvantages, but overall, we felt it gave us an interesting possibility to explore this question further.
Thank you for that. And could you tell us a little bit more about the toxic properties of lead with regard to our nervous system?
Sure. So lead does many things that are not good for the nervous system. Some of the key ones are driven a lot by a sort of interesting aspect is that, roughly speaking, lead can look a lot like other elements like calcium or zinc. So the body can sort of, in a sense, kind of misinterpret signals, and the lead can kind of start to gum up the works of processes in the body that depend on essential elements like calcium and zinc. And that can lead to a whole bunch of different bad effects, like actually, frankly, killing cells or blocking signaling systems within the body, interfering with enzymes that have key functions in the body. A key one for ALS, for example, is the copper zinc superoxide dismutase 1 that has a lot of suspected roles in ALS. And that fact that it sort of has a zinc component raises the question of whether lead might be interfering in the functioning of that protein in some way. So it sort of has this plethora of unfortunate consequences in the body. It's what we refer to as a non-essential metal, in that there is simply no biological role for lead in the body. So effectively, any lead that's in there only gets in the way with normal processing functions in the body and can lead to things like cell death or neuronal death or disruption of signaling.
Thank you. That was very helpful. So this study was conducted with participants from the phenotype-genotype biomarker study by the Clinical Research in ALS Consortium, also called the CREATE Consortium. Could you tell us more about the PGB and what it means to participate in it?
Sure. So PGB is a natural history and biomarker study that collects longitudinal data, meaning over time in people, from a large cohort of patients with ALS and related disorders. It includes motor and cognitive behavioral data, information about environmental exposures, and whole genome sequencing data. And it also collects biological specimens to facilitate discovery and validation of biomarkers relevant to therapy development. So PGB overall enables us to really better define the natural history of the common genetic forms of ALS and provides a platform for validating patient-reported outcome measures and for better understanding patient perspectives on clinically meaningful changes in standard outcome measures.
Dr. Weisskopf, I wondered, did all the patients who participated in this have both upper and lower motor neuron signs? And I ask you this because I know lead poisoning can cause a progressive lower motor neuron disease, which mimics a form of ALS that we sometimes call progressive muscular atrophy. And I just wondered if some of these patients might have had that ALS mimic instead of true ALS.
Sure. Yeah, that's a great question. I will say that from the data that we saw on our end, I wouldn't be able to tell you actually whether they all had lower or motor signs. We had data on what the initial presentation of the symptoms were, and there was a distribution of those with initially lower motor versus upper motor neuron signs. So I don't know is the fundamental answer to that question. However, as part of the CREATE Consortium and PGB, they do very deep phenotyping and its intensive clinical assessment of these patients. And PMA is one of those sort of non-ALS conditions that some of the people have in that consortium. We didn't analyze them. So to the extent that they would have been identified with PMI as part of that clinical workup, they would have been removed from our analysis. But, I guess it's possible that some might have slipped in and actually were still there. That would be more of a clinical question for the clinicians in the team.
Dr. Weisskopf, you had international participation for this study. What countries were represented?
We were focusing specifically on ALS. So as part of PGB, there are people who have ALS and related conditions. So we cut the sample about in half because half had a sort of classic true ALS condition. Others had these other things like PMA or others. So actually the sort of half that we analyzed with actual ALS, I'm not exactly certain which countries they came from, but overall the group comes from the US, Germany, and South Africa, which is where patients are recruited from.
Okay, and then participants filled out a questionnaire developed in 2017, and then they were followed clinically. Could you share what clinical outcome measures you looked at?
Sure, and also just to clarify, so the clinical following of these patients is kind of an ongoing thing. That's part of the PGB and the CREATE consortium to follow them all. Once they do the environmental questionnaire, we can then relate those types of responses to that clinical follow-up that they do. So they're followed, as I mentioned, as part of PGB for a whole list of things. I mean, there's blood testing done, there's genetics done, there's different metabolites that are analyzed. What we used for this study was simply a sort of final endpoint, whether they survived or their survival length with ALS, and also the ALS-FRS rating scale score, which was done every time they are seen as part of the PGB cohort.
What does the term deep phenotyping mean, and how is deep phenotyping used in this study?
Yeah, so deep phenotyping is kind of a general term that essentially means to try and collect as much detail as one can on clinical phenotypes of a condition. So in this case, ALS. And that can mean, clinical signs of these upper or lower motor neuron signs, fasciculations. It can mean measures of metabolites or different things in the blood. It can mean the genomic sequencing. So it's sort of the entirety of any kind of clinical manifestation of a condition with the idea of just simply trying to understand it better and know what's going on. So that's kind of the meaning of deep phenotyping. We didn't use all of that data in this study here. Really, the only parts we used that were part of that would be that ALS functional rating scale score.
Okay, and what about the survey that evaluated occupational lead exposure? In the study, you describe a job exposure matrix that was used to determine the exposure. Could you describe what kinds of questions were asked and what you were looking for? How many unique occupations were listed, why they were chosen, and so on?
Sure, yeah. So this is a very classic approach in occupational epidemiology with the understanding that certain jobs have known risk of exposures to different toxicants of sorts. So the process is actually, we didn't start it necessarily focused on lead because it can be done for any toxicant for which a job exposure matrix exists. What we do is we simply ask them to report on their occupational history. And the US Census Bureau effectively codes almost any job into a list of about 800 different codes. And so as painful as that may sound, we actually sort of stepped people through a kind of laddered process to figure out their specific job at a different time in their life. And it would be coded by this US Census Bureau code. So this could be things like, you're a dentist, or you work in the newspaper industry, or you're in construction or painting, right? So that's the base of it. And that's independent of any toxicant issue. It's simply the reporting of what jobs you've had in your past. For many toxicants, then, a lot of work has been done by others, occupational epidemiologists, toxicologists, industrial hygienists, to go into different workspaces and say, okay, in this job, what is the likelihood someone was exposed to lead, and how many people typically get exposed to lead? And that's a lot of information that uses expert knowledge, uses air measurements, in some cases blood measurements, to see which jobs get exposed to what compound. And then people have taken that and basically classified all those US Census Bureau codes for the different occupations into a likelihood of exposure to different things. And in this case, we took the lead one. So it's really a long list. 800 or so are the total list of jobs. And many, many of those have some potential for exposure to lead. So it's kind of a long list, as I mentioned a few of them before. But we essentially went through all the reporting of these folks in PGB of their occupation history and said, which ones reported some occupation that has a risk of lead exposure. this works in part because when you are exposed to something like lead or another toxicant on the job, it's typically at a much higher level than you would get in the general population. And so you're still able to classify people who really have a different level of exposure than people that don't report those jobs.
That's great. Dr. Weiskopf, a few years back, I remember seeing a talk about something called the expososome. And the sort of premise of this talk was that, we so often do studies where we're looking at whether or not someone had an exposure, but isn't it also important to try to explore the dose and the duration of that particular exposure? And if so, did you do that in this study?
Yeah, absolutely. And that is definitely something we like to do. And in fact, the job exposure matrix itself usually does classify people into kind of levels. Maybe it's thirds of likelihood, low, medium, high probability of exposure and intensity of exposure. And what we like to do is also look at whether risks change with those levels, those doses of exposure. One of the limitations of this study is that it was still rather small. So unfortunately, we really didn't have the numbers to be able to dig into different levels of that kind of exposure. So ultimately, the hope would be able to do more work in a larger cohort or combine cohorts where we can do exactly that and try and see, is there evidence that essentially the more exposure you get, the worse the problem.
Okay. Yeah, and again, it's an association, and it always makes me wonder, how can you be sure it was actually the lead rather than something else about these jobs that might have explained the differences? Maybe these jobs were more physically demanding, or maybe there was some other chemical that was there.
Yeah, no, absolutely. And that's a great issue and one that, is impossible to completely rule out. One of the advantages of job exposure matrices over, for example, simply looking job by job, is that across the many jobs in the lead job exposure matrix, there's this commonality of lead exposure. And so other things might be less uniformly experienced across all of those different jobs. For example, someone working in a dental office has risk of lead exposure. Someone working in construction has risk of lead exposure. Other things are probably less likely common between those two jobs, and those are only two of the many that might have lead exposure. So you get around that a little bit by saying, well, across all these jobs that have lead exposure, other things are likely less commonly the same across those different jobs, and so would be less likely to create this kind of a signal. But it's not something we can completely rule out. One way to also go about this is to actually look at other toxicants with job exposure matrices, with the idea that, we shouldn't be seeing all of them show a signal if there's really something specific to a particular toxicant. But it is a great point and one that's very hard to rule out. So we can't completely rule out that it isn't some other exposure that goes along with lead in these many different jobs.
Could you explain a little bit about the survival endpoint that was chosen and what events would qualify for a survival endpoint?
Sure, yeah. The main analyses we did fundamentally looked at the endpoints of either death or tracheostomy or permanent assisted ventilation. So any of those were considered kind of the end of follow-up and an event in this case. And that's more or less sort of mimics how things are done with clinical trials, for example.
Okay, and then additional factors that you looked at included age, sex, site of onset, time to diagnosis from symptom onset, the presence or absence of a repeat expansion in the C9orf72 gene, smoking history, and military service. Could you explain why these factors were chosen and why they were included in the study?
Sure. So most of those factors were chosen because of some suspicion that they might relate to survival with ALS. And a little bit like Dr. Bidlack was asking about other metals, with this job exposure matrix, how do we know that it was really the lead and not something else that came along with those jobs? We also have to worry that for some kind of reason we don't understand, for example, people who are in lead-exposed jobs have a different type of ALS, a different onset spinal versus bulbar, for example. And if that's happening, a signal we see with lead could actually be accounted for by the fact that for whatever reason, people exposed to lead are more likely to have a bulbar onset of ALS. And these conditions like site of onset or age of onset or diagnostic delay are known to be related to survival with ALS. So we wanted to sort of account for those and make sure that we weren't simply seeing a signal with lead because of a correlation with those. So they were largely chosen based on that there was some suggestion they may be related to survival with ALS. Military history was a particularly interesting one because there is some suspicion of that. There's not a lot of literature on that, but military service happens to be a lead-exposed job. So given the potential role of military service in ALS, we wanted to make sure we kind of removed that factor from our lead analysis.
Great. And then building on that, so you included 135 people with ALS in this study. Could you describe some of the characteristics of the participants, their type of onset, their time from onset to diagnosis, and so on?
Yeah, so among those 135, their age of onset of ALS was about 56 years of age. We had somewhat more men than women, about 64% men. The majority of the ALS cases were spinal onset, which is probably to be expected, about 73% of them. Only 5% had the C9orf mutation. And on average, the diagnostic delay, that is the time from reported onset of symptoms to when an actual diagnosis occurs, was about a year. That's sort of the general picture of the population.
Okay, and then could you share some details about your findings? You did find an association between occupational exposure to lead prior to ALS onset and survival after ALS onset. Did your findings achieve statistical significance? And then could you talk a little bit about what hazard ratios are and how they fit into the study?
Yeah, so we did see this association between occupational exposure to lead prior to ALS onset and shorter survival with ALS, which translates into a larger hazard ratio, which I could talk about in a moment. And yes, it did achieve statistical significance. And in fact, we tried to adjust for many different things, military, sex, site of onset, all those types of factors I talked about. And basically the finding was quite robust to whatever type of adjustment we tried to do, suggesting that these other factors were not accounting for what we were seeing. And we were getting hazard ratios just under 3, which roughly speaking, hazard ratios, we can get into the sort of wonky details of epidemiology, but in essence, they're kind of telling you about the rate of progression with ALS. And so essentially it's sort of saying that what we see in our data is about a 3 times faster rate of reaching one of those endpoints that I talked about if you had a lead exposed job prior to ALS.
Thank you for that. And then could you explain how the covariates, the other factors that you evaluated like sex, age, and smoking in military service correlated with survival?
Yeah, so the ones that were most prominent, and in some ways this made us sort of feel, like the data was looking like it should be in essence, was we found that the older you were at onset of ALS, the more rapid the progression with ALS. The bulbar form of ALS as an onset site for non-spinal had a more rapid progression with ALS. And a longer diagnostic delay, that is more time between that onset of first symptoms and when you get diagnosed with ALS, was related to longer survival with ALS, which is also expected as that diagnostic delay is already sort of telling you what the pace of that ALS progression is. So those were the more prominent ones and the ones that sort of showed signals that we would have expected based on what has been described before, which is always comforting when you're looking at your data that at least it is appearing typical as far as what people have described elsewhere. Other things didn't reach significance, but sort of trended in directions we might have expected.
Thank you. And there were only 5 female participants that had occupational exposures to lead in this study. Was this expected or unexpected? And would we need additional study in the future with more female participants?
Yeah, it's certainly not unexpected. Lead-exposed jobs in the past in history have definitely skewed very heavily male. So that was not unexpected, but of course, unfortunate in that it does limit our ability to look at this question in females. I will say this is one of the, maybe one would consider it a drawback of the job exposure matrix, or maybe not a drawback, but often you have to look separately in men and women because even within the same job, often the sort of specific tasks and what people are doing can be different by sexes. And so we often look separately by sex. But you're right, this is inherent with anything, particularly looking at lead in an occupational setting because of the skew of those jobs towards men. So ideally, we would again have larger numbers where we could get a clearer picture of whether this is being seen in women as well, since the numbers were quite small here.
Was your study able to point to specific occupations that might be more likely to shorten survival?
No, we're not really able to pinpoint any specific jobs, and that's in part because there are many that go into that lead job exposure matrix to determine lead exposure. And so any individual job simply had too few people in it. So it's a little bit like we couldn't look at the dose of lead exposure based on likelihood of jobs. That also applies effectively to trying to look at any individual job. As I mentioned before, one of the jobs that does involve lead exposure is military history or service. And we are trying to explore that one separately because we have a fair number that did serve in the military. So that's ongoing work. And hopefully in the near future, I can report to you on what we're finding there.
That's very interesting. Yeah, we look forward to hearing more about that. What implications did this study have for people living with ALS today?
Yeah, that's a great question. And of course, that's sort of the key question. I will say that, unfortunately, the main question addressed here doesn't necessarily have direct translation to people with ALS, since what we were really asking about was the exposure prior to ALS. So we can't necessarily say that the lead exposure when you have ALS, what that is doing, because that wasn't really what our question was asking. It was asking prior to onset of ALS. That said, we would sort of suspect, given what we've seen, that it would not be beneficial to have lead exposure post-ALS, but it really wasn't what our question was addressing. I mean, I think we hope from some of this work to sort of be able to simply better understand what's going on with ALS, what factors contribute to its occurrence and survival with ALS, just simply get a better picture of it. And ideally, I mentioned many of those neurotoxic mechanisms of lead. If we sort of really nail down that lead is having these effects on progression, can we then push forward to, well, what mechanisms is that acting through? And maybe that down the line would help us get an understanding of places we might be able to intervene. But I would say that's well down the line. At the moment, I can't say there are immediate implications for people with ALS.
Thank you for that. So now backing up and going back to the previous studies that were mentioned in this paper, there was 2 of them. And the first looked at levels of lead in the blood and in bone in 110 people with ALS. And then the second study looked at blood lead in 145 people with ALS and then adjusted for markers of loss of bone. So could you talk a little bit about the results of those studies in more detail, and also how bone resorption occurs in ALS and then releases lead that may have been trapped into the blood? And then you mentioned reverse causation bias in the discussion of this paper. What is reverse causation bias, and how was it a potential weakness in the other studies?
So taking the first prior study first, I mean, they simply took blood samples and bone measurements from a set of people who had ALS and then a set of people who did not, or the controls. And the issue is with lead is that the exposure to lead, you can get it into your system in many ways, and it will circulate through the blood and distribute to soft tissues to have whatever effect, usually a bad one, it's going to have. But the major sink for lead in the body eventually is into the bones. So it will circulate for a while and some will get excreted, but most of it will get deposited in your bone. And bone is not completely inert, so it's constantly forming and reforming. So you're resorbing some bone and you're reforming more bone. And there's a balance there between that formation and resorption of bone. And every time you sort of pull some bone away, anything that was in that bone will get reintroduced into circulation. So you will find it again. The problem in this setting for a study like that is that with ALS, there's obviously weight loss, differences in behavioral activities, and a lot of those effects of ALS, behavioral ones as well as these physiological ones, are likely to lead to sort of shifting that balance to bone resorption, meaning you're losing bone material. And that can do 2 things. One, it takes whatever lead you were exposed to in the past and can put it into the blood. So you now have someone with ALS who, because of the ALS, is losing more bone than someone without ALS and increasing their lead levels in the blood simply because it's coming out of the bone. And so that's a form of what's known as reverse causation, where it's actually the disease itself that is affecting the exposure measure you're making of the toxicant, rather than the toxicant affecting the disease itself. Those kind of physiological changes, when things like that are going on, when you've got someone who already has the disease, it's very hard to completely be sure that that is not accounting for any differences in the exposure measure you're making. And so my strong suspicion is with that first paper is something like that was going on. So not only, they were seeing more lead come out of the bone, then some bone reformation, so the bone levels decrease. Some of the lead that goes back in the blood gets excreted. It's a complicated physiological processing that affects this. The second paper tried to account for that bone turnover. And in fact, when they did, they got a result that looked a little bit more like what we're finding. And what I was saying is sort of one of the major advantages of the way we're approaching this is that by looking at that occupational history in the past, that's not affected by whether someone has ALS or not. So it kind of removes this problem of reverse causation where the disease is affecting the measurement you're making. So that gave us this big advantage. It comes with the disadvantage that it is simply not as good a measure of someone's lead exposure, certainly at one moment, as sort of multiple samples over time might be. But it has that very important issue of getting around this problem of the disease affecting the measurement you're making. Now, while I think that second paper was getting a more accurate picture because of the way they were accounting for bone turnover, you still have to be careful with physiology. Physiology can do very strange things. So if someone already has a condition, whether you're completely accounting for that or not can be a tricky thing to know. And so it's nice to have sort of a study like this that takes a different approach, that has its own strengths and weaknesses, but finds a similar picture as the one that accounted for those bone turnover characteristics. So that was sort of one of the, to my mind, advantages of what we were doing, to add a different approach that avoided some of the pitfalls of the others, had its own problems. But when you put that literature together and look at the different ways people have tried to approach this, the picture can become a little bit more clear.
Thank you. I think it's so helpful to understand how the research built upon the past research. That was really helpful to put things into context. What were the limitations within the study that you did, and were there any potential biases?
Yeah, so we've touched on some of the key limitations. I'll reiterate them. I mean, one is, as I say, just, assessing someone's lead exposure by what job they had has a lot of error in it. I mean, not everybody in the same job clearly has the same lead exposure. What we bank on and what we expect and have seen in many settings is that even though we're getting some error in that, we're not getting the actual picture of exposure for everybody. When we're identifying people who are exposed, even though we're making some error in how exposed they were, they're usually much more exposed than the people that we are saying are not exposed. So we get a bigger contrast in exposures, even though we may not be getting the actual exact exposure correct. So that's certainly a limitation of the job exposure matrices. Another major limitation of this study is simply just the size. I mean, it is still relatively small. All the papers we've referred to on lead and survival were about the same size, but they're fundamentally on the smaller side. We would like to have much larger studies so we can do things like look at specific jobs, look at dose of exposure, look more at women and have enough women to see whether we get the same picture there. So that was a big limitation of this study. The bias that we were perhaps most concerned about was that the environmental questionnaire in PGB only started several years after the recruitment of ALS patients into PGB, or patients with other conditions, but we focused obviously on the ALS ones. And that can lead to some problems because some of those ALS patients that got recruited into PGB may simply not have survived until the time we introduced our environmental questionnaire. And so we're missing certain people, and we're in fact missing people who tended to have shorter survival because that's why they weren't around to answer our questionnaire. And that can lead to some biases that could create problems, particularly if that differs by people who were and were not exposed to lead. So that was certainly one of concern. I will say that we did several things to try and check whether that was affecting our results. And it, in the end, did not look that way. And in fact, if anything, might have suggested that that could have made it harder to see what we were seeing. So we did a few epidemiological machinations to try and test whether that was actually biasing our results. And those suggested it wasn't, but it's always a bit of a concern when you don't have that questionnaire right at the moment you're recruiting everybody.
Thank you for that. And what future studies might build on this research that you did?
Well, so as I say, within PGB, we're exploring other things, for example, military service and the role of that. And as I mentioned, we also want to look at other toxicants, right? Especially with the job exposure matrix to get to some degree at the question Dr. Bidlack was getting at, could it be something else rather than the lead? And so we want to look at many different types of exposures. In the end, it would be great to have larger cohorts of ALS patients. Maybe now this deep phenotyping could also include different measures of different exposures over time, which would also allow us actually to better answer the question of, when you actually have ALS, if you get an exposure, is that problematic or not? How does that play out? Those, unfortunately, are also quite expensive because making these measurements of metals or other toxicants in samples is not cheap. And then, as I mentioned, the business of reverse causation, you have to be quite careful how you use those. If you have many of them over time, that helps, and it helps you get around some of the problems. But many measurements like that over time are quite expensive to do. But we'd like to be able to push that further.
So Dr. Weisskopf, based on your last couple of answers, I think I know how you're going to answer this question, but I've got to ask it. Many of my patients ask about chelation as an ALS treatment, and I've actually over the years had several people try it. I've never seen what I thought was a significant benefit on the progression of their disease. But based on the results of this paper, do you think there's enough now to justify a clinical trial of lead chelation as an ALS treatment?
Yeah, so I would have to assume that based on this paper, I would say no. This paper certainly isn't addressing, as I said, your lead exposure when you have ALS. We were looking really prior to that. And really, there's a fundamental issue that we're still not sure of, is that lead can have deleterious effects in the immediate. That is, what's circulating can affect calcium signaling, can affect neuronal communication, and even mitochondria and death of cells. But it can also have effects, if you were exposed 10 years ago, that persist, right? And so it has nothing to do with the fact that the lead is still in your system. It's just that some damage has occurred, and that remains even though the lead may be long gone. So we don't yet know which of those two is the more major player here. And if it's the latter one, where it was really that damage that occurred before and that simply set you up now, then chelation certainly wouldn't do anything if you already have ALS and that damage has happened. So I certainly don't think on the basis of this paper I would go there. And I think we have more work to do before we understand whether that could possibly be beneficial.
Well, that's very helpful. I've really enjoyed talking to both of you today. Nadia, great questions, and Dr. Weisskopf, very interesting research. I wish you the best of luck moving forward.
Terrific. Thank you very much. Great to talk to you guys.
Thanks so much for joining.
Hi, I'm Ted Burns. I'm a neuromuscular doctor at the University of Virginia. I'm again talking with Richard Bedlack. Richard is an ALS specialist at Duke University. He heads up the ALS Untangled group. And let me again remind listeners to listen to our introductory interview that provides background on the ALS Untangled group. Today, we're going to discuss another ALS Untangled publication, this one numbered 44, about curcumin. And before we do, let me remind our listeners that this podcast is supported by the CREATE Consortium. Rick, let's start by having you provide brief background on this chemical compound.
Great, sure, Ted. So curcumin is a compound that belongs to a chemical class called polyphenols, and it's one of several structurally similar compounds that are in the spice turmeric, and it's also found in curry powder. And so I know sometimes, patients will ask me, well, can I just take turmeric or just put some more curry powder on my food? And the problem is that there's very little curcumin in those things. So if curcumin is what we're interested in, probably needs to be taken by itself, not as part of those things.
Okay, and could you talk about the 4 potential mechanisms of action that might be at work for curcumin and that might be of interest to the ALS community?
You bet. So unlike most of the things that ALS Untangled has reviewed, there are many scientific papers on curcumin. In fact, there's more than 10,000 publications on this. And a lot of these publications are devoted to trying to show what it might do in terms of mechanisms. And so some of these studies are in test tubes and some of them are in cells and very few of them are actually in people. But it does look like from these studies that curcumin might be able to modulate neuroinflammation. It might be able to reduce oxidative stress. It might be able to decrease the clumping or aggregation of proteins. And then my favorite one is it might be able to alter the fecal microbiome. That's the family of bacteria that live in each of our guts. Now, each of these pathways that curcumin might influence, or at least has some evidence for playing a role in the progression of ALS.
Okay, thank you. It looks like there are many different formulations out there of curcumin, especially online. And in a minute, I want to talk about one in particular. But before I do, Rick, could you just summarize how risky this alternative therapy, if taken orally, might be?
Yeah, I'm glad you said that last part, orally. Curcumin has rarely been injected, and that seems to be very dangerous. There have been some serious adverse events associated with that. But curcumin taken orally appears to be quite safe, even at high doses of up to 12 grams per day. So as I said, there's lots of publications, and many of those are clinical trials. There's probably more than 40 different clinical trials out there. And if you put them all together, less than 10% of the people who participated in all these curcumin trials had any side effects at all. So, ALS Untangled, in reviewing this data, found no evidence that oral curcumin could cause any serious side effects like death or problems that would require hospitalization.
Okay, that's great news. Now I want to talk about one formulation in particular. And it sounds like you and a few others are going to try to start up a trial, or maybe you have started up a trial using one formulation of curcumin, and that is called theracurmin. So
Correct.
Could you talk about the reason why a trial with theracurmin is being considered?
Yeah, so of the many published trials on curcumin, there were 2 positive ones that really stood out for us because they involved people with brain diseases. So one of the trials was of people with mild cognitive impairment, and the other trial was actually an Iranian trial on people with ALS. And in both of these trials, a very specific formulation was used, which was curcumin dispersed with other molecules that could optimize its absorption and its solubility. And so this is one of the things that we see written about in terms of critiques of curcumin, is that plain old curcumin is not very soluble. And, if somebody eats a bunch of curcumin, you really can't measure blood levels of it. And so folks have tried to go at that problem in a whole bunch of different ways, combining the curcumin with things like black pepper that optimize absorption. But this particular strategy that these companies are using is to actually put the curcumin in there, disperse it with other molecules that make it water soluble. And so both of these were positive trials, and therefore we're going to use that formulation. So the mild cognitive impairment trial specifically used theracurmin. The Iranian ALS trial used something with a different brand name, but it was the same idea. So we think that we're onto something with that, and that's why we picked that for our upcoming trial.
Okay, and I looked up online, I think I was on Amazon, but I was somewhere online, and it looks like there are a lot of places that sell theracurmin online at lots of different doses. So what dose are you planning to use in this trial?
So we want to use the exact same manufacturer and the exact same dose as was used in the mild cognitive impairment trial. So we're going to use theracurmin at 90 milligrams twice a day. And we've been in contact with the company that owns that product, and we're trying to get them to work with us, and we're just waiting to hear back.
Okay, so for the listener, I'm sure the listener hears this 90 milligrams twice a day, but what about the manufacturer? At this point, do you think that matters? If I'm online, I'm looking for 90 milligrams twice a day, or roughly 90 milligrams, do you think I need to drill down to the specific manufacturer that you're going to work with in this trial?
Yeah, it's that question that keeps coming up, and it's the one that we just never have the answer for. With all these different supplements, there's different manufacturers, different brands that are out there, and really the only way to know about, the purity and the existence of co-ingredients is to do really careful, detailed testing of all these different manufacturers' products, and we just don't have that. So, we're picking this particular one because it was the exact formulation and dose that was used in that positive mild cognitive impairment trial. That's another brain disease, so we feel like, that's enough for us to want to use that.
So, Rick, any comment about the manufacturer?
Well, so Ted, once again, we don't know for sure who makes the best version of theracurmin. That would require us to test all the different manufacturers out there for purity and, for what else is in there. But we plan to use the same group's theracurmin as was used in that trial in mild cognitive impairment, and that's a group called Integrative Therapeutics. And so we've got some calls out to them now to see if they are interested in working with us on this trial.
Okay. Now, I mentioned earlier that I looked online and saw lots of different doses available. This is a bit of an unfair question, but do you feel strongly about this 90 milligram dose? Or do you have any comment on whether more might be better?
It's really tough to know. I mean, we're going to use that dose because it had a positive effect in a well-designed trial of patients with another brain disease, mild cognitive impairment. If we can show anything with our trial, if we can show any effect on biomarkers or any effect on the disease itself, certainly down the road, we can try to do a dose-ranging trial to see if we can optimize its effects even further.
Okay, thanks, Rick. Can you comment on cost?
Yeah, so Ted, 1 month's supply of theracurmin from Integrative Therapeutics at 90 milligrams twice a day is about $50.
Okay. All right, let me put you on the spot. And again, this is late March 2018. If I were to call you and say, hey, Rick, I'm going to recommend that all my patients read the ALS Untangled publication and then order theracurmin 90 milligrams twice a day, what would you tell me?
So, Ted, I don't think there's one treatment that's right for everyone. As you and I have talked about, there are many patients that are planning to self-experiment, and I personally think this is as reasonable as anything that we've looked at in the past 8 years with ALS Untangled. And I'll just say that if I wasn't very excited about it, I would not be spending my nights and weekends for the next probably 3 or 4 months trying to get a trial of it off the ground.
That's a good answer. Okay, Rick, any final comments?
Yeah, we talked about this in a previous podcast, but I just want to repeat it here. I know there's going to be folks with ALS who decide to try this, and I have no problem with that whatsoever. I just hope that they'll record what happens to them somewhere so the world can know about it. And there's a website out there, Patients Like Me, that's a great option for folks who want to track and record the results of their self-experimentation.
That's a great reminder. Okay, thank you, Rick. Again, I've been speaking with Rick Bedlack of Duke University.
Hello, everyone. I'm Dr. Richard Bedlack, professor of neurology and director of the Duke University ALS Clinic in Durham, North Carolina. I'm also in charge of education and outreach for the CREATE Consortium, which is part of the NIH's Rare Disease Clinical Research Network. CREATE is a clinical research consortium that's focused on therapy development for ALS and related disorders. CREATE aims to overcome some of the underlying barriers to therapy development with the goal of improving the success of future clinical trials. Today's podcast is part of a series we developed to try and help non-scientists understand some of the work that the CREATE team is doing. I'm very pleased to be joined again today by Dr. Nadia Sethi. Nadia is the Director of Community Outreach and Engagement for the ALS Therapy Development Institute and is the co-chair of the Northeast ALS Consortium's Patient Education and Advocacy Subcommittee. Nadia also lost her husband to ALS in 2020. In this podcast, Nadia and I will interview the authors of the recent publication entitled Harnessing the Power of the Electronic Health Record for ALS Research and Quality Improvement, CREATE, Capture ALS, and the ALS Toolkit. Dr. Jim Karras is professor of neurology at Wake Forest University School of Medicine, and this will be a joint interview with Dr. Michael Benatar, who's also been on previous episodes of this podcast. As you may recall, Dr. Benatar is professor of neurology and chief of the neuromuscular division and executive director of the ALS Center at the University of Miami Miller School of Medicine. He's also the director of the CREATE Consortium. I'll turn it over to you, Nadia.
Thank you so much, Dr. Bedlak. So to start with today, the electronic health record, or EHR, is in widespread use now. It's used to document clinical care and billing information. And with health data being recorded electronically, we have a potentially powerful tool for research purposes if we can compile the data from a broader population than with the limited groups that participate in observational studies. So today we're going to talk about the ALS Toolkit and the Capture ALS study. But could you start with giving a little background about what the EHR is and what EPIC is?
Sure, thanks for that, Nadia. I'm happy to start. I think you've covered it. The EHR is the electronic health record, sometimes called the EMR, the electronic medical record. And EPIC is one of the manufacturers of an electronic health record. There are a number that are in use around the country and around the world. EPIC is one that's used by a significant number of medical centers and clinical practices around the country.
Thank you. That helps a lot, putting things into context. Now, in this paper, you mentioned three main challenges to using data from the electronic health record. Those were that clinical data might not be gathered with the same rigor as research data, that clinical data are not always noted in the electronic health record in a structured way. So, for example, clinic notes will often be written in free text form, and that variation in clinical practice and style of documentation can cause some difficulties in documentation. So can you talk about how these challenges have been overcome in the past and what some of the challenges have been with those strategies?
Sure, I'm happy to start, and Jim, you may want to add to this. To be honest, I'm not sure these challenges have been successfully overcome in the past. I think some of the strategies have been for somebody to do the manual work of going and reviewing free text notes and other documentation and then trying to abstract data out of the medical record into a standardized form. Others have tried to use sophisticated technology like natural language processing to sort of digitally mine and pull out information from text strings. But all of these are labor intensive and very imperfect. And I'm not sure any of them, at least from the perspective of what we've done in the ALS community, have been successful in really enabling us to use EHR data for research purposes.
That's perfectly stated. It is a challenge to get organized information out of the EMR, even though it is encoded digitally, but the way it's normally documented just doesn't make it easy to extract. So the toolkit has given us a way to extract that information in an organized fashion.
Perfect. And that actually is a good lead into my next question, which is, can you tell us what the ALS Toolkit is and who came up with it and what it does? Just give us a broad overview.
Well, really, this is actually, originally the idea, I think, of John Katz at California Pacific. And John had approached me when we got the CREATE Consortium up and running to say this is an approach we should use to trying to standardize how we collect data. And together with Dave Walk at the University of Minnesota, the three of us really worked on the design of this with EPIC. And the idea really was, could we come up with a standardized way to document data that we routinely collect from ALS patients at the point of care in a way that is well structured and could be consistently done from one center to another center, in a way that would not be too disruptive to clinical practice, in fact, might enhance it in some ways, and might also give us data that could be used for both research purposes and quality improvement. And so I think that was the genesis of it. And perhaps I can just say, and Jim, you've probably been thinking about this longer than me, that I think this at some level has been a holy grail for many of us for a long time in terms of thinking about using the electronic health record for nobler purposes.
Right, rather than just a glorified billing program. All of us, I believe, are driven by a feeling that most of our patients cannot be in clinical research trials for one reason or another as they are set up. So most of the data we have on ALS patients is collected through clinical trials. That is a narrow segment of what we all do. This is an opportunity to collect data broadly. No framework is attached to this that allows you to collect a rich group of data on a lot of patients that actually this data is just not captured any other place.
I think that's right. I just want to add to that idea, and Rick, that I worry that in the past we've had sort of a biased perspective on the disease as we've studied a real small subset of patients. And part of the hope of the Capture ALS protocol and utilizing the toolkit is that we can collect data on as many patients as possible, if not all patients, that we're studying everyone with the disease.
I can imagine that that's going to be a very powerful set of data that we could draw on. So this is absolutely fascinating. So in the paper, you talk a little bit about the American Academy of Neurology quality measures and how you chose the types of data to be collected in the ALS toolkit based on those quality measures. Can you explain for our listeners what the quality measures are and why it would be useful to select data elements based on those in particular?
Yeah, I'm happy to take that too, since this is part of our thinking when we developed this. And, the AAN just happens to have a set of quality measures for the care of patients with ALS. And we like to have quality measures for all patient care that we provide. And part of the idea of a quality measure is that it gives us something to measure and to track, something to measure that's important to the care of patients, and the ability to track it, measure it, and then see if we can improve upon it. It's a general axiom that if we don't measure something, it's hard to improve upon. So, for example, every patient with ALS should be offered access to disease-modifying therapies, even if those effects are modest. And so one quality measure might be, was there a discussion with the patient about what currently available disease-modifying therapies are? Most of us think we have those conversations, but do we always have them? One way to learn whether we do is to build in a quantifiable data point that we can go back and look at and say, did this happen? And so as part of developing this and to make this useful clinically and to make it iteratively useful in improving clinical practice, we wanted to be able to measure all of the AN quality metrics that we could provide information back to clinics using the toolkit about how they might improve the quality of care that they deliver.
Perfect. And then will updates to the quality measures over time be incorporated into the ALS toolkit?
That's certainly the hope. And there's a little bit of a challenge just because it takes time to develop and then roll out and implement, but that is certainly the goal.
Great. Thank you so much. You talk a little bit about the ALS toolkit and how it overcomes some of the challenges to the data formatting. And we touched on that earlier, but can you go into a little bit more detail on how it overcomes some of those challenges from the past and what's new about the way that this works?
Dr. Caress, do you want to handle that one?
I can tell you about the end user experience, and you might be able to translate that up to the next level. The program is very clicky. So rather than sort of creating your scale of maybe you have a table in your note that might say, muscle power scale, and you've got a reflex table or something like that. The toolkit is a space that you work in to collect certain parts of data that are going to be helpful and useful in ALS patients. And it basically gives you a forced choice. You can click the button or not click it. And if you click it, you have a value of, for muscle strength, it might be 0, 1, 2, 3, 4, 5. And then that data is now captured in a specific part of the EMR that can be queried directly without the need for another sort of an artificial intelligence program to read that to understand what was happening in the node. It doesn't need to do that. That's a simple yes, no binary piece of information that is capturable, so that everything that we do in the toolkit is captured in that way. There's a little room for nuance. There are some comment boxes and stuff like that. But for the most part, it seems like it's going to be slow. But actually, most of us are clicking anyway, right? That's what we do all day now. And you're clicking either with your mouse or your keyboard. So it doesn't really slow down your documentation.
That's helpful, Jim. And maybe I can just add that one way to think about this is imagine you wanted to add up 10 numbers, Nadia. If you type them into an Excel spreadsheet, you could, use a function in Excel and sum them up and see what the total is. But if you type them out into a Word document, you need to then repunch those numbers into a calculator to calculate their total. So what the toolkit does is it makes the data more accessible and usable in its sort of native form and doesn't require some additional level of processing, whether manual or automatic, to make the data useful.
That helps a lot to clarify things. So you created these smart forms that make up the ALS toolkit. Can you talk a little bit about those and then explain, there's different categories on the smart form. So is it required that every category is filled out at every clinic visit? If you could just go into those smart forms and how those work.
Yeah, I'm happy to talk about their design, and maybe, Jim, you could comment on their use. I think the idea was that we wanted to create a suite of smart forms, and a smart form is just a collection of these data elements, and they're organized in a certain way. So one smart form might collect all the elements of the ALS functional rating scale. One smart form might collect all of the breathing information. So it's a way to just organize the clinical information that goes together in terms of who collects it and how it's collected. And the intent is not that everybody should fill out every field at every visit. We didn't want to impose a structure on the clinician, but we wanted to give a suite of forms that could be used based on what information is clinically appropriate to capture, that people have the option to capture it. And if people learn over time that they're missing a quality metric by not capturing certain information, maybe that will motivate a change in practice to capture that. So it's intended to be flexible.
Yeah, I think some of the smart forms are onset phenotype, diagnosis phenotype, genetics, ALS FRS. The smart forms can cover everything that you would normally think about and document with an ALS patient. But you do not have to fill out every smart form every time. There are some smart forms that I don't usually use. So there's flexibility in using part or all of the smart form.
Thank you so much. And then could you explain the patient level versus the encounter level data structure?
I guess I'll take that, and Michael will correct me, but the patient level data are basic demographics, onset phenotype, genetics, things like that you expect to not change over time. In the encounter level, things are like the exam, ALS FRS, that you do expect to change over time. There's some interesting things that happen when you start to use these forms in notes and how you typically generate your note. And I'm not sure this is the ideal time to talk about that, but there is a step going from the smart forms to actually creating your note. The two things are not the same. There are some differences in that. So if you're trying to copy forward a note, which many of us do, and there are some bad things about copy forward, but there are some good things. And one nice thing is that you can sort of compare how somebody was last time by altering the current exam from the old one. In this smart form, it doesn't quite let you do it that way. It erases your encounter level data, and then you'll go back and put it in new.
Yeah, perhaps I can just add an example of a patient level data might be the date on which non-invasive ventilation was started, or the date of permanent assisted ventilation, or the date of placing a gastrostomy tube. And often that information historically will get buried in a clinical note. And you either have to ask the patient again when that happened, or you have to go rummaging through to find it. By thinking of those data elements that can only hold one value for a patient and categorizing it as a patient-level data, it can carry forward from one visit to the next and always be pre-populated and present information in a user-friendly way. And we made the conscious decision, although I realize it's a little bit disruptive to an efficient workflow, not to pull forward encounter data from one encounter to the next, but we wanted to minimize the risk of cloning previous data and everybody not being super diligent about going and updating and changing what's new. So there may be pros and cons to that, but that's the idea that Dr. Karras was touching on.
Thank you so much. So you mentioned in the paper that the University of Miami, Cal Pacific University, University of Minnesota, University of Texas, San Antonio, and Wake Forest School of Medicine are already using this ALS toolkit. Have other centers since then begun using it as well? And would you potentially keep expanding to include all clinics in the US, or is there a goal in mind?
For sure. So we have continued to expand. We probably have another half dozen sites that are using it, and we hope that more will come on board. I should just clarify that the toolkit is built within the foundational EPIC system, and any center that uses EPIC can install these forms and use them. And there may be many centers that are doing this that we're not aware of. The Capture ALS is a research protocol that's IRB approved, that patients provide consent for, and perhaps we'll come to this. But one of the data collection instruments for that protocol is the toolkit. And so we certainly hope that any clinic that goes to the trouble of installing and using the toolkit will join this effort under the Capture ALS banner that will help us to aggregate data from patients across the country. So yes, our goal is to continue to expanding its use.
Michael, this is Rick just chiming in. We mentioned earlier the challenge of trying to make sure that we capture information on all of our patients. It's definitely a goal that a lot of us share. But there's also a new challenge that I see in ALS, and that is trying to get young investigators and small new sites involved in research. This seems like an ideal opportunity for both of those things. You mentioned that it's pretty easy to install the toolkit. I wonder if you could just talk a little bit more about how would a young investigator listening to this go about installing that? And then if they wanted to take the next step and participate in Capture, how would they go about doing that?
Yeah, so I can describe it briefly and just also refer people to the Muscle and Nerve paper where there are links and information included. You would need to approach your local EPIC team and draw their attention to the ALS toolkit. And if they go into the user website for centers that use EPIC and search for ALS toolkit, they'll find the documentation, your EPIC team, on how to install the special update and the documentation for doing so and the documentation for using it. That's sort of the first step that anybody can take. And if anybody's interested in joining Capture ALS, they can reach out and contact us, and we can walk them through what it will take and help them through that process.
Hey, that's great. One more question. I should know the answer to this, but I don't. Are there any other countries beside the United States that use EPIC? Is there a move in that direction? If so, could they be involved in this someday?
It's a great question. I should know this too. I've heard rumblings that there may be sites in Canada that are moving towards using EPIC as their EHR. I don't know beyond North America. Dr. Karras, do you know?
I do not know. That is a good question.
But Rick, you remind me that part of our goal when we built this is not intended to be EPIC-centric. We started with EPIC because it had very high sort of penetration in terms of its use across the country. But we'd really like to build out a similar instrument in Cerner and in other commonly used EHRs using the same data structure. So again, we can get to this goal of involving all of our ALS patients.
Dr. Karras and Dr. Benatar, I think you touched on this a little bit, but is there any special training that's required for clinic staff to begin to use this? And do you see that as an obstacle at all for this to get implemented?
I can comment on that. I do think there's a little bit of an activation energy. We've tried to make it as easy as possible. But I think, as with everything, if one lays a good foundation and you have somebody who's got a focused effort, and I think it needs focused interest and effort from the neurologist, from the investigator, and they need a coordinator or a research staff member who will dedicate some time and effort to this. I don't think it's an enormous lift, but it does require a little bit of focused effort. And so I would say if anybody is interested, you need to be willing to commit some time and effort. And there's definitely sort of an activation energy and a hump to get over to get going. And maybe Dr. Karras can speak to this, but I think it gets easier and easier the more you use it. Jim?
Using it is not particularly difficult. I think it's fairly easy for the neurologist who's leading the ALS group to generate the enthusiasm to use this. I think that it's easy to use. The trickiest part is implementing it, working with your IT people to get it pulled up from foundational EPIC into your own version of it. And then there's another step involved in trying to use this in your note. In theory, you can use the toolkit and not use it in your note, but it does capture a lot of very helpful data. And there are some real advantages to using toolkit data in your notes. So I like to do it, but that is another step to take, is to create that document that is a form that you can bring up to track your ALS patients with.
Yeah, I guess the way I look at it is there's definitely a little bit of work up front and some tending to it along the way, but it's not a super heavy lift. And I think that it's an investment that can really pay off handsomely if we embrace this sort of approach.
Thank you for that. And then within the ALS toolkit, is it just the neurologists who are inputting data, or is it other allied health professionals like the speech pathologist, pulmonology, et cetera? Is everybody able to record their feedback, or is it just coming from the neurology team?
I think it's flexible. I can comment what we do in Miami, and Jim, maybe you can comment on what's done at Wake Forest. But here we divvy up responsibilities, and all members of our multi-specialty team contribute to documenting the parts of the assessment and the evaluation that they do. So for us, it's a shared responsibility. Jim?
Yeah, at Wake Forest, the neurologist does most of it. The nursing team is also entering data, particularly ALS FRS data. The cognitive behavioral screening part of it, there are different people. It might be a speech therapist, it might be a nurse who enters that data. The respiratory therapists routinely use it and enter their data through the toolkit. So it's a little bit different.
I think, Nadia, part of it is that we wanted this to be flexible, knowing that every clinic operates a little bit differently. And so that's another thing that I think somebody who wants to use this needs to do, is to sort of plan and to sort of go through this and say who's going to do what, and train your clinic staff if they're going to use it, familiarize them with it so that it can fit well into the clinic workflow.
Thank you so much for that. I think one of the cool things about this is that it could kind of help to maybe standardize care, right? Because clinic notes might vary from one clinic to the next, depending on who's doing the exam and who's entering information. But since you're providing kind of guided questions through this ALS toolkit, do you think that might be able to help standardize clinic visits and care nationally? And would that be a valuable thing?
Jim, do you want to start with that? I'm happy to add in.
Yeah, I mean, it's a standard form. I'm not sure we want to standardize care quite in the way that you're thinking. I think all of us want to practice quality measures, of course. But when it comes to whether I check reflexes or not, I don't think that's an important feature of it. The system is flexible. You do not have to enter any exam data, for instance. So there is flexibility in that. When you use the system, it does kind of remind you, or I don't want to say push, but there are some data elements that are sort of suggested. And that might be a little different than my standard care practice. And I've adjusted to that a little bit. So I will maybe just, for instance, I don't normally measure FDI strength because I think it's difficult to know if it's 3, 4, or 5, or, well, anyway. So I usually use finger flexor. Well, the form kind of wants FDI to be highlighted. So I've started to use that. I don't think it makes a difference to patient care, but it is trackable. So from that standpoint, it might help all of us track the same thing longitudinally.
But I guess I would add, Jim, I don't know if this has been your experience, at least if somebody is maybe sort of newish to ALS patient care, it does perhaps give a framework of the scope of things that one could look at. And I'm thinking less here about the details of the elemental neurological exam, but the idea of talking to patients about end-of-life issues, talking about disease-modifying therapies, making sure one's measuring vital capacity and ALS functional rating scale, thinking about cognitive and behavioral screening. I'm sort of wondering whether at least having that available can serve as a subconscious reminder. And then, of course, if people look at data based on quality metrics, that might help guide care too. So I don't know. I wonder if it's a mixed bag with some potential, Nadia, depending on how people choose to use it.
Yeah, I think that makes a lot of sense. So now shifting to Capture ALS. Capture ALS is an IRB-approved study that aggregates data collected by the ALS toolkit after people are consented into the study. And you explain that the ALS toolkit can be used alone without participation in Capture ALS. Can you explain what additional components are available through Capture ALS? Do you have biosample collection, for example, as a part of that study?
Yeah, I think there are a few things that are a part of the IRB-approved protocol. The one is patients are explicitly giving permission for their de-identified data to be shared and aggregated and used for things like research purposes. And so we have that ability then to aggregate data and generate that larger data set and learn about a broader spectrum of patients. But we've also incorporated a one-time collection of a blood sample for DNA analysis. We haven't yet secured the funding to do the genomic analyses in all of those patients, but we felt it would be important to have. And we see this as a potential sort of launching pad from which we could build in longitudinal collection too, to add biorepository and biological samples to the clinical data that comes out of the clinics and could be helpful for sort of more basic biomarker discovery and validation work. I think we've tried to start sort of simply, making the sample collection just once off, but there's certainly potential to expand.
I think that's the beauty of this protocol, is that it does have this sort of non-biased approach to taking care of ALS patients and tracking that data. So in many circumstances, I think it's just data that just isn't out there at all. And we should be able to capture that data and look into totally new things, looking at the last 6 months of life for people that are in kind of a plateau stage for long periods of time with upper motor neuron dominant ALS. Groups of patients that we just can't normally study very well because they're not in clinical trials. The other point I would mention is that I use this toolkit from the beginning. This is not part of capture because, of course, the patient has not consented. In fact, they haven't even been diagnosed yet, but they're referred to me for ALS. They're highly likely to have it based on my review of the notes. So I will start using the toolkit with that initial encounter, and I will carry that forward into my follow-up ALS clinic notes. And one nice thing about the protocol is it can go backwards in time. So if I am consenting the patient at 3 months or even 6 months after I've seen them for the first time, that data that I started collecting back 6 months ago is now part of the data set that can be examined through the IRB-approved capture protocol.
Thank you. And because this data is being collected through the electronic health record, what are ways that the data is kept secure and de-identified? And what is the personally identifiable information that's included in the study?
Yeah, I'm happy to say a few words about that. This is an important issue. We always want to be sure that we are protecting patient privacy and confidentiality. And this study is built in this way. So firstly, patients provide consent and they sign a HIPAA authorization to release and to have their data shared. But the data that's pulled out of the toolkit and out of the electronic health record does not include things like names and addresses and contact information. And so it does not include personally identifiable information in that way. But it does include what's called a limited data set. So we do have dates of visits because we want to know when these measurements were made and how far apart clinic visits were. But what we do, and we have data use agreements in place between all of the participating sites. This all goes through data brokers at individual sites. And the data then transferred via secure mechanisms to a secure server where the data are quality controlled and checked to make sure that no information has come through on patients who have not provided consent. And at that point, the data are completely stripped of identifiers, including dates, so that the research data set that comes out at the end of that and comes out of that super secure environment is completely de-identified. So we have several checks and processes along the way to make sure that we're always protecting patient confidentiality.
That's very good to know. You mentioned that one of the main goals of the Create Capture ALS study is to validate the EHR data. Can you explain more about that?
Yes, I'll say a word, and Jim, I'd love your perspective on this too. So I'm not sure that what we always collect in clinic is as sort of rigorous as what we do in a research study. So if somebody's participating in a clinical trial, a person, for example, doing a vital capacity or an ALS functional rating scale has been trained and certified, and the data are monitored and quality controlled and errors are caught. The same is not true of what's done in the clinic. While we might all, and we do, train staff to do these procedures, there isn't necessarily the same rigor. And so the question is, if we're going to use those sorts of data elements for research purposes, we need to know how reliable they are, how robust they are. And so because we're hoping that all patients at participating sites participate in capture, it's also the case that a subset are participating in more dedicated studies, formal observational studies, clinical trials. And by using things like the global unique identifier, we have the potential to link up those data and to compare what's collected clinically to what's collected in a more rigorous research setting for us to understand what are the strengths, but also the limitations of the data collected through the electronic health record.
Yeah, I think that is going to be very helpful to compare what happens in the clinic to what happens in research and sort of see how similar that data is and to sort of assess the quality of what we do. I'm also kind of interested in looking at this as a measure of what happens in the EMR. So those of us who do this for a living, we know about copy forward and the problems with copy forward and the tendency to actually sort of assume things have not changed and maybe not examine those things again, but just to use the copy forward data. Some of the encounter level data that we collect by using the toolkit, you cannot do that. You have to re-click the buttons, which does two things. One is it's easy to click a button and maybe not necessarily do that part of the exam. I'm interested in that, but I think this is going to be a much more true measure of what's actually collected during a clinic visit, as opposed to what we used to do. And I'm kind of interested in using this as a way of looking at the accuracy of the EMR in general.
And could you both speak about the potential impact of collecting large volumes of longitudinal and demographic data through Capture ALS? And can you give us some examples of ways this data could be used by researchers?
Yes, I guess one of the impacts that we've discussed and I'll sort of touch on is this idea of who we're studying. So, in South Florida, a large proportion of our patient population is Spanish speaking. 65% of our local patients, for example, speak Spanish in the home. If I look at the proportion of Spanish speakers in our clinical trials, for example, they don't begin to approach those proportions. But in Capture, because we enroll everybody, those numbers do reflect that full spectrum. And so I think we're going to be far more inclusive and diverse in the nature of the research data that we collect than we've had in the past. And I think it's always the case that when you study the whole population as opposed to some small subset that may not be representative, there are things to learn. So I think those are some of the insights that we may gain.
That's a really great point. I think besides diversity, just diversity in phenotypes is one of my particular interests about those patients that live longer than 5 years. Why do they live longer than 5 years? That would be a really good thing to know. And those groups of patients are never in clinical trials. So they just aren't studied very well. So I think this kind of data that we're collecting will help us understand those phenotypes better, hopefully eventually link up with the genotypes. I think we can also use this kind of data to look at very long-term safety and potentially efficacy of some of the medicines that we're all using now that generally were studied over 6 or 12-month periods and not 3, 4, or 5 years. All of us are now very interested in the intersection of the 3 FDA-approved medicines for ALS and whether we're going to see some kind of synergy between these drugs. And that is not going to be formally studied by a drug company, but this kind of database might allow us to begin to see that kind of effect.
Yeah, and I want to add to that, Jim, I really think this kind of approach can enable us to do sort of phase 4 studies. I think that's what you're saying, right? Learn how these drugs work or don't work in real-world clinical practice.
Yeah, I agree completely. It's like a phase 4 study.
Yeah, just to take that one step further, as you guys know, one of my own interests is in capturing data from the many people in our clinics who are self-experimenting with different alternative and off-label treatments. It sounds like it might someday be possible to run a report looking at correlations between the start of a product, say a supplement, and the change in the slope of an outcome measure like the ALS FRSR. Is that right?
Yes and no. And Rick, this is something we spent significant time looking into. So it turns out that many of these alternative and off-label therapies are not coded formally as part of the pharmacopoeia or formulary that's in the electronic health record. We had actually submitted a grant that wasn't funded to try to do the work of coding that so that we could formally capture it. And maybe we can find funding elsewhere. But currently that's going to be challenging because those alternative and off-label therapies are not formally captured in the EMR. They will typically be in a text string.
I could add one more point about this that I think is important. In my center, I'm always trying to find ways for people to contribute. And I have many patients that want to be in research, they want to do something, and they present just too far along in their course. They are not going to be eligible for clinical trials. And to be able to offer something like this to those patients is really important, not just for us as ALS researchers, but I think the patients feel like I am contributing. I am now part of an effort to defeat this disease. And I really like being able to offer it to everybody.
Thank you for that. And do you know if similar studies are being conducted in other disease areas?
I'm aware of at least some outside of neurology that have actually done some nice work looking at sort of genotype and phenotype relations. And that was part of our stimulus to want to at least put in the freezer some DNA samples. But we're also trying to now start doing this in some other neuromuscular diseases, trying to learn from the experience, both good and bad, of working through development of the ALS toolkit and rolling it out. What have been the pain points, the pressure points, and how can we alleviate those? So my hope is that this kind of effort will continue to expand. We'll do this in many more other areas.
And I think on that note, it sounds like this is an open-ended study that can just really include pretty much everyone who's living with ALS, and that there's no maximum number of participants that we're looking for.
No, I think that's right. I mean, one of the things we have found, and this comes back to one of your earlier questions, is that there is some work to be done up front to sort of get this set up and in place and ready to go. And we've been fortunate to secure funding from NIH, from MDA, to be able to support sites and sort of going through that initial period. And what we've tried to encourage people is, while we have that funding, to enroll all of their prevalent patients. And that way, as funding might decline, if it does, the workload to sustain this becomes less, because we only have to continue to enroll our new incident patients. So the smaller number of people who are newly diagnosed every week, every month, every year. And so I think if we want to make this self-sustaining for the future, we need to really use as well as we can the opportunity of funding and scarce resources to get over that initial hump of activity, so that this can at some level become either self-sustaining or sustaining with minimal continued investment. We have a ways to get there, but that's certainly the long-term goal.
Well, as usual, I've learned a ton today. Jim, Michael, thanks so much for your time. Nadia, great questions. I think we should check back on this project maybe in a year or so, whether there's a paper or not. I think our listeners would love to have an update on what we're learning.
Great. We'd be delighted. Thank you.
Thank you.
Thank you.
Hi, I'm Ted Burns. I'm a neuromuscular specialist at the University of Virginia, and I'm again talking with Richard Bedlack. Richard is an ALS specialist at Duke University, and he heads up the ALS Untangled group. This podcast is supported by the CREATE Consortium. CREATE stands for Clinical Research in ALS and Related Disorders for Therapeutic Development. The major focus of CREATE is to advance the science that aids development of therapies for patients with ALS and related disorders. The CREATE Consortium is currently made up of 15 clinical sites on 3 continents and many other U.S. and international scientists and collaborators, and it forms part of the NIH's Rare Diseases Clinical Research Network. Today, we're going to discuss number 39 of the ALS Untangled publications. This one is about AccuScope. Before we talk about AccuScope, Rick, can you remind the listeners how to find these publications?
Sure, Ted. Just go onto our website, www.alsuntangled.com or .org. And on that website, look under the completed review section, and we list all the things that we've written about. Next to the name of each thing that we wrote about, you'll see the grades that we gave it. And you can also click on the name, and it will open up the article that you'll be able to read for free.
Great. Yeah, it's pretty easy. All right, let's start this interview on AccuScope by having you provide a little brief background on it. It's also known as electroacuoscope. And Rick, while you're at it, would you mind talking also about functional electrical stimulation?
So, Ted, the AccuScope is a machine that delivers very low amplitude, what we call microamp electrical stimulation to muscles. This amount of electricity is too small to make the muscle twitch, and that's what distinguishes it from functional electrical stimulation, also called FES. FES uses currents that are large enough to make a muscle twitch. They tend to be in the milliamp range, and we will actually do a future ALS Untangled on functional electrical stimulation.
Okay, thank you. Now, I got confused when I was trying to understand the purported mechanism of AccuScope. Can you briefly comment?
So AccuScope is advertised to be able to read and repair the body along acupuncture meridian lines. And that's really the first big problem we had with this. There is no good biological evidence for these meridian lines. And even if AccuScope could somehow read these mysterious patterns, we wondered, how might it actually repair anything? The AccuScope advertises itself as being able to open ion channels, which allow good things to flow into muscles and motor neurons like nutrients and calcium, and bad things to flow out like toxins and waste products. And I'll say this, it does sound a little hard to believe, but there is an experiment out there in which microamp current applied to isolated rat skin was enough to alter cell membrane transport, protein synthesis, and even ATP generation. Now, of course, there's no way of knowing if the effects that we're seeing in isolated rat skin could possibly translate to what would be seen in the motor neurons of a living person with ALS.
Okay, and when I was reading the publication, I was disappointed that there is so little evidence to support the use of AccuScope, and that's as of March of 2018. And I must admit that as I was reading the publication, I was a bit surprised this alternative treatment has as much interest as it might. Can you comment on that?
Sure. So we set up ALS Untangled, with a really open mind and the idea that we would prioritize our reviews based on two things. First, the number of votes each one gets, and second, the amount of disclosable information that we have. So, we might have something that has 1,000 votes, but if we can't find anything about it that's disclosable, we can't write about it. So AccuScope got almost 400 votes, and we thought we found enough disclosable information to write about it. Unfortunately, we felt like the mechanism was questionable. The one person that we found that was actually trying this for ALS said she felt better, but her ALS FRSR progression in her records was actually faster while she was using this product. It's also pretty pricey. An AccuScope therapy session might cost somewhere between $80 and $250, depending on how many body parts are treated. And it's recommended that people have several sessions per week. So the total cost of this could be $1,000 a month or even more.
Yeah, Rick, I was really disappointed to read about the cost also. Is there anything else you think people with ALS should hear about this option?
So, Ted, it's not one of the many things that my own patients ask me about. It is not something that I typically bring up when folks ask me about things they can experiment with, just because, as you pointed out, the mechanism is pretty flimsy and there's really not even a lot of good anecdotal data for this one yet.
Okay, thank you. Again, I've been speaking with Rick Bedlack from Duke University.
Hello, everybody. I'm Dr. Richard Bedlack, professor of neurology and director of the Duke University ALS program. I'm also in charge of education and outreach for the CREATE Consortium, which is part of the NIH's Rare Disease Clinical Network. CREATE is a clinical research consortium that's focused on therapy development for ALS and related disorders. CREATE aims to help overcome some of the barriers to therapy development with the goal of improving the success of future clinical trials. Today's podcast is part of a series we developed to help non-scientists understand some of the work that the CREATE team is doing. I'm very pleased today to be joined by my colleague and friend, Dr. Nadia Sethi. She is Director of Community Outreach and Engagement for the ALS Therapy Development Institute and is also co-chair of the Northeast ALS Consortium's Patient Education and Advocacy Subcommittee. Nadia lost her husband to ALS in 2020. In this podcast, Nadia and I are going to interview the authors of the recent publication, which is entitled Neurofilament Light Chain and Drug Development for Amyotrophic Lateral Sclerosis, a Critical Appraisal. And we're joined by Dr. Martin Turner, who's professor of clinical neurology and neuroscience at the University of Oxford, as well as Dr. Michael Benatar. He's professor of neurology and chief of the neuromuscular division. He's also executive director of the ALS Center at the University of Miami Miller School of Medicine. And finally, he's the director of the CREATE Consortium. I'll turn it over to you, Nadia.
Thank you so much, Dr. Bedlack. Hello, Dr. Turner and Dr. Benatar. We're really excited to talk with you about NFL and its potential roles as a biomarker for ALS today. So currently, there's 3 approved treatments in the USA, Riluzole, Radicava, and Relyvrio, that all have modest effects on the disease. And these treatments were not granted approval based on biomarker data. And now there's a new 4th treatment that was just approved called Qalsody for a specific type of ALS that occurs from mutations in SOD1. And biomarkers played a big role in the approval process for this drug. So could you talk a little bit about the conflicting messaging that we've seen recently in the last couple of years around biomarkers and in particular neurofilaments, and some of the discussion between the most recent approvals between Relyvrio and Qalsody? And I think that's going to help set the context for today's discussion.
Sure. So I guess what I would say is that historically, drug approvals in ALS have really been based on clinical outcome measures. So measurements of functional decline or on survival. And what's different about tofersen, this SOD1 antisense oligonucleotide or Qalsody that's recently approved, is that it received accelerated approval from the FDA based on a change in a biomarker, NFL. And it's that change that the FDA and I think many of us in the academic community believe is reasonably likely to predict a clinical benefit. And so that may not be universally accepted, but the FDA has bought into it. I think there's good data to support it. We still, of course, want to see the clinical benefits, and that's additional data that needs to be generated. But perhaps that's what you're referring to. Redirect me if otherwise.
I think with Relyvrio, as the approval discussions were happening, there was some discussion from the scientific community that NFL wasn't relevant. And now we have, Qalsody where NFL is very relevant. So I think that's where I was going with the
okay, I got it. So that's a helpful context. I mean, I think that as you're alluding to with Relyvrio, the phase 2 study that was done met its primary clinical endpoint. But a change in neurofilament, and in fact, neurofilament heavy was one of their highly ranked secondary outcome measures. I think either the first or the second in a hierarchy, and there was no change in neurofilament. And I think people at the time, some people argued that that didn't matter. Some of us might think otherwise, and maybe the phase 3 study of Relyvrio will tell us whether that was important or not. I don't know about Dr. Turner, but I disagreed with some of the statements at the time that were made that neurofilament doesn't matter. I think it does.
Yeah, I would take an agnostic view here, really. And my enthusiasm for neurofilament, particularly neurofilament light chain, is sort of independent, really, of trials that have gone before. And actually, although it's helpful what we're seeing with tofersen, it's sort of independent of that as well, really. And I'm sure we'll get into the detail of this, but we're faced with a biomarker that's relatively accessible, which has really quite a reliable and robust link to disease activity in patients. And that's somewhere we've never been before. So I think it's early days. So broadly speaking, the drugs that have been licensed, it's possible that their effects are of a magnitude that are insufficient to shift the disease activity in relation to neurofilament. It's possible that they're having effects entirely independently of neurofilament. I think that the biological explanations for that are a little bit difficult, but we'll get into the detail of that perhaps later as well, given that we know people with slower disease progression rates will have lower levels of neurofilament, so it's not unreasonable to expect the two to go hand in hand. But it's early days, and I think we're excited about the biomarker. I don't think we need to validate it against previous trials as things stand at the moment.
Thank you so much. That's very helpful. So we're going to backtrack here a little bit and talk more generally about biomarkers. So I think in this paper, you discuss a little bit about how biomarkers are fit for purpose in drug development for ALS. So could you both maybe talk a little bit more about that? How are biomarkers fit for purpose in drug development for ALS?
Yeah, I'm happy to take a stab at that. And I sort of wonder whether an analogy might be helpful. You can tell me. I think about biomarkers like sort of tools in your toolkit. A hammer is great for hammering a nail into the wall. A screwdriver is not so helpful for that purpose. Likewise, a screwdriver is great for putting a screw into the wall. The hammer may be less effective at it, right? So when we're thinking about developing biomarkers, we have to think about what are we going to use them for? Are we going to use them to help diagnose disease? Are we going to use them to help predict who might respond to a particular treatment? Are we going to use them to predict how disease will unfold? How quickly will it move? How slowly will it move? Or are we going to use it to tell us who might develop disease or who is or isn't responding to a therapy? And those are all different ways in which we might use a biomarker. And as you might imagine with the hammer screwdriver analogy, not every biomarker is well suited to every purpose. Some might be suited to multiple things, but we need to establish that empirically. So I think that nuance is important when we're talking about biomarkers.
Thank you so much. And could you also go into how the FDA and NIH define the many different types of biomarkers that could be used in drug development?
I mean, I think I've touched on some of that and we'll walk through that in more detail, but some of the categories are diagnostic markers, help to diagnose ALS differentiated from diseases that might mimic ALS. Prognostic markers, markers that we can measure when we initially see a patient that tell us about the future course of disease. Predictive biomarkers that tell us who might respond to a particular treatment. I mean, a good example there is having a mutation in an SOD1 gene is predictive of a likelihood of responding to an SOD1 gene therapy. We wouldn't give an SOD1 gene therapy to somebody with a C9orf72 mutations. That's a predictive marker. A response biomarker is a marker, as we discussed a little bit with neurofilament. If it goes down in response to a treatment, that shows that there's been a biological response. And then there's this concept of a risk or a susceptibility marker that tells us who might develop disease in the future. And there are other kinds. There's safety biomarkers too. We measure these all the time when we're looking for drug side effects. There's a variety of others, but those are the flavors that I think are most relevant to this discussion.
Perfect. And that was really helpful. My next plan here today is to go through in a little more detail and talk about some of these different types of biomarkers and how we could use NFL in these different contexts. So could you talk a little more about the susceptibility or risk biomarkers and how NFL might be used in that way?
Yeah, I might suggest actually, would it be okay if we kick off with diagnostic biomarkers more generally, really? Because I think that's where we're making most of our sort of decision points around ALS and management. And actually, I think it's, for our purposes, it's one of the hardest areas really for us to develop a biomarker. Most ALS is going to present very insidiously. I think many of us are struck by, in many of our patients, how athletic they are and generally the good health they've had beforehand. And so when the disease first presents, the symptoms are not going to be instantly considered to be serious. And there's going to be a significant amount of delay in presentation and also sometimes recognition that the primary problem is neurological. So a biomarker in those contexts is only ever as good as the person who is thinking, could this be ALS? In which case, could I employ this particular test? And so actually the reachable population for that sort of marker, if we had one, is actually quite small. The real way we could make, I think, some valuable inroads is with the more complex atypical presentations of ALS, which are often typically a little bit slower than normal. And those cases can sometimes be difficult, and we want to make sure those patients aren't delayed opportunities to access trials and other supportive care. So there is a role for diagnostic biomarkers, but it's quite small as things stand at the moment because of the way ALS presents. But I think there's a slightly different group of people, which I'll hand over to Michael about, who we do have an indication that the disease is much more likely to happen. And in that group, when we've already got a priori view that things are more likely to occur, then it has a different role. So Michael, do you want to expand on that?
Yeah, I mean, so this idea of sort of a risk susceptibility biomarker or using neurofilament in this way, an idea emerged out of the study of pre-symptomatic gene mutation carriers. So people at a markedly elevated genetic risk of developing ALS. And one of the challenges for people who carry those mutations is disease can develop at any age. We're not good at predicting when that's going to occur. And so that makes it difficult if we're trying to think about early intervention or prevention approaches to know when we should bring those to bear. Somebody with a genetic mutation could develop disease when they're 20 or when they're 70. And one of the key observations we made, back in 2016, 2017, I think, was that in a subset of people, particularly those with SOD1 mutations that are associated with rapidly progressive disease, that blood levels of neurofilament light go up in the 6 to 12 months before there's any symptoms and before there's any overt clinical sign of disease. And so in that way, NFL emerged as really a risk or susceptibility biomarker telling you that there was a high likelihood of developing ALS within the coming 6 to 12 months. So I think that's how we think neurofilament light might be used as a risk susceptibility marker in this population.
I might just add, actually, that one of the key issues around the diagnostic biomarker problem is that ALS is, of course, a rare condition. And so we might aspire to go to the entire population and screen them for ALS, but that's not going to be something that we can do realistically while we don't understand what the risk factors for typical ALS are. And also the wider point is that by the time currently most ALS is coming to see a neurologist, the diagnosis is in a lot of cases very clear. And obviously we don't want to delay accessing treatment in those patients. So that's why it's a more difficult challenge.
And maybe just to add to that, I think embedded in all of what we're saying is that, at least I think, that neurofilament light has a very limited role as a diagnostic marker. It is, after all, non-specific. Any cause of neuronal injury can lead to an elevation of NFL. And so I think it's one of the ways in which maybe as a field, we've collectively gone off the rails a little bit early on, thinking about this as a diagnostic marker. And of all the potential utilities, I think it's the least helpful. And so hopefully we'll shift gear and talk about some of the things where I think it is more helpful.
I think that's very helpful to hear. Thank you so much. And there's now a commercial lab test for NFL that people can get. They can do a blood test now in the US and measure neurofilament levels. And there's questions in the patient community about whether this can help with early diagnosis. So I think going back to some of your points, I think this will help provide clarity to the community. Can a test like that be used to help with diagnosis at this point?
So I can add in a little bit of data that we've got from our clinic where we took people who were referred to the clinic and we made a decision on clinical grounds, and the standard investigations that they'd had already, we labeled them as having ALS or having something else, or that we weren't sure. And one of the problems is that, and then we looked at the neurofilament levels in all of those cases, and undoubtedly a significant proportion of people who have ALS, and there's no doubt about that, and they've gone on to have a typical course of ALS, undoubtedly a large proportion of them would not have had a significantly raised neurofilament level. Conversely, people with a different disorder, so-called ALS mimics, they're not common, but they do occur. There are some patients in that group who would have an apparently raised neurofilament level. So it's neither sensitive nor specific to make the diagnosis of ALS. So just to reiterate what Michael said, the real value, and when it becomes very, very exciting and interesting, is after the diagnosis of ALS is made in that population, then we can start to use it to stratify them.
Thank you so much for that clarification. That's very helpful. Okay. So can NFL be used then as a predictive marker? And what's the difference between a predictive marker and a prognostic marker?
So I'll take a stab at that, Martin, and then if you want to jump in too. So the words are confusing because they sound like they might mean the same thing. So let's sort of separate them out. And I touched on this early on, but it bears repeating. So a prognostic marker tells us about prognosis, what the future course of disease would be in the untreated state. So the idea would be with neurofilament specifically, if we measure it when we first see a patient and levels are very high, that would suggest that the disease is progressing quickly and that function is going to decline quickly and that survival might be short. If neurofilament levels are low when first seen, we might predict a slow functional decline and a longer survival. So in that way, measuring neurofilament early on tells us something about the future course of disease. And as neurologists who look after patients, and you know this as well as a caregiver, when this diagnosis comes, people want to know, how long do I have? What does the future look like? And this is not a perfect predictor, but it's a helpful marker that tells us something about that future course of disease. Now, that's very different to a predictive marker, which is a marker that tells you that you're more or less likely to respond to a particular treatment. And maybe we'll touch on that more, but I hope that helps to sort of distinguish them. I don't know, Martin, maybe you've got a better analogy than I could think of off the top of my head.
No, I agree entirely with that. I think of it as a disease activity marker, how fast things are going, almost a sort of speedometer. What's important to say is that this is all grounded in something very important about ALS as a clinical syndrome. I mean, it's difficult to sort of prove this, but for decades, actually going back to the 19th century, physicians have observed that individuals with ALS set their own pace for the condition. So what we observe in the clinic, and we can confidently tell patients, is that when their disease is progressing slowly, it will usually remain more slowly progressive. Unfortunately, we have to also be straightforward with our patients. When the disease is progressing rapidly, it's very unlikely to slow down. So there is a part of ALS that sets its own pace. And that's why neurofilament seems to tap in quite well to that, in that individuals seem to then have an associated neurofilament level that stays rather similar for them throughout their disease course. So it ties in both very nicely with disease activity at that given time point, but also the future, which tends to be quite a stable course. Now, individuals do vary, of course they do, and we know that. And the markers that we use around disability, things like the ALS Functional Rating Score, are not perfect. But I think overall, it's a very solid way that we practice ALS neurology. As neurologists, we do rely on the fact that individuals tend to give us a clue as to how the disease is affecting them. And that's what's so exciting about neurofilament, because it seems to provide at least an objective marker that we can then use, as we'll discuss later on.
Martin, could I just ask a question following up on what you said? because this is one of the places where I'm struggling right now. I'm seeing more and more clinics starting to order this just as a routine part of ALS management. And I guess I just don't really understand that. So to me, we have lots of things that tell us how a patient has progressed coming into us the first time. And I don't know. I don't right now see the value of adding a neurofilament when a patient is going to ask me how they're going to progress. I mean, I can tell them in general they're fast, average, or slow. And I don't see how that neurofilament level helps me that much at that first visit. A lot of times people want more specific information. When am I going to be in a wheelchair? When am I going to need the ventilator? I don't have any tools that give me that kind of clarity yet. And I don't see that neurofilament does that either.
You're correct. And they are the questions that need answering. You're absolutely correct that neurofilament doesn't answer those. The interesting point is, as you're saying, you're able already with the measures that you have, and some of those are your skill as a neurologist, but also we know there are some very simple metrics. Unfortunately, the faster you get to a specialized neurologist is a poor prognostic sign. It's a marker of aggressive disease. So there are many, many ways spread from one limb to another that we can put it together and advise people accurately. So neurofilament, I think it's not going to be a tool that's useful in the hands of an individual for their particular sort of day-to-day, week-to-week, month-to-month monitoring. But it starts to become powerful in the context of relatively small groups of patients when you might start to intervene with drugs, where then we know in trials it's not going to work if we go to patients and say, do you feel better on this drug? Do you think you're getting better? Or do you think you're getting worse more slowly? A patient can't assess that. Neurologists can't assess that at individual level. So we need some sort of marker. And I think neurofilament has great potential in that setting. But an important distinction, Rick.
Yeah, but I just wanted to add, when we're talking about NFL as a prognostic marker, I think we can think about using that in different ways. And maybe this is the context in which it's used. So it may not be so valuable to draw this on an individual patient and say, based on this, you're going to progress at X rate. I don't think we yet have that sophistication to know how to make that interpretation. But where it is valuable is when we do clinical trials, we know that there's enormous variability in how rapidly people progress. And that's true in the drug group and it's true in the placebo group. And that makes discerning the signal challenging. But if we incorporate NFL as a prognostic marker into our models of what the effect of the drug is, we can sort of explain away or account for the natural variability as captured by the neurofilament level to enable us to detect therapeutic effects over a shorter period of time with a smaller number of patients. And so at a group level, NFL is powerfully predictive prognostically, and it adds value over and above the thing we typically know clinically. And so I think that's an important way in which this becomes a very, very helpful tool for drug development.
This concludes part 1 of this podcast interview. Please join us for part 2, which has already been posted. Welcome back for part 2 of this podcast interview, which continues from where we ended part 1.
I think that's a nice transition into my next question, which was actually about endpoints in current clinical trials. Right now, we're relying on the ALS FRSR for a large part. Can you talk maybe about some of the challenges with that measure and how NFL might be a potential future marker that could help with this?
Yeah, I mean, the ALS FRSR has come in and out of fashion, but it's been around a long time. And I think personally, it's given us a huge amount in our day-to-day practice. It is very, very challenging to capture the complexity of the disability in ALS across the different domains. And there are still some questions about whether it really captures in the same way things like respiratory domain, which tends to come later in a lot of patients and perhaps doesn't tend to progress in quite the same rate as other domains, for example. So it's not perfect, but when we plot the rate of decline over the main part of the ALS-FRS, for most patients, it's relatively stable. And that again fits with what we saw in the clinic and we've seen for years with patients. So it has enormous value. And the difficulty in a trial is that there is some variability between measurements, between visits. And within a trial, even with the best intentions, you end up with a heterogeneous, a very mixed population of patients, all of which will be progressing at different rates. So the way I see neurofilament helping is that it adds a little bit of quantitative measurement. It's not really necessarily a direct replacement. And in fact, a lot of the work we've done showing neurofilament has value is based on the ALS-FRS. So we should be clear about that. It has a slightly circular argument. But it gives us a quantitative value, which I think can add much more power. And certainly when we model that using the ALSFRS and adding in neurofilament, we can see that we get much more traction within a heterogeneous group to show a change. So, over to you, Michael.
No, I just wanted to add that I think, Nadia, to your point, most clinical trials in the past, even phase 2, have used things like slowing the rate of functional decline on the ALS-FRSR as the outcome. And the fundamental challenge there is that by and large, that leads to those studies being underpowered. And so at the end of the studies, it's hard to know, should this move forward into a larger phase 3 efficacy study? Of course, how patients function and feel and survive is what really matters, right? People have got no interest in my neurofilament went down if it doesn't translate into something of value to how they feel and function. We just think it's challenging to use the FRS in sort of small phase 2 studies to make decisions about whether something is or isn't likely to be working. And that's the potential utility of a biomarker, and neurofilament is the most mature one in that state that could be used. To put that another way, I want to come back to what Martin said, is that the way we think about neurofilament, it's like the dial on the speedometer. It tells you how fast the disease is traveling. And you can measure it once, and it tells you how fast the disease is traveling. So you can see the value. If you give a drug and you slow the speedometer, you can say, well, the disease is progressing more slowly. That's a good thing. You don't have to wait to see, is function declining more slowly than it otherwise would have, which you don't know, or is it declining more slowly than a comparator group, which takes time and larger numbers of patients. So those are the ways in which neurofilament can be helpful as an adjunct to these clinical measures, which are ultimately what matter, I think, for drug approvals.
So, Michael, just a follow-up question there. I mean, I love this idea of using it as a way to screen, maybe a sort of a go, no-go decision for a phase 2A study would be safety, tolerability, and a drop in neurofilament. But what is a meaningful drop? Is it any drop that's statistically significant? Does it have to be 50%? I mean, do we have a sense of that yet?
Yeah, it's a very good point. And I think at the moment, the way we're modeling this and moving forward, it is going to be rather arbitrary to start with, which is why it's still exploratory. We can look in large cross-sectional cohorts, and we can look at people with rates of progression which we would regard as slower than average and see what the neurofilament levels are associated with that, and see then what the drop would be in terms of percentage terms from people who are above the median for rate of progression. But, we will end up picking arbitrary figures. And certainly when we have modeled this, we've tried to say, well, look, we think with ALS-FRS, we need at least 9 to 12 months to show a difference in slope with a reasonably homogeneous group of patients. We should just say that the previous measure of survival takes 18 months and, of course, is just an unreasonably blunt instrument to use. So we'd like to try and bring neurofilament into the realm where we could make a decision at least on, is there some tangible evidence of human benefit as marked by a drop in neurofilament at around 6 months? And can we do that in a smaller group of patients? So instead of 200 to 300 patients in a trial, can we be doing this in 50 to 100 patients, or maybe 30 to 50 patients? And when we start to look at those sort of numbers with patients who are in a reasonably tight range of rate of progression, we start to see that neurofilament can power that at reductions around the sort of 20 to 30% level. And, I think it's enough there to go forward in that exploratory way as a go, no-go marker. But, clearly it will have to evolve. We'll have to see how that relates to what we hope will be clinical benefit that we'll start to see further down the line.
Yeah, I wanted to add to that, Rick. I think this is a tough question. We don't know the answer, but we're trying to begin to get a feel for it. And one way is to say, if neurofilament level is, 100 in somebody who's progressing at 3 points per month, and neurofilament is 50 in somebody progressing at half a point per month, right? There's a reasonable argument to be made to say, well, if we could drop neurofilament from 100 to 50, that might correspond to a slowing of disease progression of that sort of magnitude in the ALS-FRSR. Now, that's an assumption. We don't know that, but that's one way to think about it. Another is to say, how do we know what's a clinically meaningful difference in the ALS-FRSR? Remarkably, we've not done a good job of asking patients. We've asked neurologists to say, well, slow the slope by 20 or 30%. Well, we could as easily arbitrarily say, if NFL is a speedometer, slow it by 30%, and we'll regard that as clinically meaningful. So part of this is how we sort of define it, but ultimately I think we have to see how this translates into benefits that patients feel. So I think we're taking steps along the way, but we're not there yet to fully answer that question.
And the other point I think that we need to think about is, do we know much about the natural history of neurofilament in people? Like, I'm interested in these spontaneous plateaus and even these reversals that people have on other outcome measures like the ALS FRSR, trying to understand what those mean. Do you see those with neurofilament? Do people just spontaneously have their neurofilament levels go way down at times during the course of the disease?
I think the short answer is no. I think what was one of the first things that we all started to see in our cohorts was this stability over time, this flat lining that occurs. So when it's high, it stays high, and when it's low, it stays low. Now, there are intra-subject and participant variations, and that is, again, something we need to test and see and how that stacks up in the real world. But yeah, I don't know about you, Michael, but I haven't seen any sudden drops. Yeah, I think its stability is one of the major attractions. For example, we might contrast it with another marker which is still being investigated and is of interest, which is the urinary P75 extracellular domain marker. Now, if you look at the trajectories for that marker in individual patients, they tend to rise at different rates over time. Now, that does have some value because it's clearly something that if overall in a group you could again change the slope of the rise, that might have some biological relevance. But it's less attractive than being able to say for an individual, this is what their level of neurofilament tends to stay at. If you're in a situation where, well, this person's may go up a bit more, we don't really know, and this person's may go up a bit more slowly, it adds an extra noise, which fortunately we don't seem to have with neurofilament light chain.
To add to that, Rick, I think people initially thought maybe the plateauing of neurofilament would be a disadvantage. It's not a marker of disease progression. But the fact that it reaches a plateau means when we're measuring it in people with established disease, whenever we do, the level's the same, and it tells us about the rate with which disease is progressing. But it's also why when we can use it as a response marker and show that if we give a treatment and it comes down, we can say, well, it doesn't come down on its own. So that must be because of the effect of the drug. Likewise, if it were to go up, we would say, well, that's a bad effect of the drug, right? That's the flip side we haven't spoken about. So I think that stability is super helpful.
So you've looked at this and correlated with those rare people that have plateaus and small improvements in the natural history of their disease, and their neurofilament just stays high in spite of those other things? Or you haven't really looked at those patients?
I don't think there's been that kind of close look at an individual person level for people who have a plateau or people who have an improvement. I don't think that sort of granularity of data is available yet. I don't know, Martin, do you have data?
No, personally, I've found that those sort of unusual cases have generally been among the people who have an overall slower trajectory. So, of course, we would expect to have lower levels of neurofilament, so we may not capture the drop in quite such a dramatic way. Yeah, so Michael was saying about rising levels. I think I am prepared to be even more cautious than I naturally am here. We do have concerns about levels of neurofilament rising for the same biological reason that we're saying it's exciting when they fall. I think there's a little bit of an issue, particularly if we're targeting non-neuronal cells, that it's not impossible that we would see an initial rise in the neurofilament. And I think we just have to be open to that. So the way I'm looking at this, if we do reach a situation, as I hope we do, where we can start to use neurofilament in small studies as a go, no go, is not whether we decide this drug gets rejected completely, but it's really about drug prioritization. We've got a limited amount of patients, resources, time to do phase 3 studies. Which drug do we want to start with? Let's start with the drug that seems to drop the neurofilament. That's not an unreasonable way to use our money, our limited resources and time. And for patients, the one that we feel has shown a human signal. That does not mean that a drug that hasn't shown that signal is rejected. It's simply further down in the priority list. And one that's shown a rise, I think we have to be extremely cautious, and certainly within interim analyses in drug trials, I would be expecting the Data Safety Monitoring Board to be at least considering looking at neurofilament levels. But again, it doesn't mean we're not mature enough yet to say that that means the drug is definitely doing harm. So for me, it's a real window on a drug prioritization platform. That's what I see that the next step is. It should not be regarded as an arbiter of taking a drug forward or not.
Okay, so what would be the potential downside? Can we delve into that a little bit more? It sounds like you're not convinced that it should be a go, no go. But if a drug isn't moving neurofilament in a phase 2, should it move on to a phase 3 then?
Well, The situation I feel that we're in at the moment is there are 10, 20, 30 drugs at the phase 2 stage jostling around. Some are coming from preclinical signals. Some have more noise on the internet than others. But really, they're all jostling for position. And in an ideal world, we'd like to run all of them in a phase 3 study, which would likely need a placebo component. And that is difficult for patients, but there are many well-rehearsed reasons why that's important. We'd like to run a phase 3 study in all of them. But, to find 300 patients to power that on ALS-FRS across 20 to 30 studies, even if we had limitless money, finding the patient participants, the sort of time and personnel to do that, it would just be impossible. So we're faced with a need right now to say, what's the one we want to start with? And so I don't quite see that the same as go, no go. For me, this is about which one, rises above the surface first. So my proposal is that we could start to prioritize as a community those drugs where we do have a strong neurofilament signal, but in a way that's not rejecting drugs that don't. It's just simply saying, let's go with this one because that's the one where we have a human signal.
Yeah, Nadia, I wanted to add something to that, if I may. I think that there are some drugs with a mechanism of action, for example, improving skeletal muscle contractility that might improve muscle strength, that we might have no biological expectation that they're going to change neurofilament. So I think there does need to be a little bit of a nuance based on how we think the drug is purported to work. But having said that, so if neurofilament, and we didn't talk about this earlier on, but if neurofilament fundamentally, a rise in the neurofilament reflects axonal loss, axonal injury, axonal degeneration, right? Motor nerve loss. At some level, it's hard to imagine that there's a drug that's going to have a profound effect on function over an extended period without impacting axonal loss. Now, we could stand on our heads and think about ways in which it might do that, but neurofilament might not go down. But I think as a general statement, I think there's a lot of face validity to that. And so, if we're looking for drugs that might have 2 or 5 or 10% effect on function, maybe they're not going to affect neurofilament all that much. But if we're looking for drugs that are going to have a 50% effect or a 60% effect, I think the big effects, it's hard for me to imagine that that's not going to impact neurofilament. And so again, to Martin's point, if we want to prioritize the drugs that are potentially going to transform the face of this disease, not have just these sort of small incremental benefits that are hard to discern and hard to know if they're even real.
I think that's right, Michael. It's certainly something that I've had a lot of people say, that they're worried that neurofilament is a very high bar. And they're worried about what would be called technically a type 2 error, that we would throw out a potentially useful drug simply because it didn't make that high bar. But, I think as a parallel method here, I make no apologies for wanting to aim high. We have a lot of drugs jostling around with small effects, and it may well be that they have additive effects, and we will definitely need to consider drug cocktails, and that, frankly, is what's happening already. But, if we have a way of screening a large number of compounds that are queuing up and looking for a blockbuster, and then, when we find that, we move heaven and earth to put that into a phase 3 study, that's great. That's not a mutually exclusive proposal or rejecting the idea of drugs of smaller benefit. It's aiming high for an effect that is impossible to ignore. And, we should remember, as well as the natural history of neurofilament being that the levels stay the same, neurofilament is not a normal marker. None of us would want to have a raised neurofilament level. It's not something that should be raised. It's not something that sort of naturally creeps up with age, independent of other brain pathology that occurs with age. So, as Michael says, the face validity of simply you've given something which has lowered a marker, which is a surrogate really for brain pathology. The face validity of that is very high.
Thank you so much for that. So I think my other question, and some of the potential criticisms I've heard of using neurofilament in this type of context, is, do we know enough about neurofilament? And you've made a really good argument so far that we do know potentially enough to use neurofilament in this context of a phase 2 to kind of make decisions about whether a drug should move forward. But I guess from a patient perspective, does it matter? Is it going to change how much neurofilament is being given off based on the site of my disease onset? And we already talked about rate of progression, but do we know enough about neurofilament where a percentage drop in a phase 2 could reliably be seen? I guess that what I'm trying to get at is, there is a lot of variability from person to person. And are we at the point where we can overcome that and see in the data that there's a clear effect?
No, and I think one of the paradoxes is that if we had an amazing drug in terms of massive clinical benefit, one of the problems is we don't have a single drug that I know of that you give to an ALS patient and they come back the next time you see them and they say, I feel better. We're used to saying to people, this is an exercise in believing the data that your disease is getting worse more slowly. But you can't expect to be able to measure that. You can't expect to be able to feel that. And sometimes, I have to say you can't expect to feel better. One of the interesting things about ALS is people generally don't feel ill, actually. And so it's one of the things that they weigh really in taking a medication where they can't measure the effect is that they don't want to feel worse on it. So we're in a situation where we're working slightly blindly, really. And I think the opportunity of a marker that really is able to give people much more confidence that what they're taking, and actually possibly in a situation where it has made them feel slightly unwell, but where the objective marker is so great, then that would be enormous. But the paradox we face, to go back to what I said at the start, is that if we wait for the drug to come along, an amazing drug, and then we retrospectively say, oh, look, it lowers neurofilament, then we no longer need neurofilament because we have this amazing drug. And sometimes people will say, well, what happens with riluzole? And, there's two answers to that, really. If neurofilament, it's never been shown, but if it was to show a significant major drop with riluzole therapy, personally, for everything I know about neurofilament, it would cast serious doubts for me about the validity of neurofilament. It would be a massive spoiler for me. Whereas for other people, they say, well, if it doesn't do anything with riluzole, which is a drug which undoubtedly does have a small survival effect, then that means neurofilament's no good. Whereas what I think it's telling us is that the problem with neurofilament, among many problems, is going to be that it will not detect small effects. And that's okay. It doesn't mean that those drugs aren't important, but we're using neurofilament to detect a big change. And right now, we're not short of candidates to try. And so as long as we understand that it's not a panacea for every challenge in ALS, then I think it's fit for purpose.
Yeah, what I would say, Nad, is we shouldn't let perfection be the enemy of the good. The ALS FRSR is by no means perfect. If we had waited for a perfect outcome to do any drug trials in ALS, we would have no approved therapies. And I think NFL has reached the point of being sufficiently well developed and well understood that it should become a tool to aid us in drug development. And I think if we don't do that, it's an enormous lost opportunity.
Martin, can I just follow up on something that you said? So, I'm absolutely convinced now by this paper and some of the recent things I've seen, what I've heard from you two today, that this should be part of every ALS clinical trial now for the near future anyway. But I'm still struggling with this idea of, should I be using it in clinic? Like, I've already made up my mind that it's not going to help me when the patient asks about prognosis. But now I'm starting to wonder, I get questions all the time. Hey, this Edaravone, it's costing me a lot of money. This Relyvrio, I'm paying $2,000 a month out of pocket. Is there any evidence that it's helping? And, I try to graph out slopes of clinical measures like the ALS FRSR, the FVC, the hand grip dynamometry. But, we know these slopes are noisy. We know that there can be plateaus and small reversals just spontaneously. So I know that's not a perfect way to do it. But I just wonder, would that neurofilament level going down give me more confidence, give the patient more confidence in continuing the therapy? Plus, I have 90% of my patients self-experimenting with things that they're buying and trying off the internet. And there's always the question, should I keep taking this L-serine or acetyl L-carnitine or TUDCA or whatever it is? And I just wonder if, starting to routinely measure this at every clinic visit would help with some of those questions, or are we not quite there yet?
Well, I think you're absolutely right, Rick. And I thought when I first started seeing this data coming through, I immediately envisaged that situation. I suppose I thought, let's not forget there's a potential here to advise patients when they might be doing themselves harm. The reason that I think in an ideal world it would be great to be measuring this regularly in all patients is we'll gather data very quickly. Then we'll see how it varies. People are smart enough to understand that we can't make decisions yet, and they shouldn't just stop a treatment just because of their individual results. So we would start to get much more information on that. And in your pocket right now, I would imagine, is a smartphone, and it'll tell you all about your step length and all sorts of things, which we can laugh about and say, really, that doesn't really matter. But you're interested, and it's telling you about you, and you are interested in things that monitor your function. And I think neurofilament will be difficult for people, as you say, who are sometimes at their own cost paying a lot for drugs that they're not feeling better on. They're going on data from trials, and we're as rigorous as we can be with our peer review process and constant appraisal of drug effects. So I think it's inevitable, and I think we should help patients navigate that. I don't want anyone coming off medications on the basis of a speculative measurement as things stand. But I think that we're going to need to gather more data. And if that's a way to do it through a cheap, simple blood test, then I think there's a lot to commend that.
Yeah, I do too.
Well, the other thing though, Nadia was asking about downsides. And so one of the things I never thought I would see in my career is this gap between drug approvals and access. And it's being created by payers. I mean, payers are making us jump through outrageous numbers of hoops to get these drugs for patients. And I think it's only a matter of time now before they latch onto this and say, all right, we'll pay for it up front if you do your 5 appeals. But we also are going to require a substantial reduction in neurofilament after 6 months to continue to pay for it. I think that's going to come.
Yeah. And, that then, of course, it's an immediate worry and anxiety. And, this is, I think, the conversations that we need to be having as, the people with patients' interests on our minds the whole time. We need to be having discussions to stay ahead of this, own the space to stop this kind of regulation occurring without our input. So you're absolutely right, Rick. There are a huge number of dangers here, and we need to make sure it doesn't become a sort of simplistic metric. But I think realistically, the idea of keeping this out of people's hands is not the direction of travel in any other walk of life.
Great.
Yeah.
I thought it was great. I mean, the only other thing I was going to ask about is, so, Martin, Michael, I mean, I am really like 50-50 deciding if I want to start doing this on every patient now because of the kinds of questions I get about sticking with treatments, especially these people who are self-experimenting, which is most of my patients. But the danger is for those who are in clinical trials, am I going to unblind the trial if I'm giving this information out?
That's a concern.
Yeah.
But I did want to add that outside of the clinical trial context, Rick, I am in favor of us learning to use neurofilament in the clinic. I do think, what has been shown is that neurofilament levels, NFL levels, do add prognostic value to what we can tell based on, a delta FRS or a site of onset or an age of onset or a C9 mutation. It is an additional piece of information that's not simply sort of mirroring what we know clinically. Now, we don't yet have the algorithms and the tools to be able to plug that in and sort of use it at an individual patient level. Hopefully that will come. But I think it does, at least sort of biologically, when we study it, it has that additional value. And likewise, for your patients who are experimenting, they may want to try 20 different things. And wouldn't it be nice to be able to say, your neurofilament went up. This may not be a good idea. Or your neurofilament went down. Maybe that's worth sticking with. Or it didn't budge. Maybe think about something different. It's a tool. It's not the be-all and the end-all. I think it's another tool in our armamentarium to help our patients.
Yeah. I always think that the analogy or the comparison really with the cancer field has been so helpful sometimes in getting a bit of clarity. First off, the idea that you would come to a cancer clinic and your oncologist would say, there's not really drugs that we can offer. That is something that is changing massively in the ALS field. And then they would have markers that might be a little bit tangential to do with certain counts or sizes of things, but they wouldn't necessarily be saying to the patient, you will be feeling better in yourself with this. They'll be using those metrics. And, conversely, in the cancer field, many patients will accept feeling worse because there's this sort of sense, well, then it might be doing me some good. And that will come in the ALS field. And I want to be really sure that if I'm making someone feel worse for a condition where strikingly many patients do feel well in themselves, despite their disability, if I'm going to be making them feel worse, I want any handle I can get that I'm not actually making them worse. And so, I don't think this is so conceptually different from people self-measuring their ALS-FRS and such like.
Well, I learned a ton today, and I might actually change my practice as a result of it. So thank you very much, everyone, for your time.
Thank you.
Thank you.
Thanks a lot. Thank you.
Hi, I'm Ted Burns. I'm at the University of Virginia, and I'm speaking again with Richard Bedlack. Richard is an ALS specialist at Duke, and he, among other things, heads up the ALS Untangled group. This podcast is again supported by the CREATE Consortium. The major focus of CREATE is to advance the science that aids development of therapies for patients with ALS and related disorders. Let me quickly remind listeners to listen to our introductory interview that provides background on the ALS Untangled group. Alrighty, today we're going to discuss one of the ALS Untangled publications, this one number 38, about the amino acid L-serine, and serine's S-E-R-I-N-E. So Rick, let's start by having you talk about BMAA and how that story may be relevant to the rationale for the use of L-serine in people with ALS.
Yeah, this is an amazing story, Ted. So once upon a time on the island of Guam, ALS was 50 times more common than any place else in the world, and researchers flocked there to try to understand why. They found that when the native people of Guam, called Chamorros, died from ALS and had autopsies, their brains were full of a neurotoxin called beta-methylamino-L-alanine, abbreviated BMAA. A search then ensued to figure out where in the world this might be coming from. And the first place they found it were in these seeds that grew on the island called cycads. The native people of Guam made flour out of these seeds. It turns out, though, that it was present at such a low concentration that it probably couldn't have been enough to cause human disease. And so folks kept looking, and next they found it in flying foxes, which were another unusual dietary preference of these folks. The foxes fed on those cycads and wound up with a lot of BMAA in their bodies. And so if somebody ate some of these flying foxes, they could get a whopping dose of that toxin. Another nice thing about that observation was that a few decades ago, these flying foxes became extinct, and it wasn't long after that that the risk of ALS started to drop on Guam. Interestingly, though, it never got down to normal. It's still about 5 times more common there than it should be. And so researchers continued to look for another source of BMAA, and they eventually found it. They found it in blue-green algae. And now, for the first time, folks outside of Guam started to worry about this toxin because, outside of Guam, there's not a lot of cycad or flying fox consumption, but there's blue-green algae everywhere. And so people started to look in their autopsy banks for BMAA in the brains of people from North America, and it turns out that some definitely have it. And they also started to do epidemiology studies looking at the frequency of ALS around bodies of water containing blue-green algae. And some studies do find an increase. Around this lake called Lake Muskoma in New Hampshire, for example, the risk of ALS is about 25 times higher than any place else in New England.
Wow, that's fascinating. So now the blue-green algae is a source of BMAA. Is that correct?
Correct. And it's kind of a scary source because from what I've read, you can consume blue-green algae. Some people actually eat it, but you can also swim in it and absorb it through your skin if you're swimming in the water with it. And in fact, you might even be able to inhale some of the spores of dried blue-green algae. And that's one theory about why some military veterans that served maybe in the Persian Gulf came back more likely to get ALS than other military veterans because they were marching around in sand that had dried blue-green algae and maybe they were inhaling BMAA. It's just a theory, but it's really interesting.
So it's not just found in certain lakes in New Hampshire. It may be more widespread than that.
It's pretty widespread. It's concentrated in some areas, but it is pretty widespread around the world.
Okay, now let's work L-serine into this story. So is there any non-human animal model evidence for BMAA toxicity and for therapy with L-serine?
Yeah, so there's monkey models. Monkeys that are chronically fed BMAA wind up developing behavior changes and also changes in their brain, similar to what was seen in the people of Guam. And it turns out that when you add the amino acid L-serine into the diet at the same time, you can block these changes from happening. Now, Ted, this is a prevention model. What's missing is I haven't seen anyone attempt to actually take an animal that had the neurologic disease and try to reverse it. And of course, that's what we'd be trying to do in people who already have ALS.
Right. So would you talk about the results of a small trial of patients with ALS? And this was a small safety trial, but can you talk about that?
Yeah, this was led by our colleague Wally Bradley and members of the Western ALS Consortium, WALS. So their team enrolled 20 people with ALS and randomized them to get different doses of L-serine, ranging from 0.5 to 15 grams twice daily over 6 months. And again, when you do these, initial very small studies like this, mainly what you're looking at is safety and tolerability. And so the good news is it seemed to be safe and tolerable. No deaths or hospitalizations thought to be related to the treatment. It wasn't a study that was powered to look for benefits, but even though it was small, there was an encouraging trend. Folks on the highest doses of L-serine had the slowest ALS FRSR progression.
Okay, and you said 0.5 grams to 15 grams twice daily was what was studied in this trial.
Yeah, it's important to point out one of the problems with this trial is that we still don't have a way to reliably measure BMAA levels in a living person. And so, most of us think that ALS is not one disease. I personally believe there may be a subset of people with ALS who have it because of BMAA, but I don't think everybody does. And so obviously, if you did a trial of 20 patients and only one of them actually had their ALS because of BMAA, you certainly wouldn't be able to see an effect. So I think this is one of the problems with this field right now, with this whole idea of trying to treat ALS with L-serine, is we've got to develop an assay that allows us to measure BMAA levels in someone who's alive. We can't just use autopsy measurements.
Right. Okay. So are you recommending a specific dose? Or if a patient comes to you and says, I want to start L-serine, what dose are you having patients start at?
So all we have to go on as far as human ALS studies is the one that we just described. And so the dose range in that study was 0.5 to 15 grams twice daily for 6 months. And the good news was it seemed like all the doses were pretty safe and well tolerated. So what I typically tell people who say, this is the one for me, I like the theory and I like the fact that there's some safety data. I say, well, why don't you start at 0.5 grams twice a day and then each month bump it up a little bit, with the target dose being 15 grams twice a day, and we'll see what happens.
Okay, and we'll talk about cost in a minute, but it gets more expensive as you increase the dose, and we'll talk about that soon. But before we do, you mentioned safety already, at least in this small trial. You may have something else to say about safety. I'm curious, but talk about tolerability also, please.
So 3 out of 20 people that were in the small trial we talked about had non-serious adverse events. They had GI side effects, which were thought probably related to the treatment. And those included bloating, nausea, decrease in appetite. And I've certainly heard some of my patients say that too, especially as they get up to higher dosages. So that's something, if a person is thinking about trying this, that's one of the things where I say, okay, if you push the dose and you start noticing that you feel any of those kind of things, you've probably gone up too high. So drop it down a notch.
And certainly GI side effects could be problematic when we worry so much about nutrition and weight loss in our patients. We're taping this in late March 2018. You mentioned in your publication that a larger trial is going to be conducted. Is there any update on this?
So the last I saw members of the Walls group was in December at the International Symposium on ALS in Boston, and they told me they were still kind of looking for funding for it. No start date has yet been announced.
Okay. All right. Can you talk about cost?
Yeah, and it's going to depend upon which supplier you use and which dose. So we've talked about this supply issue before. And, what I typically say is, without a comparison of all these different suppliers, I just go with what the trial used. So in this case, they used somebody called Jomar Labs. And if you start from Jomar Labs at 0.5 grams twice a day, L-serine's about $10 a month.
Okay. Do you remember how to spell Jomar?
Jomar.
Okay. Perfect. All right, Rick, any comments or caveats about buying L-serine online?
Just what we've talked about before, and that is that, with all these supplements, there's probably going to be variability in purity and co-ingredients across all these different suppliers. And hardly ever do we have careful testing comparing all the suppliers. And so my approach is, if you've got a trial that showed tolerability, safety, hopefully some efficacy, use that exact product at the dosages that were in that trial. That's the way I do it.
Okay. And can you just summarize your conclusions for L-serine?
Yeah, so in terms of our table of evidence, we gave it a B for mechanism, a C for preclinical data, a D for cases, D for trials, and C for risk. In terms of final comments, I really think the whole key to this, to making L-serine useful, is to figure out which people with ALS have elevated BMAA in their brains while they're still alive. And we've got a ton of work going on in this field, biomarker work. And I think very soon someone's going to come up with a way to do this, and that's going to revolutionize the success rate for a trial of L-serine.
That's great. That sounds promising. You said B, C, D, D, and I think C. The D's sound bad. Can you remind us what D's are?
D is
Do
for
they
cases.
just mean we don't have the evidence? Is that all that means?
We gave it a D for cases and a D for trials. So in terms of the cases category, these are what we call anecdotes. These are, somebody out there tried it and this is what they said happened. So we give it a D if we can't actually get medical records to verify that the people who said they had ALS and said they got better from something really had ALS and really got better. We give it a C if we can get their records and prove that they really had ALS and that there is some positive change on some objective measurement. So we couldn't get the records on the folks that were out there. And then as far as trials go, we thought that there were some flaws in this trial. It's very small. There's no placebo group. And so it doesn't mean the trial is no good. This is very often how the first trial is done, but it certainly doesn't get a grade like a large randomized double-blind placebo-controlled trial would get.
Okay, so when my kid brings home a grade of a D, I'm not happy, but these Ds simply mean we don't really have the evidence right now to make a recommendation. Sounds like.
Yeah, it means there's some problems with the data that we have for that particular category, some significant problems which give us pause, but doesn't mean it doesn't work. We try to be very critical with the things that we look at. So, in terms of using a school analogy, we would be the tough teacher. You really got to knock our socks off to move up a grade.
No grade inflation. All right, Rick, any final comments?
Yeah, I mean, just what we said. I think the key to making this useful is to figure out which people have the elevated BMAA in their brains while they're alive. And I think that's going to happen in the near future.
That's great. Okay, thank you very much. Again, I've been speaking with Rick Bedlack from Duke University. Thanks, Rick.
Hello, everyone. I'm Dr. Richard Bedlack, professor of neurology and director of the Duke ALS program. I'm also in charge of education and outreach for the CREATE Consortium, which is part of the NIH-sponsored Rare Disease Clinical Research Network. CREATE is a clinical research consortium focused on therapy development for ALS and related disorders. CREATE aims to help overcome some of the underlying barriers to therapy development, with the goal of improving the success of future clinical trials. Today's podcast is part of a series we developed to help non-scientists understand some of the work that our CREATE team is doing. I'm very pleased to be joined today by Dr. Nadia Sethi. Nadia is Director of Community Outreach and Engagement for the ALS Therapy Development Institute, and she's also the co-chair of the NEALS Patient Education and Advocacy Committee. She lost her husband to ALS in 2020. In this podcast, Nadia and I will interview the authors of the recent publication, the Amyotrophic Lateral Sclerosis Health Index, ALS-HI, Development and Evaluation of a Novel Outcome Measure. We're joined by Dr. Chad Heatwall, who's professor of neurology and director of the Center for Health and Technology at the University of Rochester Medical Center, and also by Dr. Michael Benatar, who's been on previous episodes of this podcast. To refresh your memory, Dr. Benatar is professor of neurology, chief of the neuromuscular division, and executive director of the ALS Center at the University of Miami Miller School of Medicine. He's also the director of the CREATE Consortium. Nadia, I'll turn it over to you.
Thank you so much, Dr. Bedlack. Hello, Dr. Heatwall and Dr. Benatar. Thanks for joining us today. So PROs, or patient-reported outcomes, have become a buzzword in the ALS community recently, but I think it's kind of hard to understand what PROs are, how they're designed, how they record the patient experience. So first of all, could you explain what patient-reported outcomes are and why there is such a focus on them in ALS drug development right now? Why do PROs matter?
So I guess I'll start, Nadia, and then I'll pass it over to Dr. Heatwall, who's really the guru here. But from my perspective as an ALS neurologist and other disease areas where I work, a patient-reported outcome really aims to capture the patient perspective, how a patient feels, how they function, things that matter to patients. When we're thinking about developing drugs, the FDA is very interested in outcome measures, things that tell us whether a drug or a treatment is working or not, based on things that impact how patients feel and function. And a patient-reported outcome is really the best way to do that. But Chad, your thoughts?
Yes. First off, hi, Richard, Nadia, and Michael. It's really a pleasure to be here with you this morning. And thank you for inviting Michael and I to talk. So the patient's voice is really the most important thing. And we know this is true in the clinic, and we know this is true in research. And a properly designed patient-reported outcome measure is a tool, usually in the form of a questionnaire, where a patient provides direct input into the health or the severity or occurrence of one of their symptoms. And as Dr. Benatar mentioned, they are extremely important in clinical research because they provide an opportunity for a patient to provide direct input in how they're responding to a treatment or placebo. And historically, PROs have been developed in a lot of different ways. Traditionally, they were developed in dark rooms where several physicians gather and decide what is important to patients and what should be placed in an outcome measure. But more recently, the FDA has set forth clear guidelines of how these PROs should be developed and the different validation steps that are needed to build one of these instruments for use in a clinical trial. And it's now really critically important when building these instruments and validating to obtain extensive input from patients into what questions and items should be included in the questionnaire.
Chad, could I chime in for a second? So just
Sure.
at the start to sort of set the table about the importance of these. I mean, clearly, the concept, it makes a lot of sense, but is there any lesson that we can learn from another field where one of these outcome measures has accelerated drug development, or maybe just as importantly, has convinced payers to cover a new FDA-approved medicine? That's something that we're struggling with in ALS right now.
Yeah. So we've been at this for about over 15 years now. And my group's developed over 160 of these disease-specific patient-reported outcome measures. And we've learned a lot over the years of really what works in these outcome measures and what does not. And what we really have strived to do is develop an outcome measure that is highly sensitive and has a capability to detect a small but meaningful clinical change in a patient's state during a clinical trial. And so if you have a treatment that works, but you don't have an outcome measure that can identify that, your treatment trial will fail. And so this is really a travesty. And so we really have gone out of our way to make these outcome measures as sensitive and as relevant to patients, but also as sensitive to detect these small but clinically meaningful changes. And so one example of a success with this is a recent study that's not in ALS, but actually in Huntington's disease, which is a very severe neurologic condition. And the center that I work at conducted a study called the CONNECT study, where working with a pharmaceutical company, we evaluated valbenazine versus placebo in this condition. And we utilized one of our disease-specific instruments for Huntington's, the HD high, that was developed in the same way that ALS high was. And that outcome measure was able to detect a benefit of that drug, whereas generic and some other outcome measures failed. And so this data was then used and presented to the FDA, and that particular drug received an FDA approval and label as a treatment for Huntington's disease. So this gives an example of how important outcome measures are and how it's really important to select the right outcome measure and to really build it so that it's really as valid and relevant as possible.
Thank you.
And Dr. Heatwald, to continue on that thread, could people who are participating in a trial just simply submit testimonials? Why do we need a tool like this?
Yes. So, again, the patient's voice is so important. The patient's perspective is important. If you have a drug and physicians say it works, but there's no effect that's noted by patients, does it really work and does it really provide benefit? And so we want to make sure that treatments really improve the lives of patients. What we do and what a good PRO can do is it takes what is not quantifiable and makes it quantifiable. The PRO that we have gathers the patient's input, and it's a mechanism to take what they're saying and actually put a number to how their clinical state is. And why verbiage by patient is certainly important, it's really hard to analyze and to quantify that in a clinical trial outside of a PRO.
I think that makes a lot of sense. And you had mentioned a guidance document from the FDA. So could you explain a little bit what an FDA guidance document is and how you use that in creating this measure?
Yeah, so it actually goes back to 2009, maybe even a little bit before that, is that the FDA was using patient-reported outcome measures to support drug labeling claims in pharmaceutical studies. And again, the quality was variable in those outcome measures at the time. And so the FDA decided that, hey, if we're going to approve drugs in part based on patient-reported outcome measures, we should have a bar of how these outcome measures are made in a set standard. And so they had a draft guidance, and then they came out with official guidance in 2009. And they said, if you're going to use a PRO, it really has to satisfy certain criteria. And they set very, very high standards for these PROs. So they said it has to be meaningful, it has to be reliable, it has to be responsive, it has to have good psychometric properties, it has to have low patient burden, it has to have no redundancy, and it has to be valid. And you have to show a study showing all the validity. And there's 7 types of validity. So predictive, content, construct, criterion, face, known groups, and convergent. And they said, you have to really show all of these things. And at the time, I was foolish enough to say, well, let's go ahead and see if we can do this. And I went back to school, got a master's degree to really learn this intense psychometric techniques to really make these outcome measures. But without overstating it, I think it's very, very difficult to make these outcome measures in the correct way.
And that leads into my next question here. So how did you go about figuring out what priorities from patients to include in these outcome measures? How did you find the people, and how did you start this process with people with ALS to create this measure?
Yeah, so thanks, Nadia. So that is the most important part. And that what you're referring to is the content validity of an outcome measure. And so it is critically important that large amounts in frequent amounts and massive amounts of patient input is baked into these outcome measures so that we know that we're asking the right questions and that we're measuring the right concepts and the right symptoms. And so to make this particular instrument, we partnered with several organizations. The Create Network was certainly one of them. We partnered with the CDC and utilized their registry. And then we had local partnerships with national leaders like Dr. Bedlack, Dr. Benatar, and we recruited out of the University of Rochester. So we had a lot of different sources and referrals with hundreds of ALS patients.
Thank you for sharing that. And so can you talk a little bit more about what was involved? So first you brought together a group of 15 people with ALS and you talked to them about their symptoms. Can you go into that a little bit?
Yeah, so we started out with very qualitative work, kind of what you mentioned before, and we recruited a diverse group of patients with ALS of different severities, and we asked them, we said, hey, what symptoms and issues affect your life the most or impact your life the most? And we conducted these interviews. They were about an hour each, done by very skilled clinical coordinators who are trained in these type of techniques. And we did open-ended, close-ended, and recorded their interviews, and then went through an analysis process where we boiled down each individual quote and then categorized these quotes to really identify potential issues of importance. Now, just because a patient says that something is important in one interview doesn't mean that it's necessarily true. They could have another condition, or maybe they're an outlier in some way. And so then we do a follow-up validity study where we do a large cross-sectional study involving tens of thousands of data points, in this case, over 400 patients, where we said, hey, do you have this issue that we identified through these interviews? And if so, what's the relative importance of it?
Sorry, Nadia, could I just chime in with one more question about that particular issue?
Sure.
So this is something that I've in recent years been thinking a lot about, and that is, I don't know if there's a better way to do it. I mean, I think this was completely, valid from a science standpoint, but I wonder sometimes if the people who participate in studies like this really are representative of, the 30,000 people living with ALS in the United States. I feel like, these are people that could come to clinic. These are people that understood the importance of participating in this type of research. I just wonder, is that really what the average person with ALS is like? And, how can we reach people that maybe don't come to clinics? We think that there's a large percentage of people that maybe aren't coming to an ALS clinic. I don't know the answer, but I just wondered if you thought about that.
Yeah, this is something I really think about a lot. And we actually have a new division where I work at Chet that we started about 16 months ago called Chet Health. And it really focuses on this. And this has historically been a problem in clinical research, is that the patients that participate in clinical research are not always representative. And it's difficult to really reach underrepresented populations. And so this program that we've started up really is initiating different mechanisms to try to reach the unreachable, because their input is really important as well. And so we've done a couple different programs, advocacy programs, super advocates in the community. And like you mentioned, we utilize patients that were in the registry, and not everybody's joining the registry. And we utilize patients that are in the Create Network, and a lot of patients are, but not everybody's in the Create Network. And so if a patient is really sick or maybe doesn't trust the system, then it's hard to reach them. And so then we go to the clinics, but maybe not everybody goes to the clinic. And so I think we need to do better in the future and get more diverse populations and really bolster our existing data that we have.
Yeah, and Chad and Rick, if I could just sort of add to that, I mean, I think there's sort of layers or tiers of this, right? There's the group that we're able to reach when we're developing this instrument. And then there's a broader group, hopefully, that we reach as we're trying to study how it behaves, how it performs, what's a minimal clinically important difference. And it's always hard to reach everybody, but we do have several initiatives, some of which we've spoken about in this podcast, for example, through our EHR-based study, where we're trying to reach at least everybody who comes to a clinic, knowing that there's still people who don't come to clinics. So I think we have to sort of, see this as trying to get to the broader population, and we can do that more or less effectively in different sort of tiers or stages of sort of development and implementation.
Makes sense. Thank you.
Yeah, so you've generated this tool. And so as we put it into clinical use and as we see it in clinical trials, is this something that's going to potentially evolve based on the population that we're reaching?
So I think, let me say a few words and Chad can comment on the extent to which there have been revisions of some of the other health indices that he's developed. But there's the development of the instrument that meets all of these FDA guidance in terms of how it's constructed and developed. But one of the things that we're doing now that we may not get to talk too much about today is try to understand what magnitude change on this scale really sort of matters, and doing this using a variety of methods to understand patient perspective again. And we'll do that in a broader population. And so some of the interpretation of a change in the score and what that means will come from implementation in a broader population. But Chad, I'm curious what your experience has been with the need to modify these instruments over time based on some of these learnings.
Yeah, so just to clarify, the instrument is completely finished now. So we've done all the necessary validation steps to finalize the instrument. And this takes a long process, and there's multiple iterations of the instrument as we go. And we make small modifications based on patient input and how it performs in longitudinal fashion. So the instrument now is completely validated and being used in pharmaceutical studies and several longitudinal studies. But I think you're absolutely right. As we go forward, we certainly like to monitor the responsiveness of the instrument, the performance of the instrument as it's being used in clinical trials, and reserve the right to potentially modify it. This we haven't done too much in the past. We have 160 of these, and we've always kept that option. Do we make another version? In some instances, when we have utilized, we have 20 different translations for other countries that we translate and validate. So in some instances, when we modify an instrument or make it useful for another country, we will modify a question just to make it fit the cultural criteria of that country. For instance, we're doing an instrument for SMA in Australia. And one of the questions was, how much difficulty do you have lifting a gallon of milk? And the patient said, well, what's a gallon? Because they don't use a gallon. So, sometimes we have to make cultural modifications. And there is, in theory, if we find that one question is not performing like it should, through its use in therapeutic trials, we do reserve the right to change it. But we haven't had to because we've designed these so well.
But Chad, one thing this raises, which also comes back to something we were discussing, is right now we are not able to use this instrument, for example, in our Spanish-speaking population. But it's something that we probably need to get to. And I wonder whether you can share some thoughts, based on other instruments and getting these translated for broader use within the US.
Yeah, so we've done this a couple different ways. We do this all in-house now. And so one way that we do it is we partner with another academic group in a different country. And again, this is not a simple process. You can't have your aunt translate this into Spanish. This has to deal with 2 translation forward, reconciliation, 2 translation backwards, reconciliation, and then validation studies or qualitative validation. And so we either work with an academic group, or in some instances, when a study has an urgent need for this, we have a preferred vendor that we work with that does this full time, where they make translations for our instruments for our use in other countries. And so if there's a need, we aren't doing this for every country, obviously, and every instrument we make. We do it as a need base. So if a company wants to do a study or Dr. Benatar wants to do a study, then we contract and build these translations.
Thank you so much for that detailed explanation. Okay, and so you had mentioned that there were multiple versions of this as you were creating the tool and as you moved forward. So could you talk about the 3 different versions a little bit and some of the feedback that you sought from the community as you carried this forward into the final version?
Yeah, so, right now there's just one final version, and maybe it's not correct to say that the other ones were other versions. It's just part of the process. We're not releasing those until we know that it's really good and really perfected. But we start out with questions that are really important to patients that we've identified through a cross-sectional study and through our qualitative interviews. And we use psychometric methods, factor analysis to really group the questions into small subscales. And so these subscales measure very granular aspects of ALS health that have been identified by patients as being very, very important. And so the final ALS high is actually a composite of 15 small subscales that measure very specific areas. Collectively, they measure fatigue, mobility, lower extremity function, upper extremity function, social performance, hand and finger function, activity, emotional health, pain, communication, sleep and daytime sleepiness, swallowing function, breathing function, GI health, cognitive health. And so every time a patient completes the instrument, they get a score from 0 to 100 for each one of those concepts. And then the total score is actually a weighted score of all of those. We started out with these subscales. We used psychometric and face validity to generate these subscales. Then we made the first instrument, and then we beta tested it with patients. And we said, hey, what do you think of this instrument? Is it too long? Can you use it? Is it comprehensive? Are the questions clear? We ask a lot of different questions. Does it really represent how you feel and function? And we took feedback from patients during the beta testing to make small modifications. And then we tested the reliability of the instrument. Technically speaking, you don't want questions that are rapidly changing over a very short period of time, because that can really lessen the ability for it to be used in a clinical trial to really detect a useful therapy. So we got rid of any really unreliable question. And then we looked at how it was able to differentiate between really sick patients and not sick patients. And ideally, you want an outcome measure that can do that, because if your outcome measure can't tell you that this patient is more sick than this one, then it's really not going to be good in a clinical trial. And then after looking at all that analysis, we went back and did another assessment of the internal construct validity of each subscale and then finalized the instrument.
Great. And then you were saying that you ended up with the final version that has 105 questions, I believe, in the full form, and then 15 questions in the short form. So when do you decide which one is the appropriate one to use? And is the long one too burdensome, and the short one, will that miss things?
I'm so glad you're asking this, because this is probably the most misunderstood aspect of all of our outcome measures. And so people hear that number and they always panic with that number. But in actuality, in all of our instruments, there is only one question. And the question is, how much does this impact your life now? And then it's the same Likert. And that's the same question for all of these things. So really, there's just one question. And then those things, it's a list of 105 items, but many of those things are one-word things. And so it's the same checkbox. The patient doesn't have to keep on reading a different question. They just go down this checkbox, and they can actually go through that quite rapidly, usually about 10 to 12 minutes. And really, the burden is extremely low. It sounds like a lot, but because they're not switching questions, it's not. And we beta tested this with hundreds of patients, both in ALS and dozens of other diseases, and they actually prefer this mechanism. In fact, we ran a study and we compared another one of our instruments for myotonic dystrophy that had over 100 questions towards the much shorter INQAL and SF36. And there was an 87% and 85% preference for the disease-specific outcome measure that we developed, even though it was slightly longer. One, because we're asking questions that are important in that population. So these generic instruments are not asking questions that are relevant, and that people get ticked off about that. And two, they're switching questions around, so it's difficult to use. And so even though that sounds like a lot, it's really not. And the burden to patients to complete it is low. Now, your second question was, when to use the short form versus the long form. And so we typically prefer the long form because there's a lot of validation that's been into that. You get a lot of data every time you use it. It's not burdensome to patients to use. But sometimes, again, it takes 10 to 12 minutes typically. So sometimes you want a patient to be able to complete this really rapidly, or maybe on a weekly basis, or maybe even a daily basis. And so the short form can be completed in less than a minute. We know that it does correlate with the longer form. It's not quite as validated, but in some instances, you might want to put it on a phone, or you might want to have patients complete the outcome measure on a more rapid basis. And in that cases, people decide to use the short form.
Yeah, Nadia, just to echo some of that from sort of being in the clinic, we generally do hear back from patients that they don't find this burdensome to complete one. And just to echo what Chad said as well, I hear certain patients and their family members ringing in my ears about sort of frustration with non-specific instruments, that these questions sort of aren't relevant. Why are they asking me these things? And there can be sort of a loss of patience with it, in a sense that we're misguided in what we're asking about, and are we really talking about the things that matter? So both of those really sort of resonate from what we hear from patients and family members.
That's really good to hear. So for other tools that exist then, like ALS-FRS and ALSAC and Rhodes, how could this tool complement the information in those?
Yes, I'll share some thoughts. The ALS-FRSR, as I think this audience well knows, has been sort of the workhorse of ALS clinical trials. And it's a good instrument, but it's got many limitations. It's also not really a patient-reported outcome. It's an interview that a trained evaluator does with a patient. And I think it's the workhorse because it's been around for so long and we understand it well, including its limitations. You know, the ALSAC has been around for a while as well, and this was also built off of patient interviews. And, Chad can comment as the extent to which the methodology varies or is different. But I will say that the ALSAC covers sort of fewer domains and misses areas that are important to patients that we know from these interviews and talking to them and hearing about the things that matter. And I'm not sure what the history of the ALSAC is and why it really hasn't sort of taken off, but it typically hasn't sort of made its way prominently into clinical trials. The Rhodes, I guess, is a newer version. And again, it's a different methodology, I think. I'm not the rash expert. The R in Rhodes is a rash analysis. But I think this started out with a literature review and patient input came later. And so it's sort of been built in fundamentally a different way. But Chad, maybe you can comment more on some of the sort of nuances of the methodology and how these differ.
Yeah, thanks. So, just to start off, our instrument is used for a lot of different ways for payer studies. It's sometimes used in clinic, but at the core of it, we designed it really to be regulatory grade, satisfy FDA criteria for use in therapeutic studies in the United States. And so that really is its intended use, which probably is not the intended use of the other three instruments that are mentioned. And as such, we really designed it to be as sensitive as possible. This is really a key feature, and we designed it again from the ground up to really satisfy the FDA's criteria. And so I think every time a clinical researcher designs a trial, they should take everything into account and look to see what they really want to measure and what the purpose of the study is. And as Dr. Benatar mentioned, the ALS AQ40, that's a very good instrument. They used good technique in developing that. That was primarily British populations or UK populations that were used in the initial validation of that instrument. And it doesn't really cover all of the domains that patients have identified as being really important to patients. The ALS FRS-R has been around for a long time. It's an important historical instrument, but it may lack some of the responsiveness that you need. So if you have a treatment that does provide some benefit, if it shows up on the ALS FRS, it probably has provided a lot of benefit. But there's a possibility that the drug does provide benefit and that instrument fails to detect it. In fact, I think there's been some studies looking at that where it hasn't been responsive to some really good treatments. And then the Rhodes was done using a rash analysis. There's benefits and potential drawbacks to using a rash analysis. Namely, you need to be measuring one concept. And so it's unidimensional concept. It's not measuring multiple concepts. And sometimes you can have questions that land in a rash study that really are not overly useful or relevant or common. So blowing out a candle, drinking from a milkshake, these things may not be something that patients do commonly. And the other thing that can limit a rash analysis is that it assumes that people develop difficulty with things in a standard fashion. But we know in ALS that some patients develop symptoms in the lower extremity before the upper extremity and vice versa. And so that can sometimes be problematic. But all in all three are good instruments, and I think it just needs to be, what you're trying to do with your study. Do you want a sensitive instrument that can really measure the multiple factors that are important to ALS? And what are you trying to do? So I think those are the key issues that need to be addressed when selecting an outcome measure.
I think that was very helpful. And then you also mentioned in the publication that individual subscales could be used on their own. So if a therapeutic is meant to address pain, for example, you could use that subscore on its own. So that seems to be a very helpful feature. Can you talk a little bit more about that?
Yeah. So again, we realized that if someone comes up with the cure to ALS, most of the outcome measures that are out there will change. But we wanted to have a versatile instrument so that if you were studying something that was going to address one critically important symptom in ALS, that you'd be able to measure that in a clinical trial. And so something like pain, which is not the most important thing in ALS, but it is important to some patients. There's a pain subscale that's included as part of the ALS high. And so if you owned Tylenol and you wanted to run a study to see the effect of Tylenol on pain in ALS, you could use our outcome measure and pre-specify. Say, we're going to look at, the ALS highs pain subscale before and after treatment and see how the ALS high score changes in response to our therapy. You can do this for any one of the subscales. Most people just typically just give the whole outcome measure. Again, like I said, it's easy to use. They get all the information as well as the total score. But you could also use each of the individual subscales in isolation.
Yeah, and Nadia, you've probably seen people doing this a little bit with the ALSFRS-R, right? It's got sort of 4 components, a bulbar, a fine motor, a gross motor, a respiratory. And although the scale wasn't designed for each of those individual sort of subsections to be used individually, people are trying to do that. So I think, as Chad's pointed out, one of the nice things about this instrument is that each of those subscales, in a sense, can stand alone.
I think that's great. Could you talk a little bit about, I think you had mentioned that the ALS Association and some pharmaceutical companies are using this in longitudinal studies right now. Can you share a little bit more about that? And then also, what are next steps to getting this to be used in clinical trials?
Yeah, I think, like I said, it's been used in pharmaceutical studies. I can't specify which of those due to confidentiality reasons. And also the ALSA is utilizing the instrument in a longitudinal fashion. And the CREATE network is doing some wonderful work with the instrument. And I think these studies will really provide additional information of the performance of the outcome measure and really kind of facilitate its use going forward. And specifically the CREATE network study, where we'll be able to compare the performance of the outcome measure against other functional outcome measures that are being measured, genetic markers. We can see how the natural history of the disease changes as measured by the ALS high. And so this natural history data, looking at disease burden and how the different areas of disease burden change over time, will be just really interesting and informative going forward. And I think we want this to be used as much as possible. We feel like this is a really good way to allow the patient's voice to be heard in clinical trials. And we feel that it's a very sensitive outcome measure, and it can provide a lot of benefit and value to studies that are looking to study therapeutic interventions. And, where it's going to go from here, I don't know. I'd love for it to be used in the Healy platform study. I think that's a natural fit for it. But outside of that, I think using it in academic studies, pharma studies, government studies, and registries makes a lot of sense.
Yeah, it sounds like you've developed a tool that is very different from other things that are out there and very sensitive. And so I'm excited to see where this goes. So one final question for me, I think, why would it be so helpful for you to publish your methodology in so much detail? You shared so much about how this was developed and how could that help people and why is that important?
Yeah, I think, it depends who you are, Nadia. I mean, if you're a pharmaceutical company, you want to get a drug approved, it's important to have this data. And, we have this data we can share with companies to go to the FDA. But when we publish the data, this is peer reviewed and people can see, how was this instrument made? How was it validated? What patients were involved in the validation? And so these aspects are really important when you have to justify an outcome measure before you can justify a therapeutic intervention. And so having that data published and available to the public, I think, is really important. And, one of the things that is, again, novel about our outcome measure is in the stone age of outcome measure development, people put in questions and they said, well, this question is going to be worth 1 point and this question is going to be worth 1 point. And that really is not a truthful way because everyone knows that questions are not equal. using a straw is not the same value as being able to walk independently. And so that kind of methodology for scoring is convenient for the scorer and the physician, but not really representative of what's important to patients. And so, this particular outcome measure has a very sophisticated scoring algorithm that weights based on the relative importance. It also takes into account missing data and really is true to the patient's preference as far as what's important. And so providing this data to the community, I think, is important so that it's not a black box. This was developed in a black room years ago. This is how we did it and why we did it, and this is how it performs. So this data is important to the research community, in my opinion.
And maybe, Nadia, maybe I can just add, and I think we might have spoken about this before, one of the challenges with the ALS FRSR is it wasn't until very recently that anybody asked patients what sort of change in an ALS FRSR matters to them. There's been a little bit of work looking at this, and there's some controversy around that. But in a sense, it's very backwards, sort of starting with an instrument and not sort of knowing to what extent changes on that score matter, as opposed to starting from the patient perspective, what are the things that matter and how do we build an instrument from the ground up? And so I think in a sense, coming back to where we started about what are PROs and why do they matter, I think as Chad nicely put it, it's sort of putting the patient voice first.
And I think that's beautiful. That's how it should be, right? Especially if the goal is to improve how somebody functions and feels, what better way to do it than to ask people what that would mean to them. So I think that's fantastic. Dr. Bedlak, do you have anything else?
No, I just wanted to say thank you to Nadia, to you for all these great questions, but also to Chad and Michael for this beautiful work. I mean, I feel like this was one of the most impactful podcasts that we've done. I'm very optimistic about this instrument and its ability to help us find better drugs, but just as importantly, to convince payers that these are important drugs to cover. Because that is something that we're all struggling with in ALS right now. We have a lot of newly FDA-approved drugs, but we can't get them for a lot of patients because payers don't see the impact. So hopefully this will help there.
Wonderful. Thank you, somebody.
Yeah, I think that wraps it up. I appreciate everyone's time and have a good rest of your week.
Thanks all.
Thanks, everyone.
Thanks, Chad.
Hi, I'm Ted Burns. I'm a neuromuscular doctor at the University of Virginia. I'm again talking with Richard Bedlak. Richard is an ALS specialist at Duke University. He heads up the ALS Untangled group. Let me remind listeners to listen to our introductory interview that provides background on the ALS Untangled group. Today we're going to discuss one of the ALS Untangled publications, this one numbered number 15, about coconut oil. And before we do, let me also remind the listeners that this podcast is supported by the CREATE Consortium. CREATE stands for Clinical Research in ALS and Related Disorders for Therapeutic Development. And the major focus of CREATE is to advance the science that aids development of therapies for patients with ALS and related disorders. Rick, let's start by having you provide brief background on coconut oil.
Sure thing, Ted. Coconut oil is literally an oil that is extracted from the kernel or the meat of coconuts. It's available in a basic, also known as virgin form, and also an RBD form, which means it is refined, bleached, and deodorized. It can be fractionated into different medium chain fatty acids. Fractionated coconut oil is sometimes referred to as an MCT, medium chain triglyceride. Various forms of this stuff, coconut oil, are used in flavoring, cooking oil, engine fuel, lubricants, soaps, herbicides, and even flea repellents.
And could you talk about any theories that might explain why coconut oil might be of interest to the ALS community?
Yeah, there's two possible mechanisms by which this could slow ALS progression. First, we know that the ingested medium chain triglycerides in coconut oil get converted into ketone bodies, which can cross the blood-brain barrier. There's some evidence that these ketone bodies might be able to be used by central nervous system neurons to bypass the problems they have producing energy in diseases like ALS. Second, there's evidence that nutritional status, and in particular lipid metabolism, are important prognostic factors in people with ALS. Coconut oil might slow ALS progression simply by acting as a high-calorie supplement that increases circulating lipids.
Okay, thanks, Rick. And I heard you say medium-chain triglycerides that are converted into ketone bodies. So let's talk about the ketone diet, which is something that you and your colleagues mentioned in the manuscript. setting aside coconut oil perhaps for a second, could you just talk about the ketone diet idea in ALS? Ketone diet is something sometimes epilepsy patients try. Is that something ALS patients could try?
Yeah, so just to go back to the preclinical data, there is actually a flawed study of a ketogenic diet in the SOD1 mouse model of ALS, and that showed some benefits. A ketogenic diet for people classically means a 4-to-1 ratio of calories from fats versus carbohydrates. And this is another way to elevate those ketone bodies. I tell patients that ask me about it that we have no proof yet that this helps people with ALS. We tried to get a trial off the ground a few years ago, but nobody signed up and the trial had to be closed for lack of enrollment. I suspect this happened because the ketogenic diet is not easy or attractive to people. In fact, if you read papers looking at the ketogenic diet across different conditions, including epilepsy, less than half of everybody who starts it stays with it. One big concern in people with ALS is that this diet causes weight loss. And we know that there's evidence that people with ALS who lose weight may actually start to progress faster.
Okay, and so the thought might be that coconut oil leads to ketone bodies and mimics, I guess, the ketone diet. Is that a fair way to summarize?
It's two different ways to get elevation of those ketone bodies, which we think might be important. And in fact, there's even other ways, Ted. There's another molecule out there now called triheptanoin, which is a medium chain triglyceride that is known to raise ketone bodies. And this also has been tested in the SOD1 mouse model, and it slowed progression too.
Okay. The other thing you mentioned as a theory of why coconut oil might be of interest to the ALS community is lipid metabolism. And you talked a little bit about, can't remember how you put it, but something about high-fat diet. And so could you talk a little bit about this idea of high-fat diet in ALS patients?
Yeah. So again, this is something that we tested in the animal model. And in that SOD1 mouse model of ALS, feeding it a very high-fat diet was associated with slower progression and longer lifespan. It turns out not to be a very easy thing to study. So one of my colleagues, Dr. Anne Marie Wills at Mass General Hospital, tried to study this. She did a randomized trial of 2 high-calorie diets, one where most of the calories came from fat, one where most of the calories came from carbohydrates, and compared these to placebo. It looked like there was a trend toward people on the high-calorie diets doing a little bit better, but it wasn't clear that one type of high-calorie diet was better than another. And in fact, folks in the high-fat diet wound up having more GI side effects than those in other groups.
Okay, now back to coconut oil. So again, you said coconut oil can provide medium chain triglycerides that are converted to ketone bodies, and that coconut oil also provides high fat. So I guess the assumption is that coconut oil can do both of these things, and therefore coconut oil is possibly of interest to our patients with ALS.
That's right. Yep.
Okay. So what's the experience with coconut oil in patients with ALS?
Yeah, so I went back and looked at the website Patients Like Me to see how many people on there now, years after we published our review, are using it. And it turns out there's now 77 people that are on there saying that they're taking it for their ALS. And on Patients Like Me, folks can rate their perceived effectiveness. And so 4 out of 77 report major effectiveness, 6 report moderate, and 9 slight. All the rest could not perceive any effectiveness. But it is interesting, if you look more closely at the people who report major effectiveness, some of them are really reporting improved muscle strength. And that is quite rare in my experience to occur spontaneously in people with ALS.
Okay, but there aren't any clinical trials at the moment.
No clinical trials of coconut oil at the moment, but there is about to be a clinical trial done by me of triheptanoin.
Oh, okay. And that was a compound that can also increase ketone bodies? Is that what you said?
Yeah, it's another medium chain triglyceride that gets converted to ketone bodies.
Okay. And so you're going to do a trial, a multi-center trial or a single-center Duke trial?
This is just going to be a pilot trial. So the idea is that we're going to just see how people tolerate this. People with ALS tolerate it because it's never been used in people with ALS before. But also we have a biomarker to look at the energetics of brain neurons. So we're actually going to do MR spectroscopy. And there was a pretty cool study that was done with this compound in patients with Huntington's disease. And it actually improved the MR spectroscopy signal in the brains of those patients over a short duration clinical trial. So if I can just show that alone, I think I might be able to get funding for a much larger trial. but I am going to follow these 10 patients for 6 months and compare the change in their ALS functional rating scale while they take trieptinoin to how they were doing before. And so that'll just be a way to get sort of a rough idea if it's doing anything clinically in this very small study. But the biomarker is the thing that I'm most interested in for this pilot trial.
Okay, and can you spell that word?
Trieptinoin?
Yeah.
TRIHEPTANION.
Okay.
It's on clinicaltrials.gov too for people that want to see more about it. We've already got the announcement up.
All right. So maybe we can talk about both as we progress through this interview. Let's talk adverse events of coconut oil, and maybe you can talk adverse events as we understand it of triheptanone.
Yeah, I mean, both of these compounds are very well tolerated. A very small percentage of patients on both compounds develop GI side effects, most commonly loose stools. So we'll be watching out for that. But as you know, from taking care of lots of folks with ALS, constipation is pretty common in this population. So something that moves the bowels along would probably be of benefit to a lot of patients. When it comes to coconut oil, there is a theoretical warning. Experts such as the World Health Organization, the FDA, and the American Heart Association have all previously warned against taking too much coconut oil because it has high levels of saturated fat. It also contains lauric acid, which can raise blood cholesterol levels. But there have been some meta-analyses published, and there really wasn't great evidence for concluding that consumption of saturated fats cause an increased amount of heart disease or stroke. And it turns out that lauric acid, while it might raise total cholesterol levels, actually improves the ratio of good to bad cholesterol, HDL to LDL ratio.
Okay. And could you say something about dosing first of coconut oil, but actually, I think I'm going to ask you about dosing the triheptanone, but I don't know if that's also available over the counter. So could you talk about both of those?
Yeah, so trieptanoin is not available over the counter, so it doesn't make a lot of sense to talk about it here. But for coconut oil, we don't know for sure what the optimal dose is. There is one group out there that did some calculations and suggested that 86 mLs of coconut oil, which is about 6 tablespoons, would raise blood ketone levels into the range that was effective in a small Alzheimer's and in an epilepsy trial. So 6 tablespoons a day would be the target dose according to this one paper.
Okay. Any comment on the taste?
I've never tried it. I'll be honest. I've never tried it.
Okay. But you've not seen that on patients like me, that patients complain about the taste?
No.
Okay.
People are taking it in a lot of different ways. I mean, some people are actually just cooking with it, and some people are like putting it into their beverages and things like that.
Okay. And what about cost?
Well, it turns out to be pretty reasonable, depending on, the brand and the dose that you decide to take. The costs are between $25 and $50 a month.
Okay, that's not bad. And so let's have you summarize what you would recommend to patients and loved ones when they ask you about coconut oil.
I tell them that coconut oil has a plausible mechanism. It has relevant preclinical data. It has interesting anecdotal reports. It's easy to get. It's not very expensive, and it seems to be pretty safe. We can't go so far as recommending it until we have trials that show benefit. But for folks who are going to self-experiment with something anyway, I think there's lots of worse things out there than this one. And, for anybody that tells me that they're going to go ahead and try it, I advise them to create a profile on patients like me and follow their outcomes there so everybody can know what happens.
Agree. That's great. Any final comments?
Yeah, just that I'm so excited about this potential mechanism that I've been working for the past couple of years to get a clinical trial of something similar. It turns out it's going to be triheptanone off the ground. So I hope to start enrolling in that trial by the end of this month, which is May 2018, and hope to have results ready to present by early next year.
That's great. Rick, as I'm listening, I'm thinking there are a few things we've talked about in this series of podcasts that are exciting or certainly of interest. When patients ask you, can they try 2 or 3 different things at the same time, how do you answer that question?
Yeah, it's going to come up when we talk about the Vienna Protocol. So what I tell folks is nobody knows how these things are going to affect you individually, much less, in a combination. So if you want my advice, what I would do is, pick one that, has a mechanism that you're comfortable with, a price point that you're comfortable with, that has a risk profile that's acceptable to you, and give it a few months and let's see what happens in terms of how you feel and how your ALS functional rating scale changes. So we typically see our patients about every 3 months in clinic. So I say, if you're going to start that one, why don't we just monitor it for the next 3 months and let's see how many points your scale changes. And we'll compare that to how you were doing before you started it and decide if we want to keep that one, add something to it, get rid of that one if you don't do well over the next 3 months and substitute it. But I think that's the most logical way to go about this.
Perfect. Okay. Thank you, Rick. Once again, I've been speaking with Rick Bedlack from Duke University about coconut oil. Thanks, Rick.
Hey, everyone. I'm Dr. Rick Bedlack, professor of neurology and director of the Duke University ALS Clinic. I'm also in charge of the education and outreach department in the CREATE Consortium. This is part of the NIH-sponsored Rare Disease Clinical Research Network. CREATE is a clinical research consortium that's focused on therapy development for ALS and related disorders. CREATE aims to help overcome some of the barriers to therapy development with the goal of improving the success of future clinical trials. And today's podcast is part of a series we developed to help non-scientists understand some of the work that our CREATE team is doing. I'm really pleased to be joined today by Dr. Nadia Sethi. Nadia is Director of Community Outreach and Engagement for the ALS Therapy Development Institute. She's also co-chair of the Northeast ALS Consortium's Patient Education and Advocacy Committee. Nadia lost her husband to ALS in 2020. So in this podcast, Nadia and I will interview the authors of the recent publication, Temporal Course of Cognitive and Behavioral Changes in Motor Neuron Diseases. We're joined by Dr. Caroline McHutchison, neuropsychologist and CREATE clinical research scholar at the University of Edinburgh. Caroline started working in the MND ALS research community in 2015 during her PhD program with Professor Sharon Abrahams. Since then, she's been working collaboratively with the team at University of Miami. This will be a joint interview with Dr. Michael Benatar, who's been with us on previous episodes of this podcast. Dr. Benatar is professor of neurology and chief of the neuromuscular division and executive director of the ALS Center at the University of Miami Miller School of Medicine. He's also the director of the CREATE Consortium. So Nadia, I'll turn it over to you.
Thank you so much, Dr. Bedlack. Hi, Dr. McHutchison and Dr. Benatar. Thanks so much for joining us today. In this publication, you explore the changes in cognition and behavior over time while evaluating whether demographics or clinical and genetic factors have an impact on these cognitive changes. So first of all, could you describe what some of the clinical changes might be that would be considered cognitive dysfunction and maybe highlight the differences between cognitive dysfunction and frontotemporal dementia or FTD?
Definitely. Okay, so I think one of the things in ALS in terms of cognition and behavior is that we do see that these sorts of symptoms can really vary from person to person. But on the whole, we see that they typically affect two main cognitive domains, and they are called executive functioning and language. And so people who have difficulties with their executive functioning, this can include things like having trouble planning the different steps that they need to take to complete a task or a set goal that they have. It can mean that they have problems with their ability to make decisions or hold pieces of information in mind while they manipulate them. But for some people, it can also impact things that we call social cognition. So that's really the ability to read and understand people's emotions and get things from their perspective as well. In terms of language, the difficulties tend to be maybe they experience changes in how well they can spell certain words, or maybe they're having difficulties understanding what certain words or sentences mean. So they may have problems following instructions. In terms of the behavior changes, in ALS, this is typically apathy that we see. So this can be a real loss of motivation. So they might not be, reaching out and contacting their family members and friends as much as they used to, as an example. And so you mentioned sort of the difference between the cognitive dysfunction in ALS and FTD. And I think the main difference is that the symptoms are more severe in FTD. So they really have a greater functional impact, and it might mean that they have difficulties with their job, or maybe they're having sort of problems with their relationships with family members and friends. But they might also experience a whole range of other behavior symptoms like socially inappropriate behaviors. Maybe they've started to tell jokes that are a little bit rude or inappropriate, or maybe they've had some changes in their diet, so they're eating more sweet foods.
Thank you. That's very helpful. All right. So in literature, how frequently has cognitive dysfunction and FTD been reported in ALS? And also, are these commonly screened for during clinic visits?
So I think, again, this is something that's sort of really varied in the research in terms of how common these symptoms are. But in general, the research will state up to 50% of people will experience some degree of change in their cognition and their behavior. So it's important to note that for the majority of people, these changes are relatively mild. So maybe up to 35% have sort of milder symptoms. But in terms of those who experience these more severe symptoms and they're meeting the criteria for FTD, the proportions of people are between 5 to 15% in ALS. And I think you mentioned as well, just in terms of how often they're screened in clinic, I think we're really starting to see an increasing recognition that these are really important symptoms for us to assess. And as a result, we're starting to see that they are more often being looked at by people in clinics, definitely here in the UK as well.
And perhaps, Nadia, I can just add to that this is complicated because it takes time to do sort of a good quality screen, and that's often challenging in the context of a multidisciplinary clinic. So I think many clinics often resort to sort of fairly brief screens, but they're really just that. And I think one of the areas where we collectively need to do better is to figure out how to, with some periodicity, maybe not at every clinic visit, do a more detailed assessment to understand this. And there are some tools, but I don't think they've really made their way into widespread clinical practice in the US.
So, Carolyn, Michael, I have a question. Given how subtle these changes are and the fact that most people don't have them at all, why is it important for us to screen? Is there an effect on prognosis? Does this change the way that we present options to our patients and family in clinic?
Yeah, so we definitely know that even when people might experience very mild changes in their cognition and behavior, that it can have a real impact on their ability to make decisions. So anyone with mild executive functioning, they may have real problems sort of, one, deciding whether they want to take part in, say, a clinical trial, or perhaps they need extra help making decisions about what sort of clinical care that they want as the disease progresses for them. So I think even when they're subtle, they can be really important to identify people with those problems so that we can provide them with the right support.
And I guess the added piece to that, Rick, is the behavior perspective. If the behaviors are sort of rising up, the caregiver may not realize that it's part of the disease and may misinterpret that. And so I think understanding that, sort of in a sense, putting a label to it and helping both the patient and the caregiver are important aspects of this.
Yeah, and I think with those behavior changes, even when they're mild, they can be quite distressing for not just the person with MND, but also for their family members. So making sure they're aware that they are a normal part of the disease and how to handle them can be really helpful.
Yeah, and I know here at Duke, it kind of changes the way that the whole team presents options. Normally we're focused right on the patient, right? We're sort of pull our chairs in close and we're looking right at the patient and we're presenting all the options to the patient. But when we find out that there's any cognitive or behavioral dysfunction, we kind of invite the family to huddle together and we pull back a little bit and we explain that they may need to make decisions as a unit. And also they may need to monitor compliance, that it's not nagging to remind the patient of why this medicine's important or why this piece of equipment's important. Because I think a lot of times, that's the worry that our caregivers have, is that they don't want to nag the patient. So yeah, I think it's all really important.
I think I have something to add to that too. For a symptom like apathy, how do you quantify that? I mean, are you looking for symptoms beyond something just like that? What if it's apathy alone? Is that still a concern, or are you looking for a combination of multiple things here?
So, I mean, we're really looking for anything because apathy is really common in people with ALS. That symptom alone is enough to trigger, concern if it represents a change for that individual. Obviously, when we're interpreting the symptoms of apathy that we might observe, or perhaps a loved one has observed, we're also taking into account things like, are they experiencing symptoms of depression that we also need to look at? Or are they undergoing significant distress as a result of their diagnosis? And we factor that sort of thing in when we think about things like apathy, but they can occur with other cognitive symptoms, with other behavioral symptoms. Apathy can occur on its own or with other cognitive and behavioral symptoms.
Thank you for that. And what might have been some of the limitations of previous studies on cognitive dysfunction and ALS?
So some of the early research which looked at cognition and ALS was really limited by the types of tools that were being used to assess cognition. When we think of people with ALS, we know that they have physical limitations, and that can really impact how well they're able to respond to certain tasks in traditional neuropsychological testing. And so that's had a real impact on some of the earlier results. But as we're improving the way that we measure cognition, we're starting to see sort of improvements in the research studies that are looking into this. And I think just maybe another point is the designs of the study. There's very few studies that have looked at cognitive changes over time. Many just look at cognition at one time point.
So participants for this particular study were drawn from those enrolled in the phenotype-genotype biomarker study through the CREATE consortium, and that evaluated people every 3 to 6 months. And this group included people with ALS, PLS, PMA, and HSP. What did the evaluations for the study include? What were you studying in the participants over time?
Yeah, perhaps I can start with that. I mean, one of the underpinnings of the PGB study is that we wanted to acquire really good quality natural history data. And we wanted to acquire that not just in terms of the motor phenotypes, so what does the motor function look like, but also the cognitive and behavioral function. As Caroline mentioned, there isn't great longitudinal natural history data. So one of the goals was to acquire that. And then to pair that, as the name phenotype-genotype biomarker implies, with whole genome sequence data and also biofluids to enable biomarker discovery and validation. So the phenotyping was what we call deep phenotyping, trying to characterize people across the spectrum of the manifestations of disease, but in addition, pair that with the richness of other data types, including things like environmental exposures. So PGB was one of the really sort of unique opportunities, I think, in our field to acquire this depth of multimodal longitudinal data. And I think is a unique opportunity to study different aspects, including, as we're discussing today, cognition and behavior.
Thank you. And then from a genetic perspective, you evaluated all participants for the C9 repeat expansion, as well as SNPs in UNC13A, and I hope I'm saying this correctly, TMEM106B. Could you share why these other two genes might have been relevant? We hear a lot about C9 and cognitive changes and FTD.
Yeah, so, one of the questions, and this comes up in C9, but in patients with ALS more generally, why do some people develop cognitive and behavioral dysfunction and some people don't? And, one of the thoughts is that the C9 off repeat expansion is a mediator of this. But even within the C9 population, not everybody develops ALS, not everybody develops FTD, or not everybody develops both. And so the question has long been, are there genetic modifiers of that? And there's some suggestion from the literature that polymorphisms in TMEM106B and UNC13A might be protective or drive you towards an ALS or an FTD phenotype. And I think one of the limitations of those prior studies is that they've been based on either very limited phenotyping, so what's documented in the medical record, or a single snapshot in time, which may not capture the evolution of disease. And so what we wanted to do was look at those reported SNPs in those genes in the context of a more detailed longitudinal look. And as we may talk about, I think what we see is a little bit different to what's been reported in the literature before, and maybe that reflects the different approach to data collection. I don't know, Caroline, did you want to add to that?
Yeah, I think it's also just worth noting that, we mentioned before that a lot of the early research was limited by the tools that have been used to assess cognition. And I think when we look at some of the studies that have examined these other genetic modifiers, we again see that perhaps they're limited by the tools that they've used to assess cognition, which may be influencing the results that we see.
So for listeners that might not be familiar with the ECAS or Edinburgh Cognitive and Behavioral ALS screen, can you describe how this measure works and how it's conducted?
Certainly. So the ECAS has been developed specifically to assess cognition and behavior in people with ALS. So it really accounts for the fact that often these people have physical limitations that make it difficult for them to respond. We've made it nice and brief. It's around 20 minutes to complete, and it assesses those cognitive functions that we mentioned at the beginning that are really common in people with ALS. But it also assesses other cognitive functions like memory and visual spatial skills. And these are typically affected in people with Alzheimer's disease. And it can really help us determine if the cognitive symptoms are related to the FTD-related dementia or more of the Alzheimer's disease dementia. So it is conducted in person with someone who's been trained to complete the ECAS. But we do have a version now which can mean that people can do it over a video call. So this makes it a lot more accessible. And then we also have a behavior component, which we complete with someone who knows the participant or the person with ALS really well. And that provides us with some information and details around whether they've seen any changes in behavior from their normal pre-ALS state. And it's really important that we get the perspective of someone close to the person with ALS, because often they don't have insight into the changes that they're experiencing themselves. So that's sort of a brief overview.
One follow-up question about the ECAS. So, I was first made aware that there might be some cognitive issues in my patients by Kathy Lomenherth's group at UCSF. I think it was like around 2003 when I started to see her reporting on this. And back then, I think she was doing like full neuropsychological testing that takes hours. And then I think, eventually she sort of developed this tool called the ALS Cognitive and Behavioral Screen, the ALS CBS. So I wondered if you could just tell us how the ECAS compares to a full battery of neuropsychological testing and why it might be better than the ALS CBS, which is what I've been using.
Yeah, so I think that definitely people are still using the ALS CBS, and it is a valid tool that we can use to screen for cognitive dysfunction. It does sort of not capture certain cognitive functions as well as the ECAS, such as executive functioning. But the ECAS has been really well worked up in terms of we can be fairly confident that when we do the 20-minute ECAS assessment, that we're capturing the same individuals as having cognitive impairment as we would be if we did, say, a full 2-hour battery of full neuropsych testing. So in terms of its ability to detect people that we need to, be aware of their cognitive impairment, the ECAS does really well there. Another benefit of the ECAS over the ALS CBS as well is if you want to follow people over repeated assessment, they have multiple versions. So it means that between each assessment, the person isn't going to be impacted by, say, learning what type of questions are going to be asked and therefore getting better at the task because they've had more time to practice, perhaps.
And Rick, the other thing I would add is I think they're fundamentally different tools. The CBS is literally a screen to tell you whether somebody needs an additional evaluation. The ECAS is actually a short assessment battery, which gives you some qualitative and quantitative sense of how people are performing in different cognitive and behavioral domains. So I think they have slightly different sort of intent and purpose and accomplish different things.
All right. So within your study, some participants didn't have the 3 time points that you were looking for. And those participants tended to have lower ALS-FRS scores, indicating that they had more advanced disease. Do you think there's implications to this for your analysis, since people with more advanced disease or more rapidly progressing disease might have been excluded from your data set?
Yeah, I think that this is a really important point to make. And it's something that's really common in studies where we assess people longitudinally. So it's possible that these people who have the faster progressing disease are also more likely to experience greater declines in their cognition. And by including people with just 3 or more time points, we're potentially missing some of these people who are experiencing cognitive dysfunction and cognitive decline over time. So it is possible that perhaps, we identify this subgroup of people who do experience cognitive decline. It may be that there are more people in real life who belong to this group who are experiencing this pattern of change.
Now, I guess, Nadia, just to add, I think this is one of the intrinsic challenges to studying natural history of disease. And this is, in a sense, we really need the partnership of our patient community to help us collect these data and understand the sort of entirety of the disease. And that's hard. We know it's hard and time-consuming and physically challenging. But if we don't acquire these data, we're left with a very incomplete understanding of the disease. So I know there are lots of calls in the community for natural history studies, and PGB is, as one example, and we have a version of this that's currently ongoing. And so just to underscore the importance of our getting as full a picture as possible.
Thank you so much for highlighting that. So can you talk about the overall findings within the study? What did you learn about cognitive changes over time, and was anything surprising to you?
So overall, our study, or the findings from the study, showed that in the group of people with ALS that we looked at, the majority of people weren't experiencing any cognitive dysfunction, and they remained relatively stable over time. But we did see that there was a small subgroup of individuals who were experiencing cognitive difficulties when we first assessed them, and these continued to decline over repeated assessment. When we compared people who carried the C9 repeat expansion with those that didn't carry the expansion, we did see that people with C9 decline more. So there is something to do with C9 that affects cognition. But I think what was really interesting was that not everyone in that low and declining group had C9. So there's something else that is impacting people's cognition that we really need to work to try to figure out what that is. So the whole picture isn't C9.
Were there other genetic mutations that might have come into play there?
So the research has sort of really focused on C9 so far. I think some of the early research maybe suggested that SOD1 didn't contribute to cognitive dysfunction. But again, that early research, they had much smaller numbers of people with the gene. And I think as our research improves and we're starting to collect more data on people with different genetic mutations, we're starting to see that there's maybe a slightly different picture there. So I think this is a really important area of ongoing research that we might have a better idea of in the future.
That's good to know. And as far as UNC13A and TMEM 106B, were there any protective effects that you saw from those?
So we did not find any protective effects in our sample, which is in contrast to some of the previous research.
All right. And then you found cognitive impairment in about 8 to 18% of participants, which is lower than what other studies have reported, which we had talked about. Do you think that these findings are a more accurate assessment, or do you have thoughts on why this might have happened?
Yeah, I don't think that it's necessarily that it's a more accurate assessment of the rate of cognition. I mean, when we look at the research, it has sort of fairly consistently been shown in up to 50% of people. So it might be, as we mentioned before, the fact that we've got this group of individuals who are healthier, they're slower progressing. I mean, when you think about inviting people into a study which assesses people over a long period of time, we might be more likely to get people who are generally healthier. So I think it's sort of the differences between the rates of impairments are due to lots of different factors that we've kind of mentioned.
And perhaps I can just add to that. I think one of the issues, and we probably can't get into it too much, I think has to do with not just the tool, but the normative data. What do we regard as sort of normal, in scare quotes, performance in healthy people? And one of the things Create has done, and I can't recall if we spoke about this in a previous podcast, is look in a largish controlled population and try to develop normative data. And that's important because populations differ for all sorts of reasons. Age, demographic, education distributions, and cognition clearly varies based on that. And so one of the things here is that we were using North American norms developed using quite robust methodology. So that might have played a role too.
Yeah, and I think also just further to that is there are a lot of cultural differences and they can really impact people's responses to cognitive testing. And the version that we used here in Create was one that was specifically developed for the North American population. So that's another really important point.
That's very interesting. All right. So could you discuss the concept of cognitive reserve and the findings that those with higher education actually had small increases in cognition over time? I thought that was very fascinating.
Yeah, so the concept of cognitive reserve is very interesting. So it's this idea that there are certain things that we are exposed to throughout our lives that may increase the strength or the number of pathways within the brain. And this then makes us more resilient to sort of neurological damage. And so many people will look at things such as having more years of education, or perhaps whether someone experienced certain types of disadvantages in their childhood or adulthood, such as financial or health disadvantages, and see how they relate to cognitive reserve. So you mentioned we found, people with higher education, typically their cognition remains stable, or in some cases it even increased. And it's really difficult from our findings to know whether this does support this theory of cognitive reserve, or perhaps it's something else where people who have more education are perhaps more able to develop techniques or strategies to complete cognitive assessments. And that might be why we're starting to see slight improvements over time.
All right. And then could you discuss potential confounding factors? So in a dire disease like ALS, there will be strong emotions and depression, which we talked about a little bit earlier. How might those have influenced the findings of your study?
Yeah, so depression definitely can have quite a negative impact on someone's cognition. It can really affect, our ability to concentrate or our memory. In the Create study, we assessed at their baseline assessment. So when people first came in, did they have any history or had they been diagnosed with something like depression? And we actually found that in the study that there was very low rates of depression. So we can be fairly confident that there wasn't a major impact of this in the data that we saw. One thing was we didn't actually sort of follow this up over time. So we can't be certain as to whether, people who don't have depression at baseline, Are they increasing over time, and how does that impact cognition? But I think that's something that's important to think about.
Okay. And you discuss in the publication that some of the cognitive changes that might occur might happen pre-symptomatically. So how could you study this further for those that don't have a genetic risk? This would be really challenging to study in a research setting, right? And then how do you safeguard those that might be gene carriers from being assessed erroneously?
Yes, I'm happy to start with that. Caroline, we've been studying for a long time people at genetic risk for ALS, and so that's the obvious way to get into thinking about pre-symptomatic disease. And so that's an opportunity for us to learn whether people develop cognitive or behavioral symptoms and when they develop them, and do they emerge before motor symptoms. And that's work that's ongoing, and hopefully we'll get to come back and talk about that in another podcast soon. We're just beginning to think about how we might do this in the non-genetic population. And again, maybe that's a topic for the future, but the idea would be if there are people who have subtle motor or cognitive symptoms and they've come to clinical attention, can we get them into a study to understand, is that a risk factor for developing ALS? I think those are unanswered questions, and we're sort of standing at the cusp of beginning to think about those things, but they're difficult problems to study. I don't know, Caroline, if you want to add to that.
I think, from studying people in pre-phase and looking at their cognition and behavior, we really are learning, what sort of symptoms come up very early on in the disease. And that will help us identify people without the genetic risk in the future. So yeah, we're definitely learning.
And to your point, Nadia, this is enormously challenging. We've got to be careful with the tools we select, the normative data, the interpretation. We don't want to be telling otherwise healthy people who carry a genetic risk, you're behaviorally impaired, right? Or you've got cognitive impairment. We have to be very confident of that before we draw those conclusions and communicate them. So I think we have a fair bit of work to do to make sure that we're standing on a firm foundation as we work to understand that and think about that communication. So we're very mindful of that and very sensitive to what we communicate and how.
Really interesting. I wanted to just sort of come back and see if I should change my practice based on what you found here. So in my Duke ALS clinic, and some of the other ones I visited do the same thing that we do, we perform cognitive screening the first time the patient comes in, and we only repeat it if the patient or family or our multidisciplinary team raise a concern that something has changed. I mean, should we be repeating it at every visit, or is that approach still reasonable?
I mean, I think it depends how often you're seeing people. I do think that there is value in repeated assessment, maybe say every 6 months, just so that we are capturing people who might be having very subtle changes in cognition. One thing that can often happen is you kind of have some people who are very aware and they're sort of monitoring any cognitive or behavioral symptoms. But then you might also have some people who are sort of dismissive of them. They kind of think that, it's maybe due to stress or depression or anxiety, where in fact it might be part of the disease. So it could be quite important to repeat that assessment just to capture those symptoms in some individuals.
And Rick, just to say what we're trying to do, we try to do the CBS at every visit as a screen, and I'm trying to figure out the logistics around thinking about an ECAS perhaps every 6 months. It doesn't fit neatly within the clinical workflow, but I guess I have a concern that the CBS may not be enough, and I think we won't know until we start to integrate it into clinical practice and learn. So it's one of the things we want to try and do.
It's just so challenging, as you know. I mean, there's so many things that we're trying to do. I mean, the patient is already with us for about 4 hours, and they're pretty exhausted, even with the limited screens that we do. So, taking on a new instrument that takes, I would say, significantly longer than the one that we've been using, is going to be a challenge.
I agree.
From a caregiver perspective, I have a question. What types of support are offered to patients and caregivers that might have some cognitive dysfunction going on?
Yeah, so I think that can really vary from sort of clinic to clinic where someone is seen. I know in a research setting, if we identify people who might be experiencing sort of significant caregiver burden or distress, or perhaps are having difficulty managing the cognitive symptoms, they would then get a referral to a clinical psychologist or a clinical neuropsychologist who can best help them develop some mechanisms or processes to help manage those symptoms.
And maybe to add, Nadia, I think this gets done differently in different places. Here in Miami, we have a psychologist in the clinic, and so we try to help through that service. Where I think we have room for improvement is doing a better job of integrating with our FTD colleagues and learning from them and the support structure they offer. And this has actually been a big push from CREATE, is to bring the ALS and FTD communities together. And we've been partnering with both ALSA and AFTD to think about how we might learn from each other to better support motor dysfunction in FTD clinics and cognitive and behavioral dysfunction in ALS clinics, because it sort of spills across areas of expertise.
That's very helpful. Thank you so much. Thanks for joining us today, Dr. McHutchinson and Dr. Benatar. We appreciate your efforts and time devoted to sharing this important research with our community, and we look forward to next time.
Great. Thank you, Nadia.
Thanks for having us.
Hi, I'm Ted Burns. I'm at the University of Virginia. I'm again speaking with Richard Bedlack. Richard is an ALS specialist at Duke University. He heads up the ALS Untangled group. And let me remind our listeners that this podcast is supported by the CREATE Consortium. The major focus of CREATE is to advance the science that aids development of therapies for patients with ALS and related disorders. Today, we're going to discuss the ALS Untangled publication on Lunasin. This is publication number 26 from this highly skilled group of dedicated ALS doctors and scientists. And Rick, let's start by having you tell us where the word Lunasin comes from, and then will you tell us a little bit about this peptide?
Sure, Ted. Lunasin comes from a Filipino word, lunas, which means cure. It's a 43 amino acid peptide, which was originally isolated from soy and is also found in rye, barley, and wheat. It's claimed to have a number of potential health benefits, including being an antioxidant, an antihypertensive, an anti-inflammatory, an anti-cancer, something that can lower cholesterol, and something that can help fight obesity. My interest in this started when I was sent an online video about a man with ALS named Mike McDuff, who reportedly had significant improvements in his speech, his swallowing, and his arm and leg strength while he was taking Lunasin. We found him. He was nice enough to send us his medical records, and we were able to confirm that he most likely did have a form of ALS called progressive muscular atrophy, but also that he really did experience marked objective improvements as measured by various clinicians on his ALS team. And these improvements rarely occur spontaneously in people with ALS, in my experience with it.
Wow. So why might Lunasin help some patients with ALS?
Well, it looks like it has three mechanisms of action that could be useful. First, it can reduce free radicals. And we know from previous podcasts about the importance of free radicals and oxidative stress in the biology of ALS. Second, it can inhibit the release of inflammatory chemicals called cytokines. And we know that neuroinflammation is happening in the brains of people with ALS, and it might be a target worth going after. And finally, Lunasin can alter histone acetylation. So histones are proteins that regulate which genes are turned on at any given moment. And histones themselves are regulated by something called acetylation. So ultimately, if you alter histone acetylation, you alter gene expression. And we know that people with ALS have abnormal patterns of histone acetylation and abnormal patterns of gene expression.
Okay. Rick, could you explain specifically what macrophages are and why they might be of interest in ALS and this podcast today?
Yeah, so macrophages are cells in the immune system that normally help us fight infections. They do this by releasing chemicals that may themselves be toxic or may activate other parts of the nervous system. They also do this by gobbling up bad things around them, kind of like little Pac-Men. Unfortunately, in ALS, these cells seem to be activated with no clear infection present, and they're causing damage to parts of the brain and spinal cord. And there have been some preclinical studies suggesting that Lunasin might be able to alter the secretion of some of these bad chemicals from macrophages.
Oh, okay. And you mentioned something about free radical production, excess free radicals, which we've talked about a little bit to some extent. But is there any reliable, relatively easy way to determine whether or not an ALS patient, an individual patient, has excess free radical production or has abnormal patterns of cytokine production, which is something else that you mentioned?
So at this time, Ted, there's not a really easy way to do this. There's no test that we use in clinic or that patients and families can use at home. But I think that's going to change. There's a lot of work to develop things called biomarkers that are going to help us with this. So there's people working on blood tests, urine tests, spinal fluid tests to look at measures of oxidative stress and neuroinflammation. And my colleague Nazim Atassi at Mass General Hospital is even developing a special kind of PET scan, which can look at immune system activation, in particular the activation of one specific type of central nervous system cell.
Wow. Okay. All right. That sounds great. So Lunocin might work. If it works, it might work by a number of different mechanisms. And let's now talk about if there's any preclinical data for Lunocin in the ALS animal model.
Yeah, unfortunately, that's one thing we didn't find. We didn't find any studies of Lunocin on any preclinical ALS models.
Okay. And what are patients on Lunocin reporting?
So in addition to Mike McDuff, whose case I described earlier, at the time that we wrote this article, we had reports from at least 18 people all over the world with ALS who were reporting benefits. Unfortunately, we were not able to get records to verify either the diagnoses or the improvements of any of these other people, just Mike McDuff.
Okay, that's disappointing. Now, could you talk about your Lunocin virtual trial?
You bet. So I thought after finishing this article that there was enough here to warrant a small pilot trial. So last year I put this together and carried it out. And the goals were to determine if Lunocin could alter histone acetylation and improve progression in people with ALS. I also decided to do this trial a little differently. I'm sure that you've heard the same things that I've heard over the years working in our clinics. A lot of patients are frustrated by the way most trials are run. Many of our trials are very restrictive, so the majority of my patients can't even get in. Many of these trials have lots of in-person visits required, which is difficult for patients to travel. Many of these trials use a placebo, which patients with ALS are not excited about. Many of these trials take a long time to get answers. So the trial that I designed tried to take all that into account and do something different. We did a single center year-long trial that featured broad inclusion criteria. Almost anybody in my clinic could participate. Instead of placebo controls, we used historical controls. So for everybody that came into the study, we looked at their progression before the study, and we found 3 people on patients like me who had a similar progression rate, and those were the virtual controls. So every person that enrolled in this study had 3 virtual controls. Most of the data that we collected in this study was virtual, meaning there were only 3 visits to the clinic over an entire year. All the other visits were done online. So we asked patients to go onto the Patients Like Me website and enter their data. One of the advantages of doing that is that you have real-time results for people around the world that are wondering. So instead of waiting a couple of years to find out what happened to the study, anybody in the world could go on to Patients Like Me at any time and put in Duke Lunocin study and see all the patients in this trial and what their data was showing. So there were several outcome measures that we asked people to measure: ALS functional rating scale, weight, perceived effectiveness. We asked them to measure those things on themselves every month and record it on the website. Twice over the course of the year, we had people come in for blood tests, and that was to look at the biomarker of histone acetylation. One final thing that we did that was quite different than most of our trials is once our protocol was approved, we published this on our website, alsreversals.com. And the reason we did this is that we knew there were people all over the world that wanted to try stuff, that wanted to self-experiment. And we felt like by putting this protocol out there, we would give them something that was reasonable and tell them specifically, how we were studying it, what company we were getting the product from, what dose we were using, and even what outcome measures we were following, so that if they were going to self-experiment anyway, they could try this exact protocol themselves with their own doctor, and they could even measure the same things and record their data on patients like me outside the study. So you might ask, what happened? Well, there's some good news and some bad news. So the good news is we enrolled very quickly. 50 people came into the study in just over 5 months. And although the population we enrolled was much more advanced than that of other trials I participated in, retention and adherence were very high. Most of the patients who started the study stuck with it and did everything we asked them to do. Unfortunately, we found no evidence that Lunocin altered histone acetylation or changed the progression of anyone's ALS. So we conclude that Lunocin's lack of effectiveness is disappointing, but that maybe this type of trial, warrants another try with a different supplement. I mean, we had the highest ALS trial enrollment rate ever recorded. And like I said, this was a very different population that's much more reflective of the folks who come to our clinic. So if we do find something positive with a trial like this, we can be much more certain that that effect will generalize to most of the patients that we see.
Well, that's really disappointing about the primary outcome of the trial. But I got to say, this virtual trial idea I thought was terrific. And it was really nice that you and your team posted online dosing and pretty much the entire protocol, if I recall. I borrowed it for some patients, and that was all really great. And it seems like you said, it seems like this would be a really nice way to run trials rapidly. Was it extremely expensive, or was it a pretty efficient, relatively inexpensive way to get through a trial? What can you say about that?
Yeah, so as you know, most early phase trials cost $1 million or more. This trial cost a little over $200,000. So I think it was very efficient from a resource perspective. And again, part of that is just because we didn't have a lot of in-person visits where we had to pay, for people's time, like the coordinator's time and the investigator's time and things like that.
And you matched every individual who enrolled with 3 similar patients in terms of rate of progression that existed in a natural history database. Is that how you did it again?
Yeah, in the Patients Like Me database. So this is a method. Yeah, this is a method that Patients Like Me actually invented and used to predict what was going to happen in our lithium trials. If you remember, a few years ago, we studied lithium. And Patients Like Me, 5 different groups from all around the world were doing lithium clinical trials. Patients Like Me did a virtual trial. So they compared the people that were on their website taking lithium and matched historical controls using this exact same algorithm. And they showed that there was no difference. And they predicted that the lithium trials were not going to work. And lo and behold, a couple of years later, all 5 groups found the same thing, that lithium didn't do anything, at least for the ALS population as a whole.
Right. So why aren't we doing more of this right now?
It's a great question, Ted. I think there's going to be more and more of these types of trials, but I don't know that they'll ever completely supplant, the traditional randomized double-blind placebo-controlled trial as far as a group like the FDA. I mean, I think...
that's fine. I agree with that, Rick. But if you're not getting yourself enrolled in a trial, we've talked about how Patients Like Me is a great place to record your own personal data. And I agree with that. But it seems like if we could get more organized, we could have 5 concurrent studies running through Patients Like Me. What am I missing? I must be naive. I must not be thinking this through. You would have to come up with a dose that everybody agreed to. Why could that not happen?
No, I think it should happen, and I'm trying to make it happen. Like, I'm already gearing up to do a trial of curcumin, which will be even more patient-centric than the Lunison trial. There'll be no visits in my curcumin trial. Everything that I do is going to be virtual, and the biomarkers that I collect, I'm going to send kits out to patients' homes and have them collect the biomarkers in their homes and send me back the urine and stool that I need. So there won't be any visits required. So I'm trying to lead by example, and I think that you're going to see more and more investigators starting to do some pilot trials like this, but everything always kind of starts with an interest and some resources. So I was lucky enough not only to be interested, but to have some wealthy families. The one in particular, the LVH ALS Foundation, came to me and said, we want to support some of your ideas. We want to give you the money to do a trial of Lunison that you've been talking about. And so what would it take? And I priced it out and said, this is what it would take. And they wrote me a check for it. So I have now funding for the curcumin trial, but it's going to take people who are motivated enough to go out and find the funding and then, want to go through all the steps to getting these trials off the ground. But I think it's the right thing to do for patients. Patients want to be able to participate in these kinds of studies. So I hope to see a lot more of them over the next few years.
Right. If they don't get into randomized control, industry or investigator-initiated trial, this would be a pretty good alternative, it sounds like.
Yeah, no, so I think, part of it is not being able to get in, but also part of it is that some people don't want to be in that kind of study. I got to be honest, when a patient tells me this might be my only trial that I can qualify for over my whole life, I might get one chance. And they say to me, I'm not interested in, the risk of a placebo. I get that.
Right.
But, the other side of me, the scientist side of me, understands why ultimately we'll need that type of trial to be sure whether something works or not. But so I want to be able to offer people both types of studies so that everybody can have the opportunity to participate in something.
Yeah, perfect. Okay, so if I'm a patient or a loved one of a patient with ALS, how do I keep myself posted on what's happening in this virtual trial world?
Well, in general, the best place to go, I think, for information about all the studies that are open out there is the website clinicaltrials.gov, www.clinicaltrials.gov. If you're particularly interested in these studies that I'm doing, I try to post information on my Duke ALS Clinic website and also on my ALS Reversals website. So anytime a new study opens, I post it on those websites. I send tweets out at Duke ALS Clinic. And then I'll publish the protocols. Again, I think that's an important part of all this is to keep publishing the protocols as soon as they get IRB approved so that folks all over the world who are going to self-experiment anyway can have a little bit of guidance on, how to do that.
Mm-hmm. And so they should be registered also on clinicaltrials.gov, right?
Yeah, these trials.
You said that. Okay.
Yep, these trials are registered on there. Yep.
And are they all called virtual trials, the trials we're speaking of? I mean, could you Google ALS virtual trials and probably have some success?
Yeah, you probably could. That word is not necessarily in all these types of studies, but certainly if you pick the name of the product that you're interested in, or, you have time to just search all the open trials on clinicaltrials.gov, you can see immediately what they're asking you to do. And so if you're interested in ones that don't have a lot of visits, you can select those on the website.
Okay. Now, Rick, I was going to ask you about cost and dosing and convenience and risk and tolerability of Lunocin, but I don't know if those are relevant questions. If you're going to tell me your study was negative, what do you think? Is that something we should be talking about? Should patients still consider it, or should they be focusing their energies elsewhere?
Well, I'll just make two comments. So the first is on risk and tolerability. And, when we went into this trial, we thought Lunocin was pretty safe. I mean, that was part of the reason it was attractive to us. But GI side effects were surprisingly common in our trial, especially constipation and fullness. So 2 of the patients in our trial got constipation so severe they had to be hospitalized for it. And I've never actually seen that before in a patient with ALS that wasn't in this trial. So I think those were serious adverse events related to the Lunocin. 32 of the 50 people that we enrolled in this study lost weight over the course of the year, which we do not like to see in patients with ALS, again, because it might mean accelerated progression. And so, after spending the last 3 years working on this trial, I'm now pretty firm in telling my own patients not to take Lunocin for their ALS. So it comes back to, what happened with that patient? Like, why did Mike McDuff get better? Well, I think there must be another explanation. I've now collected 38 people like him, the medical records on 38 people who really appeared to have ALS and unexpectedly got better. Some of them got completely well. All of them regained significant lost motor function. And none of the other 38 were taking Lunocin when this happened. In fact, they were all doing different things. So my leading theory on these ALS reversals, like Mike McDuff, is there's something different about them, hopefully something different genetically. And I'm working with the CREATE Consortium to test this theory now. We're actually going to do whole genome sequencing on the 38 ALS reversals.
Great. Okay. So if a patient is on Lunocin, let me present 2 scenarios. If somebody's on Lunocin now and they haven't noted any potential benefit, it sounds like they should probably stop. Do you agree?
Yes. I mean, if a patient with ALS is taking it to try to slow their progression, I would let them know about the results of the study. Now, there's other reasons why people might take it. I mean, I still do have some patients in my clinic who take it because they say they feel better on it. It's hard to argue with it. I mean, and you think it's helping you to feel better and you're okay with the price, which to take the regimen like Mike McDuff took, it's about $700 a month.
Wow.
So if you're okay with all that, then I'm not going to stop you from taking it. But I just want folks to know that we did this trial. We had a question after the ALS Untangled review, and we thought it was important enough to spend 3 years answering. And to my satisfaction, we've answered it. I don't think that Lunocin slows ALS progression.
Okay, thanks. Again, I've been speaking with Rick Bedlack from Duke.
Hey, everybody. I'm Dr. Richard Bedlack, professor of neurology and director of the Duke University ALS Clinic. I'm also in charge of education and outreach for the CREATE Consortium, which is part of the NIH-sponsored Rare Disease Clinical Research Network. CREATE is a clinical research consortium that's focused on therapy development for ALS and related disorders. CREATE tries to overcome some of the underlying barriers to therapy development with the goal of improving the success of future clinical trials. And today's podcast is part of a series we've developed to help non-scientists understand some of the work that our CREATE team is doing. I'm really pleased to be joined by my colleague, Dr. Nadia Sethi. Nadia is co-chair of the NEALS Patient Education and Advocacy Committee. She lost her husband to ALS in 2020. In this podcast, Nadia and I are going to interview the authors of the recent publication called The Miami Framework for ALS and Related Neurodegenerative Disorders, an integrated view of phenotype and biology. And we're joined today by Dr. Michael Benatar, who's been on previous episodes of this podcast. Dr. Benatar is also a professor of neurology, and he's chief of the neuromuscular division and executive director of the ALS Center at the University of Miami Miller School of Medicine. He's also the director of the CREATE Consortium. Nadia, I'll turn it over to you.
Thank you so much, Dr. Bedlak. So today we're going to be discussing the Miami framework. And Dr. Benatar, I noticed you defined this framework as a classification system. And as I was reading this paper, it felt like a new way to think about several disorders and how they're linked in their biology, their biomarkers, and also how they present or their phenotype. So am I getting that right?
Yeah, I think that's right. Traditionally as clinicians, we think about disorders clinically based on their phenotype, how they present, how they manifest. But the truth is disease invariably, and this is true of neurodegenerative disease too, reflects an underlying biology. And I think in medicine, we're always striving to understand that biology because it's that understanding that then drives treatment. And so part of what we were trying to do with this framework is to push our fields. And I say fields, ALS, frontotemporal dementia, other clinical communities, to think about the shared underlying biology of these diseases, and then to think about the phenotype that is sort of an emergent property or characteristic of that biology, and that may be varied. So in a sense, maybe we've always put the cart before the horse, and we're trying to put the horse before the cart in terms of thinking about how biology leads to phenotype.
And so since in gene carriers, we might be able to anticipate that ALS or FTD or some of these other syndromes may come on at some point, but in sporadic ALS, we don't know that. So will this framework be relevant only for genetic ALS, or will it apply to sporadic cases too?
Yeah, it's a great question. I think most of the evidence that we have that helps us think about this framework and construct it comes from what we've learned from studying genetic instances or cases or people with ALS and FTD who have an underlying genetic cause. But there are many reasons to think that this framework applies equally well to people with non-genetic forms of disease. And part of the reason for saying that is from what we understand of the biology of these diseases. The biology is mostly shared. So the biology is typically either TDP43 in FTD or tau, and in ALS, it's usually TDP43. So the biology is shared irrespective of whether you have an identifiable genetic cause for disease or not. And then we know that the phenotypic manifestations as ALS or FTD are the same. We can't tell when somebody has ALS or FTD if there's a genetic cause or not without testing. So there is a shared biology, there's a shared phenotype, and although the evidence is harder to acquire in non-genetic cases, we have every reason to believe that the same sort of theoretical, conceptual thinking applies.
Thank you for that. And so building on that, could you talk a little bit about how mild cognitive impairment or mild behavioral impairment might be a part of some cases of ALS? And then are there some cases of FTD with mild motor impairment too?
Yeah, I think we recognize this to some extent already. There are established criteria for thinking about mild cognitive or mild behavioral impairment in ALS. And we call those ALS-CI, ALS cognitive impairment, or ALS-BI, ALS behavioral impairment. And implicit to that thinking is the idea that a proportion of patients with ALS also develop FTD. But some patients develop cognitive or behavioral manifestations along a frontotemporal spectrum, but those are not severe enough or manifesting sufficiently that it's enough to call that FTD. So that's the idea of a mild cognitive or behavioral phenotype in people who have ALS. And we recognize that well in ALS, and I think the FTD community recognizes this too, although it hasn't been well formalized in their thinking, that people with FTD may develop ALS, but it's also the case that people with FTD may develop some motor manifestations that are not enough to call ALS, let's say an EMG abnormality, and we might then call that FTD-MI or FTD with motor impairment. That's not a term or an abbreviation that exists, but I think the concept is there.
And I think, again, building on that, Can you talk about the phenotypic continuum that you described? You shared some stages, clinically silent, prodromal, and then clinically manifest disease. So could you describe what those mean a little bit?
Yeah, and if you don't mind, I'm going to step back just a sec, just for the listeners who've not read the paper. The Miami framework recognizes three axes: a motor neuron axis, a frontotemporal axis, an extrapyramidal axis. And then within each of those axes, we recognize, as you've described, a continuum of disease or a continuum of phenotypic manifestation that may range from being clinically silent to prodromal to fully manifest. And if we think about a biological definition of disease, let's imagine that we're thinking about ALS as a TDP-43 proteinopathy. If there's the underlying TDP-43 pathology, but there's no outward clinical manifestation of that, we would regard that as clinically silent. If there's an outward manifestation of that leads to progressive weakness with upper and lower motor neuron dysfunction, we'd call that clinically manifest ALS. And if there's something in between, where people are not entirely healthy, they have some symptoms or there's some abnormalities on examination or EMG, but these are not enough to be comfortable that this represents ALS, then that's a prodromal stage of disease. And that's how I've described on the motor neuron axis. And you might think about something similar along the frontotemporal axis. You've got underlying TDP-43 pathology, no outward manifestation, you're clinically silent. If you have very prominent behaviors, apathy, disinhibition, and that's impairing your function, we might think about that as manifest FTD or behavioral variant FTD. But if there's some milder manifestations that family members notice or the individual notices, but which don't rise up to be of sufficient severity to declare FTD, then we might call that mild behavioral impairment. So I think it's recognizing that there's a continuum of phenotypic expression of an underlying biology. And implicit in this is that we recognize that the biology is a continuum and that the phenotype is a continuum. And when we make categories of clinically silent, prodromal, manifest, we're drawing somewhat artificial boundaries, but we think they're useful boundaries because they give us tractable concepts and ideas that we can talk about.
Yeah, Michael, I think this is fascinating and certainly it makes a lot of sense. But to me, I have a really hard time with this prodromal phase that you've described. It seems so nonspecific. I mean, all of us have good days and bad. Sometimes we twitch or get a cramp. Sometimes we feel tired. Our motor performance declines as we get older. I know I don't hit the golf ball as far as I did 2 years ago. I mean, given that it's so nonspecific, how can you be sure? How would a clinician use this? I mean, you talked about later in the paper that maybe we could make an earlier diagnosis if we recognize this, but do you really think someone would make an ALS diagnosis based on those vague symptoms and with no specific, EMG or exam findings? And do you think somebody would start disease with such vague symptoms?
So lots to unpack there. Those are great questions. So firstly, I think we would not suggest diagnoses of ALS based on prodromal symptoms. We might think about a prodromal diagnosis or designation. And maybe I can pull an example from sort of the existing medical literature that might be helpful. And I think the analogy to what's going on in the Alzheimer's world is helpful. So in the Alzheimer's world, there was a recognition many years ago by Ron Peterson and others that frank Alzheimer's disease clinically as a dementia is preceded by a stage of mild cognitive impairment or MCI, and specifically amnestic MCI. And it was recognition of that prodromal stage that has really pulled Alzheimer's trials back into early disease, where we're intervening in people earlier in the course of disease. But an important thing to say is that not everybody with amnestic MCI has Alzheimer's. And I think the idea of MMI, MCI, MBI, as we've described, is exactly what you say, Rick, that these are not specific. In fact, these are intentionally non-specific. But what we need are tools to help us understand the biology of that prodromal state. So going back to Alzheimer's, if you've got amnestic MCI, and you have evidence of amyloid pathology, then you are almost certainly prodromal for Alzheimer's. If you have amnestic MCI and you don't have amyloid pathology, you're probably not, and maybe that's just a manifestation of normal aging. And what we would like to see is getting to a future of somebody having, let's say, mild motor impairment, and also evidence of TDP-43 pathology, and we'd say, that person with MMI is truly prodromal because there's evidence of the underlying biology. But the person who has MMI but no evidence of that biology would say, we don't have to worry about emergent ALS. So by proposing these prodromal syndromes, we're trying to help us begin to wrap our heads around what the earlier stages of the disease clinically might look like. But we are absolutely not saying that this is always a precursor to clinically manifest disease. I hope that helps.
Yeah, excellent. Thank you.
I don't know if you have anything else to add, Dr. Benatar. I was going to ask exactly that, right? Can somebody kind of pause in that prodromal stage? And might that be some of the reason that we see genes that have incomplete penetrance?
It's a great question, and one that we actually didn't ponder too much in the paper. So just again, for the listeners of this, what penetrance is, it's the proportion of people who carry, let's say, a genetic abnormality who manifest the disease. But that requires us to define what we mean by manifest the disease. And typically, right, we think about that manifestation as a fully fledged clinical syndrome of ALS or FTD. And for a gene like C9orf72, we know that penetrance is incomplete. We know that estimates of penetrance are even more incomplete if you only ask about penetrance of ALS. And so if you really want to understand the penetrance, you've got to think about the emergence of ALS and FTD. I think, and you raise a very interesting question that we don't have a good answer to yet, is could some of these prodromal states represent a phenotypic manifestation? And maybe the penetrance of any clinical phenotype, prodromal, fully fledged, is actually higher. We just don't know that yet. And I think we're going to get to that point once we develop better biomarkers, better tools to tell us who has that underlying biology. But it's a great, great question.
Thank you for that. And then some of the diagnostic criteria we've seen in the past include the LS-Scorial and the Gold Coast criteria. And I've heard a lot of interest from the genetic ALS community around questions about diagnosis and the changes that the Miami framework will bring. So first of all, were members of the at-risk and ALS and FTD patient and caregiver community included in the development of this framework?
They were well represented at the workshop, and we heard their voices. And I think we agree. We feel the same way that our current thinking in the community around diagnostic paradigms maybe is insufficiently sensitive. And that's part of what we were trying to do. We were sort of recognizing the value of this newer approach of the Gold Coast criteria that simplifies LS-Scorial, but it also, because it perhaps underemphasizes the probability if you carry a genetic mutation that puts you at elevated risk. The Gold Coast criteria under-recognize perhaps that a manifestation, an early manifestation of disease likely represents the emergence of ALS. And so what we wanted to do really was, in a sense, I guess, wind back the clock and say, at least for carriers of pathogenic variants, we should be using the criteria that LS-Scorial has proposed, which would recognize in a carrier that weakness together with either upper motor neuron signs or lower motor neuron signs is sufficient for a diagnosis, whereas Gold Coast would require, irrespective of gene status, weakness with upper motor neuron and lower motor neuron. And it's precisely from our experience of following carriers and seeing the emergence of disease early that we think it's really important not to require both upper and lower, because we worry it will delay diagnosis, and as more genetic therapies emerge, it will delay therapeutic intervention. So we see value in both LS-Scorial and Gold Coast. We're trying to merge them a little bit and take the best of each.
That was a very thorough response. Thank you so much. So why is now the time for the Miami framework? Is the current research on genetics driving the need for more flexibility or a new I mean, this feels like a very new way to look at the spectrum of many diseases. So what's driven that change now?
Yeah, I think it's many things. I think one is, you're right, we're learning lots more about genetics, and carriers of pathogenic variants are being studied, and we're learning more. But one of the motivations for sort of thinking about this is, one, at some level, I think it seems obvious that we don't go from a state of being completely healthy to having fully fledged ALS or fully fledged dementia. That just, when you reflect on that, that just seems unlikely. It's a little bit like you don't go from a mutation in a single cell to having metastatic cancer overnight. The cell doubles and doubles and doubles, and the tumor grows, and eventually that becomes clinically manifest. If we're a viral infection, the virus is replicating, and eventually it reaches a threshold and a viral load that it produces a manifestation of disease. I think the nature of biology is that it's sort of continuous in this way. And so I think recognizing prodromal states at some level is a natural evolution in thinking about the evolution of these diseases. But it's also the case that we in the ALS world, and certainly FTD as well, have had this stubborn problem that we can't seem to improve upon of delayed diagnosis, an average of a year from symptom onset to diagnosis. And part of that is our way of thinking about the disease is we sort of wait for enough disease to emerge before we say, oh, that's ALS. And so we're never going to change that unless we come up with paradigms and ways of thinking that encourage us to think about what an earlier manifestation of disease would look like. So I think there are many factors that are driving this, but this is ultimately all driven towards the idea that therapeutic intervention is likely to be most successful if we intervene earlier. For those at risk, hopefully real prevention. For those in whom we don't know what their risk is, we still want to draw back that timeline for diagnosis and intervention.
Thank you for that. So if we can chat maybe a little bit about some of the biomarkers. So you talked a little bit about TDP-43. How does NFL fit into all of this? And, kind of what's the current status with respect to identification of markers for those at risk?
Yeah, so it's a great question. So firstly, one of the things we try to do in the Miami framework is to separate out the clinical phenotype, the clinical manifestations from the underlying biology. And the biology of most forms of ALS and FTD, as we've said before, are either TDP-43 or tau. There are some exceptions. SOD1 carriers have a different pathology. FUS carriers may have a different pathology. But for the most part, we have some sense of what that underlying pathology and biology is. One of our limitations is that we currently don't have the best tools in life to be able to measure those. One of our holy grails in ALS is to develop better biofluid markers in urine, in blood, in spinal fluid that tell us that there's TDP-43. So those are just beginning to emerge, but they're not yet all that robust, but we need to develop them. Those biomarkers, as we develop them, will tell us about the underlying pathology that's driving the disease. NFL is sort of a consequence of those drivers. NFL is a marker of neurodegeneration. NFL, for listeners, I think you know this, is neurofilament light. Neurofilaments are structural components of axons. When axons and nerve cells die, neurofilament is released. So that's a little bit of a downstream consequence of that earlier sort of upstream biology. We think about NFL as a marker of sort of neurodegeneration. And so we don't yet fully understand the temporal course of that neurofilament rise. We know it in some genotypes, but not all. We don't know that it's consistent in everybody. And that's part of why we suggest this decoupling, to be descriptive of what the clinical phenotype is, and then in parallel be descriptive about what we know about the biology. NFL is elevated or it's not. As we get these markers, there's evidence of TDP or there's not. Or there's evidence of tau, or there's not. And we hope that this, over time, will drive us towards an understanding of how we then integrate these two and understand how they're connected. But until we understand that better, we feel there's value in decoupling them.
That was extremely helpful. Thank you so much. And I want our listeners to have context before I dive into the next question on the biomarkers as well. So with respect to communicating a prodromal diagnosis, in the last 5 years that I've been in ALS, I've felt a strong shift in the whole community, from clinicians, people at risk, people living with the disease, to focus on getting genetic testing. And there's many more people who are now finding out their status, and in turn, people who may be at risk are learning that they're at risk. Friends that I have who are at risk worry about every little change that happens in their body. They worry about every twitch, every potential change. And, they're always thinking about, am I walking differently? Am I moving differently? All of those things. So I worry that, it is burdensome to carry information about your genetics. So I guess, are we sure that it's good to share this information back to people? And, what kind of actions can people take based on this knowledge? it's heavy information to carry. And so I wonder how clinicians are going to handle that as we move ahead.
It's a great question. And these are such important issues. And this is one of the reasons we devoted significant time at the workshop from which this framework emanated, talking about this. A few things to say. The one is to recognize everything that you say is true. This is a burden. The second thing to say is that I think this needs to be individualized. Not everybody is the same. There's some people who want more information and they find more information despite the burden is helpful. There are other people who prefer less information. And I certainly don't think that one size fits all. And I think this is where partnership with the potentially at risk and the carrier community is so important. That within every context, whether it's in the clinical context, in a research context, that we're having these discussions to understand what it is people want to know and people don't want to know. You know, when we first started studying carriers now 16, 17 years ago, and we set up our pre-FAL study, the pre-symptomatic familial ALS study, we purposefully set this up to be broadly inclusive, where we said people can participate if they come to us knowing they carry a gene, if they come to us wanting to learn whether or not they carry a gene, and if they come to us saying, I've got a family history, but I don't want to know, but I want to contribute to research. And so we designed the study to be inclusive of all of those perspectives and to give people the opportunity to change their minds over time about what they want to know and what they don't want to know. And I think as we move from that discussion around just disclosure of genetic information, and we begin to think about disclosure of non-genetic biomarkers at the neurofilament level or a clinical prodrome, I think there's a lot to learn from that genetic paradigm where we have to engage the at-risk community as individuals as well, right, within every context and say, what do you want to know? What don't you want to know? What are the limitations of what we understand and what this might mean? And I think those conversations are key to any consideration around disclosure. And I think we have to continue to update that thinking as our knowledge evolves and as people's thinking about this changes. I don't know, does that get at the question, at the concern?
Yeah, yes, it does. And I would agree. I think there are people out there who want to know as much information as possible, and there are some that really don't. And so I very much agree with your thoughts that it needs to be on an individual basis. But we're going into, I think, uncharted territory, neurodegenerative diseases.
I think we are absolutely. Just two other things that I was going to say. The one is, people worry when they're at risk about every twitch, every symptom. This is one of the values we found of people participating in a study like pre-FALS, is to have somebody they can call and talk to and get a gut check as to whether this is something I should worry about. If we're not sure, we'll say, come and visit. We'll take a closer look, and we can either reassure or help people confront a new reality of something that's emerged and give them knowledge and empower them to take whatever steps need to be taken. So I think there's value in being in a research study as you're confronting this risk. And as you may know, and this is currently under review, maybe we'll talk about it in a future podcast, we held a workshop a little under a year ago, again, very much motivated by the needs of the carrier community to explore how do we develop paradigms of clinical care for people who are at risk. Because I think you're right that there is a need for us to confront this and to help people shoulder this burden and figure out how to interpret symptoms and manifestations. And so I think that's part of the future state that we want to move towards.
Perfect. Thank you so much for adding all of that. And then, prevention is a dream that we all have. If we inform people that they're in prodromal stages, they might feel tempted to start treating early. And, I guess in some genetic mutations, we may have more options available and more info available than others. But is there a possibility of potentially inducing or triggering progression by treating early? And is that something that we should be thinking about?
It's a great question again. I think whenever we're doing something experimental with a therapeutic, and this is true if we're in an affected population or an at-risk population, it's an experiment, a clinical trial. We don't know whether something's going to help, whether something's going to hurt, or whether it's going to be neutral. And so that needs to be part of the informed consent process around the discussion of whatever that experimental therapeutic might be. And I know, and Dr. Bedlack's the world expert here, that our patient community experiments with a lot of off-label and alternative therapies. And I think for all of those things, we don't know the risks and the benefits. And so any experimentation around the use of something that's off-label, I think would need to be had in discussion with a treating clinician to help discuss what are the potential pros, what are the potential cons, what are the risks, what monitoring do we need to put in place. We always have to be cautious. And I think it's also important to recognize that when you're at risk and we don't know when manifest disease will emerge, that's a much longer horizon than there is for somebody who's already developed disease, who may say, I've got nothing to lose by trying something. This disease is going to progress notwithstanding. And maybe there is more to lose during the pre-symptomatic state. And maybe that's the reason why we need to tread extra cautiously and not rush into clinical trials or experimental therapeutics, which are not well understood in terms of their potential biological impact and what their safety profile looks like.
It sounds like the Miami framework will help us study all of these different stages, which will help us find the answers to that question, I think, too, in the long run.
I think that's right. I think we're very much hoping, this will just open up perhaps just a different way of thinking about these diseases. And we haven't spoken about this, but importantly, breaking down silos between them. Because when we talk about prevention, let's say the C9 carrier, we have to prevent not just ALS, we have to prevent FTD. And so we have to think about both of those diseases if we're thinking from a biology perspective, right? We're saying you've got a C9 mutation that carries with it a certain biology. You're at risk for both diseases. We can't think about just one half of that coin. We have to think about both. And so part of our hope is that this will draw traditionally different communities together to bring strengths of those communities together to drive forward this agenda of prevention.
And I think it's probably worth a mention. Within the paper, you had mentioned that, a clinical trial for C9, for example, might just be targeting FTD, but there could be ALS underlying there as well. So, currently our clinical trials potentially missing some symptoms, and that may be happening.
I think that's right. And that's another reason to bring the communities together, right? To a man with a hammer, everything is a nail, right? If you're an ALS doc, you only see ALS. If you're an FTD doc, you only see FTD. We need to get better at understanding the expertise of our sort of related disease communities so that we can think more broadly and think about how we mitigate all of the manifestations of a certain genetic state or pathology and not just one part of that.
Thank you so much. And what changes or additions do you anticipate to the framework moving ahead? Do you already have thoughts on that?
I do. We hinted this a little bit in the paper. I mean, I think we've described these three axes of motor neuron, frontotemporal, and extrapyramidal. But there may be other manifestations of the same biology that we don't yet understand well enough. So maybe we need to expand those number of axes in the future. That's one possibility. But I certainly think as we develop better biomarker tools of the underlying biology, we're going to want to better understand how to integrate those into the thinking about these different axes and their phenotypic expressions. So I think almost certainly as our biomarker tools evolve, we'll be able to update this framework and come closer to where I think our Alzheimer's colleagues and Parkinson's colleagues are in having really reached a perspective or a point of thinking about their diseases from a biological perspective and having that drive therapeutic thinking, rather than maybe sort of the last century view of thinking solely from a phenotypic perspective. So I think our understanding of biology will evolve, and I hope that we'll really sort of push forward into biological definitions of disease.
Thank you so much for today's discussion, Dr. Benatar. The Miami framework is poised to have a strong impact on care and development of treatments for multiple diseases, and I look forward to seeing how this framework evolves.
Great. Thanks so much for the interest and for the conversation today. Much appreciated.
Hi, I'm Ted Burns. I'm at the University of Virginia. I am again speaking with Richard Bedlack. Richard is an ALS specialist at Duke University. He heads up the ALS Untangled group. Let me again remind our listeners that this podcast is supported by the CREATE Consortium. And again, CREATE stands for Clinical Research in ALS and Related Disorders for Therapeutic Development. The major focus of CREATE is to advance the science that aids development of therapies for patients with ALS and related disorders. Today, we're going to talk about one of the ALS Untangled publications. This one is numbered 31, and it's about Protandim. Protandim is spelled Protandim. It is an oral tablet derived from 5 different plants. So, Rick, could you talk about Protandim and how it might reduce oxidative stress and why that might be a good thing?
Sure, Ted. Yeah, as you mentioned, Protandim is a tablet, and it's made up of 5 different plants. And it appears to activate an intracellular molecule, which is called NRF2. That stands for nuclear factor erythroid 2 related factor. Once activated, NRF2 binds to another molecule, which is called ARE, antioxidant response element, and then that increases the expression of more than 200 antioxidant and anti-inflammatory genes. As you and I have talked about several times now, there's quite a bit of evidence that oxidative stress and neuroinflammation are damaging motor neurons in the brains and spinal cords of people with ALS. By reducing these, Protandim might be able to slow the progression of this disease.
Okay, and is Protandim something that is produced and marketed by many companies, or is it a product owned by one company?
Protandim is patented and sold by a company called LifeVantage.
Okay, so one company has it and has patented it. All right, so is there any evidence in humans without disease that Protandim activates this NRF2 pathway and reduces oxidative stress?
So, Ted, at the time of our ALS Untangled publication, there was one small study showing that Protandim could upregulate antioxidant biomarkers and decrease markers of oxidative stress in the blood of healthy volunteers. Since then, I found out about 3 other studies, one in alcoholics, one in runners, and one in healthy older adults. Unfortunately, none of these studies were able to show effects on blood markers of oxidative stress.
Okay, so that might be disappointing. How about preclinical data for Protandim in the ALS animal model?
We didn't find any preclinical studies of Protandim in any ALS models, but we did find several flawed studies of other NRF2 activating compounds. And in these studies, those compounds slowed progression in SOD1 mouse models.
Okay, Rick, so are there any human trials of Protandim for patients with ALS?
I don't know of any, Ted.
Okay, and what's the online community reporting?
So we found multiple reports of people claiming their ALS improved on Protandim in one way or another, but as with Lunacin, we were only able to confirm one of these. This was a young man whose record suggested he really did have ALS and was progressing, though slowly, before starting Protandim. Since starting Protandim, his ALS FRSR scores actually improved. In fact, they went up by at least 6 points. And again, this amount of recovery of significant loss function in a person with ALS, what I call an ALS reversal, it's very unusual. And I think this alone warrants further study.
Okay, but it was only one individual.
Correct.
Yeah, and you may have mentioned this, but how many people have reported online their experience with Protandim?
I don't have an actual number, but it is a fair number of folks who, reported to me that they noticed something improving when they started this. It's just that I've only been able to validate the one.
Oh, got it. All right, and so how's it being dosed?
It's usually dosed at 1 tablet, which is 675 milligrams daily. But it's not clear that we know what the optimum dose, if any, is for reducing markers of oxidative stress. It's possible that less Protandim might work just as well. It's possible that more might work even better. Studies haven't been done.
Are you aware of studies that might be done in the near future?
I'm not.
All right. What about risk and tolerability?
So this product seems to be very well tolerated and pretty safe. We didn't find anybody having any serious adverse events with it, like deaths or hospitalizations. We did find very rare reports of loose stools and rashes, which appear to occur in less than 1% of everybody who's taking this.
Okay, so pretty well tolerated. What about cost?
Again, it's not very expensive. So at a dose of 1 tablet per day, the cost is $40 to $50 a month.
Okay. So could you summarize what you recommend to patients or what ALS Untangled might recommend to patients and loved ones when they ask about Protandim?
Yeah, so for me, this is right up there with coconut oil. For those who are going to self-experiment anyway, this is one I often mention. I talk about the fact that it has a reasonable mechanism, the fact that other NRF2 activators did good things in animal models, the fact that there's a person with a validated ALS reversal that occurred on this, and the fact that there's a pretty reasonable cost and side effect profile. I do always mention that the only way we know for sure whether something works or is even absolutely safe is when somebody does a trial. But, there's going to be folks who are going to self-experiment, and I think this is something reasonable for them to try. And I just remind folks, if they're going to do that, be sure to create a profile on patients like me and follow their outcome measures so we can all know what happens.
And right now, the company recommends a dose of 1 tablet a day.
Correct.
And I guess we know nothing about 2 tablets a day.
I do not. There may have been studies, but I do not know what the results were.
Okay, so stay tuned. More to learn, I hope, about this. Any final comments, Rick?
Well, Ted, I'll just say that this is on my own personal list for a future trial. And again, I'm going to try to make that a very patient-centric trial like I did with Lunison and like I'm going to do with curcumin. I don't know when I'll get to this one, but it is something I want to study.
Okay, great. And Rick, quickly remind our listeners how to find the manuscript online for this and also other alternative treatments.
Ted, our website is www.alsuntangled.org, and this manuscript and many others can be read for free on the completed review section of this website.
Yes, great. Again, I've been speaking with Richard Bedlack from Duke University.
Hello, everyone. I'm Dr. Rick Bedlack, professor of neurology and director of the Duke ALS Clinic. I'm also in charge of education and outreach for the CREATE Consortium. This is part of the NIH-sponsored Rare Disease Clinical Research Network. CREATE is a research consortium that's focused on therapy development for ALS and related disorders. CREATE aims to help overcome some of the underlying barriers to therapy development with the goal of improving the success of future clinical trials. Today's podcast is part of a series we developed to help non-scientists understand some of the work that our CREATE team is doing. And once again, I'm thrilled to be joined by Dr. Nadia Sethi. Nadia is co-chair of the NEALS Northeast ALS Consortium Patient Education and Advocacy Committee. She lost her husband to ALS in 2020. In this podcast, Nadia and I are going to discuss the recent publication, Genetic Associations with an Amyotrophic Lateral Sclerosis Reversal Phenotype. And we're especially grateful to be joined today by Dr. Jesse Crail, Clinical Neuromuscular Fellow in the Department of Neurology at Washington University in St. Louis, and Dr. Evadne Rampersad, Principal Bioinformatics Research Scientist at St. Jude's Children's Research Hospital. Nadia, I'll turn it over to you.
Thank you so much, Dr. Bedlack. I'm very excited to talk about this interesting topic today. So to get started, I would love to hear about your study of ALS reversals, Dr. Bedlack. Can you tell us about these? What prompted you to study them? And how long have you been studying this phenomenon? What does it look like clinically?
Well, thanks, Nadia. Yeah, so when I started my career, I had no idea that something like an ALS reversal could occur. You may know that I run a program called ALS Untangled, which takes ideas from people living with ALS, things that they might be considering buying and trying that are advertised on the internet. And, we conduct scientific reviews of these things with the goal of trying to help people living with ALS to make more informed decisions about these things. And so it was probably sometime around 2010 when an idea came in for me to look at the website of an energy healer by the name of Dean Kraft. And in particular, what seemed compelling about this website was a video that was on there of a person who claimed that she had been diagnosed with ALS at the University of Virginia, progressed to where she was disabled, paralyzed, nearly dead, specifically said she was picking out the outfit that she wanted to be buried in. And then over the next couple of years, under the care of Dr. Dean Kraft, recovered seemingly all of her lost motor function. And of course, I had never seen anything like that before. I thought it couldn't possibly be true. Well, long story short, it was. I found her. I talked to her on the phone. She sent me her medical records. And then I was left with, how do I explain this? What do I do next? And my first thought was maybe I should study Dean Kraft's energy healing, even though I didn't really understand, how that could happen, like the scientific plausibility of it. But that turned out to be impossible. Dean Kraft did not want to be studied. But ALS Untangled is very collaborative. And this case was discussed amongst, over 100 different clinicians and scientists living in 11 different countries. And what I learned from that is that this phenomenon has been described in the literature dating all the way back to the 1960s. there appear to be these patients who meet diagnostic criteria for ALS, progress to where they're disabled, and then recover a significant proportion of their lost motor function. And so my mind was blown by this conversation because, again, I had never heard of this. The journals where these things were reported were not journals that I routinely read. And so I thought to myself, if this happens even rarely, there might be a clue in these patients. There might be a clue to something that I could give the rest of my patients to maybe make this happen more often. And so I decided to start 2 programs, one called STAR, Study of ALS Reversals. And in that program, we would look for something that was intrinsic to these people, maybe some exposure that they had or something in their gut microbiome or something in their genes that might have allowed them to recover from ALS no matter what they did. And then the other program was called ROAR, Replication of ALS Reversals. And this would be a series of small pilot trials of treatments that were associated with ALS reversals. And so we've been working on both of these now for over a decade. And I would say that this paper describes the most significant thing that we found.
Thank you so much for that. And just a little more on reversals. Do you see people living with ALS that might have a plateau or regain function temporarily? And how do you distinguish that from a reversal as you define it?
Yeah, great question. So somebody whose progression seems to stop for a while is what I would call a plateau. And I think plateaus are pretty common in ALS. In fact, long before I started to study ALS reversals, I'd been seeing plateaus in my own clinic that wound up leading to an analysis of something called the PROACT database, where we showed that ALS plateaus, at least as defined by the ALS functional rating scale, were really quite common, especially those that only lasted a few months. But I believe there are patients who have plateaus that last for years or even indefinitely. And I think that is all much more common than a reversal. So the difference between a plateau and a reversal, in both cases, patients meet diagnostic criteria for ALS. They have the right story, the right exam, the right EMG, a reasonable set of tests for ALS mimics. In both cases, they progress to where they're disabled from the disease. But a plateau is someone who sort of stabilizes there and doesn't get any worse for some period of time. A reversal has to have a dramatic and sustained improvement in lost motor function. So I now know of 61 people throughout the history of the world who meet that 3-part definition. In other words, they have the right story, they have the right exam, the right EMG, the right test for mimics. That's criteria number 1. Criteria number 2 is they have to progress to where they're disabled. And then criteria 3 is they have to recover a dramatic amount of their lost motor function, and that's got to be sustained. So that's the difference.
Thank you so much for clarifying that. All right, so let's jump into our content then. Dr. Krill, Dr. Ramprasad, just feel free to jump in on these questions as they apply to you. Can you all tell us what a GWAS or genome-wide association study is and what its purpose is?
Yeah, sure, Nadia. So basically, simply put, a GWAS is just a way to scan the genome of individuals that either have a disease or trait. In this case, it would be the ALS reversals, and to compare that genomic sequence to other individuals who don't have that trait. And what we're essentially trying to do is just identify regions of the genome where maybe the people that have the disease or all the people that have ALS reversals may share something in common, a genetic region in common, maybe a background of genetic variation in common compared to, in our case, people that had ALS but didn't reverse the ALS symptoms. And then what we do is we use statistical methods to hone in on those regions. And then we basically try to identify genes within the regions and to determine whether any of those genes may potentially be related at the biological level with the trait under study.
Great. And then can you tell us a little bit about the genomic study that you conducted for this research? What data sets you looked at? And did you know what you were looking for? It doesn't sound like it. And who was included in this?
Yeah, I think I'm going to punt this to Rick and Jesse because really it was their idea coming to create, to work with us to perform genomic studies on this really interesting cohort. So, Rick's already described the ALS reversal data set. I can describe a little bit about the CREATE PGB data set, which was used as the quote unquote pseudo control cohort. And the idea at the time was for us to determine, looking at ALS reversal patients against controls, people that never had ALS, wouldn't really be the point. the point would be to try to compare ALS to ALS. So ALS patients who somehow reversed to ALS patients who didn't. So we worked with CREATE. We're investigators as well with the CREATE PGB project. And we used those cohorts that were matched. Those individuals were matched by ethnicity to the ALS reversal patients. And then we used another cohort, Target ALS, which you're probably familiar with, as the secondary control cohort. Of course, and we'll talk about this later, we only had a few patients who fit the ALS reversals. Just by definition, it's like a really extreme phenotype, and that's how we considered it. So we didn't really know what we would find, but we knew that this was really highly unusual and highly likely to have something potentially at the genomic level that could be responsible and differentiate from the other ALS patients. And Rick and Jesse can chime in as well.
Yeah, I think Maddie said it really well. This study really was looking at ALS reversals and trying to compare them to patients that have typically progressive ALS and trying to find any genetic factors. Why do these very rare patients of ALS get better and other patients of ALS don't? The majority continue to progress. And that was really the point of our study. And, when we looked at it, we found two regions that looked like they were different between the patients with ALS reversals and the patients of typically progressive ALS. There was one of those regions that we focused on because it's actually been studied in the ALS world before, and there's been clinical trials around this particular mechanism. So what we found is a single nucleotide polymorphism, that is a single letter change in the genome near a gene called IGF-BP7. So IGF-BP7, it makes a protein. And this protein, there's been back and forth over the years. What does this protein really do on a molecular level? But the general consensus is it blocks the IGF-1 pathway. So IGF-BP7 blocks the IGF-1 pathway. Now, why do we care about this? There's been prior data and consistent thought through the years that IGF-1 might be protective for motor neurons. We know that motor neurons are the cells that are dying in ALS, and we want to protect them the best we can. So this was really exciting for us. We took some, Vanny, I don't know if you want to talk about some of the MetaBrain stuff right here, and I'll stop and let you take over.
Sure. So as Jesse mentioned, we did have this really interesting finding, which was based on a region that popped up that was unexpected. But excitedly, we realized that it had been studied in the past, which lent us some confidence about maybe investigating a little bit more. And what's really neat is that, like 10 years ago, maybe we wouldn't have been able to really move forward beyond just saying, oh, this is an interesting region. But what we have now through the really great collaborative work of many, many researchers and clinical scientists and patients are these multi-omics data sets. So we have tissue from brains of patients, who have and don't have ALS. We have what's called ATAC-seq data. And not to get into the nitty-gritty details, but basically what that allows us to do, which is fairly novel, is to say, this SNP doesn't exist, for example, in the coding region of a gene. So it doesn't actually change the protein of IGF-BP7. But what it does is it resides close enough to that gene that it's pretty close to the promoter region. And we know that SNPs, or single nucleotide polymorphisms, can impact the expression of nearby genes by being part of the promoter. And by using the ATAC-seq data, we were able to show that there is a linkage of that SNP to that gene. And that's all data that was independently identified in the public data sets, and for which our collaborators have just generously provided. That's the beauty of public data resources, right? We're able to mine all these data to really help us to feel a little bit more confident about the finding. We recognize the issues that could be present in such an intense and an important question, and population that we're looking at. But that's why we really tried to scrape every bit of information that we could in order to support this finding for other people to look into and prove or disprove, as it goes in science.
So this SNP was not in a coding region of the gene. Is that right? That's what you're saying. Yeah. Okay. And was that information you're referencing, some of these public databases, was that specific to ALS, or are those databases that might be used for lots of different types of research?
Oh, yeah, that's a great question. So one of the data sets that we used is called the MetaBrain. It's a MetaBrain consortium data set. And it's basically encompasses tissue specific data from lots of different neurological disorders as well as some controls. And that data is actually looking at the transcriptome, so the expression levels of the genes within that tissue. So to your point, if I understand correctly, the data is actually available such that other investigators for other, horrible disorders and diseases could maybe like mine that data as well.
Very interesting. Okay. So you've identified this single nucleotide variant in IGFBP7. So what are the next steps from there in understanding whether or not there's an impact in ALS from this? What happens next?
Well, I can tell you what I would like to see, and then maybe we can hear from Jesse and Avadni. I mean, if this is meaningful, then there should be some relationship between the amount of IGF-BP7 that someone has and how fast they progress. Like, if our theory is right, that these people might have recovered because they have this SNP that drastically reduces how much IGF-BP7 they have, so therefore they get a form of ALS that they can recover from. Well, it shouldn't just be these patients. It should be maybe present to a lesser degree in a large data set of people who didn't recover from ALS. And so that's work that we have underway right now with some collaborators at the ALS Therapy Development Institute. We're looking for a relationship between how much of the protein is expressed and how fast people progress.
And I'll just go ahead and add. So interestingly, people have actually done some work looking at IGF-BP7 and ALS before. There's been some cell models of ALS in which it seemed that the amount of IGF-BP7 was increased in these cell models relative to normal cells. Now, we don't know if that's necessarily a bad change or if that was a protective change, but it is certainly very curious. There hasn't been any studies in the ALS space trying to see if knocking down this IGF-BP7 could help ALS. However, in another neurodegenerative disorder, Alzheimer's disease, there has. So there was actually a study published with a mouse model of Alzheimer's disease. They took a look in the hippocampus, which is the main brain region that's degenerating in Alzheimer's disease, much the same as the motor neurons are degenerating in ALS. What they found in this mouse model is that IGF-BP7 was increased in the hippocampus. They tried to inject the mouse hippocampus with an antibody against IGF-BP7 to decrease the amount of IGF-BP7. And what they found was the mouse thinking and cognition actually improved. They took another cohort of the mice, and instead of injecting something to decrease the IGF-BP7, they actually added extra IGF-BP7 protein into the hippocampus. And in this group, they actually found that the thinking got worse. So this is very exciting. It suggests that perhaps what we found here may even be beneficial in other neurodegenerative diseases too. And of course, this is very exploratory, but it is very curious.
I'll add just one more thing, and Avadni, feel free to chime in on this. But, one of the many brilliant things that Avadni and her team brought to this that I would have never thought of is the importance of matching your controls for race and ethnicity. We wanted to try to reduce as much of the genetic noise that might be present in these two groups as we could and focus on genes that might actually be involved in whether you get the disease or not. And so that's part of why we found what we did. This SNP that we found is quite unusual in Caucasians with typically progressive ALS. So what's really interesting to me, the more I've read about this, if you look at other races, like people who have non-European ancestry, for example, East African or East Asian populations, the same SNP is actually much more common. And it makes me wonder, is that one of the reasons why we don't see nearly as much ALS in these populations as we do in Caucasians? Maybe this is a SNP that's protective against getting ALS in the first place. And I've never actually heard anyone postulate an explanation for why there seems to be this racial imbalance in who gets ALS.
I can chime in on that. Actually, Rick, you're going exactly where I wanted to go as well. In 8% of white Europeans in a general population, Nadia, the SNP allele, the rare allele, is present at this SNP. And in the non-reversal patients for ALS, which we tested, it was present 3% to 9%. So basically in line with what you would see in white European patients with ALS or without ALS. What we found is that 26% of the patients with ALS reversal carried that allele, which is a huge difference compared to the patients that were not ALS reversal patients. And as Rick pointed out, if you look in the general population, and of course, we don't have any neurological data, but if you have ALS, you would have been diagnosed, I would think. I don't know about endophenotypes or less severe symptomology. If you look at African and East Asians, that allele is occurring at 35%. So clearly from a population genetics standpoint and from a public health standpoint and from an etiological standpoint, it would be really interesting, as Rick alluded to really try to understand why that is. Why is it enriched and perhaps protective in those populations? And what percentage of African ancestry contributes to like that allele being present as opposed to like in the European population?
Absolutely fascinating. I always thought maybe we're not counting correctly in global populations, but yeah, which also could be. But this is very interesting finding. That's definitely worth studying further. And what would be next steps then in finding potential drugs that might intervene in this pathway?
Well, I know what I've been doing. I mean, I've again brought in my more senior colleagues in the ALS Untangled world and asked, have they ever seen a study? And of course, I've gotten a couple of hits on that. So there actually are a couple of, one is a supplement, one is a drug that are out there that for different reasons looked at the expression of IGF-BP7. Again, these were studies of a supplement or a drug for a completely different condition where IGF-BP7 was just one of many things they looked at. But in both cases, there was a significant reduction in the expression of IGF-BP7. Now, I do want to just take a step back, though, and say, I don't really think we're at the point now where people should be getting their genome checked for IGF-BP7 or for the SNP that we found. I don't feel like we're at the point where people should be taking supplements or drugs to try to knock down IGF-BP7 expression, because this is just one finding in a very, very small number of people. I mean, I feel like we need that data from TDI to tell us that we're on the right track before we start doing things like that. If that's completely negative and there's no relationship at all, we're going to have to go back to the drawing board. And the other thing is, we don't really know what the downstream consequences could be of significantly knocking down IGF-BP7 expression. IGF-BP7 is actually a tumor suppressor protein as well. And so, you always have to wonder, like when you start doing things, what are the pros and cons? And I don't think we know either side of that equation right now for people with ALS. So I would say, I know it's exciting, but I think we need a little bit more time to fully understand this, to fully understand whether it might be meaningful to try to manipulate this as a target.
I think that was very helpful. That was actually my next question was, is there anything clinically actionable for people now based on your findings? And it sounds like we still have a little to learn before we get there.
Yeah, I would say no, not today, but hopefully soon we'll have more follow-up data where we can use that to try to guide people.
Perfect. And were any of the reversals in this study carriers of genetic mutations known to cause ALS or other movement disorders?
Yes, there was. One of the patients in our study had a pathogenic mutation in a protein called sequestosome 1. This particular mutation is well defined as causing ALS as well as some other occasional distal myopathies that don't improve. So this is a really exciting finding. This suggests that this patient definitely had a genetic predisposition to develop ALS, but there was something else in the genetic background that allowed them to get better. And kind of speaking to what Rick was saying, this is really just the beginning. It's worth mentioning that a lot of the patients in our study didn't have this single nucleotide polymorphism that we found, even though it's such a strong finding that we did find it compared to the control group. So why did those other people get better? We still don't know. So there's definitely more work to be done. Perhaps, it's a mixture of genes or something in their environment. We're just not sure.
Yeah, I've been thinking about that too, Jesse. I think it's a great point. And, again, this is early days. It's just kind of fun to speculate on things, but there may be epigenetic ways to knock down IGF-BP7. And so even though you might not have the SNP that does it naturally, perhaps some of these people had an exposure or took something that knocked their IGF-BP7 levels down to where they could recover. And again, this is all very speculative, but it's just the thought on how it all might connect.
And that actually reminds me of something that Dr. Rampersad, I think, brought up earlier, that she said there was 2 regions of interest that were found, and one was IGF-BP7. And so what's going on with the other at this point?
Yeah, so I think it was Jesse who mentioned that. But indeed, typically when you do a GWAS, especially with such small numbers, you're going to get several regions that may or may not be real, right? And so there were other regions that showed up that we are going to explore a little bit more. This just seemed like the obvious one to pursue because of the significance, but also because of the additional evidence that I mentioned before. So it's a little bit of a conundrum as to why, and if this isn't the only disorder that that's the case for, as to why only a subset of the patients have that particular genetic polymorphism. And that's something that I'm really interested in. I think there probably are, as Rick mentioned, other ways of affecting that pathway that are not as obvious from this particular screen, but will come to light later on.
Thank you. Okay. And what might be some of the weaknesses of this study?
Well, I would say the biggest weakness is the small sample size. And there's just no getting around it. I mean, I wish ALS reversals were much more common. I hope someday they will be. But, to have a phenotype where there's only 61 examples in the known history of the world, it's a pretty small sample size. And as we know, unfortunately, not everyone was contactable. Some of these folks were, cases that were in the literature from 60 years ago. So who knows where that person who was written up in that case report is. Not everybody was able to send us a sample that we could genotype. And so it's really, Jesse rolled up his sleeves and did a lot of hard work to try to contact as many of these known reversals as he could and get samples from them and get the samples to the right people who could do the analyses for us. But there's no getting around the small sample size. It's just a fact of life with this group. And you'd like to be able to find another sample of ALS reversals and, repeat this again. That would be a true replication. But the way that we tried to get around that, because we don't have another sample of reversals, is to use 2 different control groups and make sure that the issue was really with the reversals and not with the control group that we chose. I feel like that's one of the strengths of the study, is that, the association held up even with 2 completely different sets of controls.
Perfect. Anything else that I missed or that anyone would like to add?
I think you asked a lot of great questions as usual, and I'm really looking forward to seeing, what happens with this ALS TDI study. And we'll hopefully get something else published on it one way or the other and do a follow-up podcast about this.
I'm looking forward to those results too. And either way, we will have learned something new. So that's fantastic. Okay, everyone. Well, thank you so much for your time today. And thanks for sharing about this interesting finding. Looking forward to this podcast going out so people can hear about it.
Thank you, everyone.
Thank you. Thank you.
Hi, I'm Ted Burns. I'm a neuromuscular specialist at the University of Virginia. And again, I'm talking with Richard Bedlack. Richard is an ALS specialist at Duke University, and he heads up the ALS Untangled group. This podcast is again supported by the CREATE Consortium. CREATE stands for Clinical Research in ALS and Related Disorders for Therapeutic Development. The major focus is to advance the science that aids development of therapies. The CREATE Consortium is currently made up of 15 clinical sites on 3 continents, as well as many other U.S. and international scientists and collaborators. And this consortium is part of the NIH Rare Diseases Clinical Research Network. Today, we're going to discuss the ALS Untangled publication on the DEANA protocol. DEANA is DEANNA. And this is publication number 20 for the ALS Untangled group. So, Rick, let's start by having you give us some background on this protocol, including why it's called the DEANA protocol.
Sure, Ted. Let me start by saying that this is not only our most popular review ever, but with 30,000 downloads, it is the #1 most downloaded article in the history of the journal ALS and Frontotemporal Degeneration. The protocol was invented by a retired orthopedic surgeon named Dr. Tadone. It is apparently the result of his own literature review, which was motivated by a desire to help his daughter, Deanna, whom he reports was diagnosed with ALS. Deanna's progression is said to have slowed on this protocol, but we have never been able to get records to confirm Deanna's ALS diagnosis, nor her progression rate before and during the use of this protocol.
Okay. Now, the ALS Untangled Review article includes a table of close to 20 supplements that make up this protocol. And it appears that these supplements are all commercially available. And it looks like all but one are taken by mouth, but one is IV administration. And we can talk about that in a bit. I must say, as an ALS doctor myself, I really struggle with what to tell patients about protocols that lack evidence of benefit and are also quite extensive, complicated, and costly, such as this complete Deanna protocol. So I'm hoping we can deconstruct this one a bit during our conversation. And before we do, is there any clinical evidence for the complete protocol?
Well, Ted, the table that you're referring to showed what the Deanna protocol looked like at the time of our 2013 publication. At that time, there were no clinical trials of this regimen. We only had anecdotal reports like that of Deanna, and we did not have any medical records to substantiate these. In the article, I talked about some patients from my own clinic that I saw try this protocol and the fact that I didn't see any obvious change in their progression rate on it. This protocol has evolved since then. It's unclear to me how or why this evolution occurred. Thankfully, I can say that it's at least shorter now. The website www.winningthefight.org lists the following 6 ingredients as, quote, Deanna protocol essentials. These are AAKG, which stands for arginine alpha ketoglutarate, AKG, which stands for alpha ketoglutarate, 5-HT, which stands for 5-hydroxytryptophan, niacin, GABA, and CoQ10. Additionally, the website lists 4 other optional parts of what they call the WFND, Winning the Fight Against Neurodegenerative Disease program. These are glutathione, exercise, massage with virgin coconut oil, and oxaloacetate. Now, in terms of effectiveness, the website claims there are more than 4,000 people on some or all of this. It has testimonials on there from 26 people who say they have ALS and say the protocol is helping them. We have no records to validate any of these anecdotes. There was a previous publication that claimed a success rate of, quote, 85% on the Deanna protocol. And you might ask, how did they come up with this since there's never been a formal trial? What they did is look at serial ALS FRSR scores that were submitted by 41 people who said they had ALS and said they were taking the Deanna protocol. They noted that the average rate of ALS FRSR progression in all people with ALS is about a point per month. Since 35 of the 41 people that they report on had a progression rate of less than that, they concluded that this protocol was working to slow ALS in 85%. Now, Ted, as a physician and scientist, I'm sure you can see the flaws in this. We don't know for certain who these 41 folks were. We don't know what their diagnosis was. We don't know what their progression rate was like before the Deanna protocol. And plus, there's probably a selection bias here. People who do well on something are much more likely to want to talk about it and much more likely to keep sending in serial scores than people who don't notice any benefits. I can't help but wonder what happened to the other 3,960 people that the website says were taking this.
Right. And what's patients like me reporting? Do you know?
I don't know. It's a good question. I haven't been on there recently to look at what people are saying about the Deanna protocol.
Okay. And do we know if this was the Deanna protocol light with the 6 supplements or the 9 or 10 supplements? What do we know about that in terms of the testimonials, the reports that you mentioned?
I don't know. It's not stated to my knowledge in the publication what exact version of this protocol these folks were on.
Okay. And as I'm listening to you, you don't, I don't know how to put it. You wish that there was maybe more data that was forthcoming on these patients. And I don't know, could you comment on that?
Well, it's certainly nice to see that there's some data being reported, but that type of analysis is so flawed to me that it's uninterpretable. At the very least, we need to know how people were progressing on this score before they started the protocol, what exact protocol they were taking, and what their progression rate was like on the protocol. We can't just have a series of scores. And it could be that these folks were all super slow progressors in the first place.
Mm-hmm. Right, of course. Okay, so let's focus on some of the supplements found in the Deanna protocol. And I'm going to let you pick a couple. I don't know if you want to focus on the most compelling 6 or the 10 or all 19 or 20, but could you single some out and talk about them?
Sure, Ted. You and I have talked many times before about the potential importance of oxidative stress and also impaired energy production in the biology of ALS. And several of the things in the Deanna protocol are purported to address those mechanisms. For example, glutathione, that's an antioxidant. AAKG, AKG, CoQ10, and coconut oil are all supposed to help with impaired cellular energy production. But remember, all this is theoretical. We don't even know at this point if these products at their recommended dosages can alter biological mechanisms in people with ALS, much less slow the progression of their disease.
Yeah. Okay. And you mentioned glutathione, and I thought that was IV in the original protocol.
Yeah, so I'm looking at, the very latest description, and this is not part of the Deanna protocol now per se, but it is included in the, let's see, how did they phrase this? The WFND program for ALS. So it's outside the protocol, but it is part of that program, and it doesn't specify how it should be taken. It says they suggest 3,000 milligrams of glutathione IV once a week, but it also does say that there's other ways that this can be dosed: suppository, liposomal, sustained release. So again, it's just not clear, first of all, not clear whether glutathione itself, well, it's definitely an antioxidant. It's not clear that it really, in any dose or form, can help a person with ALS. This is one of the few things in the protocol where there actually was a randomized clinical trial at one point. So years ago, somebody did a trial of glutathione at a dose of 600 milligrams IM daily and found no evidence that it altered ALS progression using carefully measured objective outcome measures. We do have a future ALS Untangled review that we're going to do on glutathione, but in the meantime, that's what I can tell you about it.
Okay, so Rick, if I am a patient with ALS or the loved one of a patient with ALS, and I ask you to cherry pick for me some of the supplements that are part of the Deanna protocol, how would you respond?
Ted, I would say this is a rather complicated and expensive regimen, which has no more proof that it helps people with ALS than several other simpler things that ALS Untangled has reviewed. So for patients who want to self-experiment, I usually suggest starting with one simple thing at a time and seeing how it affects the way they feel and how they progress over a few months. So some folks are really interested in attacking oxidative stress. For them, I might suggest curcumin or Protandim. Some are very interested in trying to attack this mechanism of cellular energy production. For them, I suggest coconut oil. Again, until all these things are carefully studied in ALS trials, all this is theoretical.
Okay, fair enough. Now, your publication mentions that Emory priced the most important supplements from the Deanna protocol at about $150 to $200 per month, whereas the entire protocol was estimated to cost somewhere around $400 per month. I don't know, Rick, do you know if that $150 was for what is now the 6 or 10 most promoted supplements of the protocol? Do you have any comment about that?
I don't, because it's changed since then. So I haven't priced out the latest version of the Deanna protocol, but I can say there's really no way to know if any of these individual ingredients or any combination of these things are any good without a clinical trial. I mean, even the proponents of the Deanna protocol are now calling some parts of their protocol essential, but it's not clear why. I mean, there hasn't been a trial of any individual items, much less any combinations of things. And so until you actually do trials, I don't know how you decide what's essential and what's not scientifically.
Right. Okay. Anything you want to single out that has been studied and not found to be efficacious or not found to be safe?
It's a great question, Ted. So, I mean, in addition to what we already talked about regarding glutathione, which had a negative trial, there's also CoQ10. And this is something that I very commonly see my patients on as part of a cocktail. And what I tell them is, a lot of these things we don't know. But CoQ10, we actually already studied it. It wasn't that long ago. We did a well-designed trial in people with ALS, and we found it was no better than placebo. So to me, it doesn't make much sense to take things that we've already studied and found to have no benefit.
Okay. Do you remember the dose of that CoQ10 trial?
Unfortunately, I don't. I'd have to look it up.
Okay. But you don't think dosing is an issue. Should CoQ10 be studied again, or should we be moving on?
I personally think we should move on. I mean, we've got, how many different things have just you and I talked about that we want to study.
Right. Okay. Fair enough. Any special comments about risk and tolerability of any of these supplements or the entire protocol?
Well, the good news is we didn't find any evidence of any serious adverse events associated with this protocol. And in fact, adverse events of any kind appear to be pretty rare, affecting less than 10% of those who take it. The most common adverse events are gastrointestinal in nature.
Okay. Anything else you want to say about this protocol?
To me, Ted, this is fascinating that it's our most read ALS Untangled review. This would not be on my own personal top 10 list of the most promising things that we've looked at in the past 9 years. And I think this shows the power of anecdotes. The stories of the folks on the website reporting positive experiences are very appealing to patients, even to the point of trumping a lack of good scientific evidence. And I would just encourage patients listening to this podcast to be careful in general with anecdotal data. When any of us read stories on the internet, very often we don't know for sure who these folks are, whether they really had ALS, whether anything important got objectively better. I'm not saying we should just ignore anecdotes. If I did that, I wouldn't even know about the ALS reversals that have become a huge part of my own research. But we need to at least try to validate anecdotes by getting their medical records, confirming their diagnosis, confirming their improvements. And once we've done that, we can use these as a model. We should take the anecdote and try to confirm what happened using a well-designed clinical trial like I did with Lunacin.
Okay, let's take that a step further. So let's say I came to you and I'm either a patient or a loved one. And I said, I found, 20 different testimonials for 20 different supplements, and I'm trying to figure out what one or two I want to use. Would you suggest we go to patients like me and do some research? I mean, of course, there's ALS Untangled. That's a lot to review. It's a great website, and you guys have done a great job. But as a patient or a loved one, would the next thing be to go to patients like me and read about the experiences of these different over-the-counter alternative supplements? What's next? What's the next step after an anecdote?
I think that all the things that you talked about are reasonable. I think a strategy that would be reasonable is to bring the story to your doctor and ask your doctor if they can help you validate the anecdote. I mean, that's a big part of what I spend my nights and weekends doing, is trying to find people and get their medical records so that I can prove that they really had ALS and that they really, had objective improvements. And
let me stop you there. You and I think would agree that some of the response is going to depend on the personality of the doctor. Yeah. Some are more open-minded with alternative treatments and the fact that we lack a lot of evidence right now to support this or that, whereas other doctors are more open to trying different things. So I hear you loud and clear, but I worry that the answer you might get may depend more on the personality of the doctor than anything else. Could you respond to that?
So if you can't get someone locally to help you validate the anecdote, then yes, the next thing I would do is go to ALS Untangled, see if we've already written a review about it, in which case we would have tried to validate the anecdote. And if there's no review or you didn't get the answer you wanted there, then I'd go to patients like me next, because the more positive or negative anecdotes, the more believable they are. I mean, if there's just one person saying they took something and they got dramatically better, that's quite different than 100 people saying the same thing.
Right.
So it's kind of like what we do with Amazon, right? I mean, we try to find products that have a lot of positive reviews, not the product that had one positive review and a lot of negative ones. So,
right.
So that's where you can get a lot of good information in a quick period of time about alternative therapies, is to look at what people and patients like me who are using them are saying.
Okay, so some of the resources are your doctor, ALS Untangled, and patients like me would be, and of course the internet, but some of the go-tos are your doctor, patients like me, and ALS Untangled.
Correct.
Okay, Rick, thank you very much. Again, I've been speaking with Rick Bedlack from Duke.
Hello, everyone. I'm Dr. Rick Bedlack, professor of neurology and director of the Duke ALS Clinic. I'm also in charge of education and outreach for the CREATE Consortium. CREATE stands for Clinical Research in ALS and Related Disorders for Therapeutic Development. We're part of the National Institute of Health sponsored Rare Disease Clinical Research Network. Today's podcast is part of a series we've developed to help non-scientists understand some of the work that our CREATE team is doing. I'm very pleased to be joined by Dr. Nadia Sethi today. Nadia is a brilliant and inspiring ALS advocate who lost her husband to this disease last year. Among her many accomplishments, she co-chairs the Northeast ALS Consortium's Peace Committee. She's the head of the I Am ALS Group's Promising Therapies Committee, And she's built a really useful new clinical trial search engine, which is called ALS Signal. In today's podcast, Nadia and I will interview Dr. Benjamin Murdoch, Research Assistant Professor of Neurology at the University of Michigan. We'll be talking about his recent paper, which is entitled NK Cells Associate with ALS in a Sex and Age-Dependent Manner. Nadia, Ben, I'll turn it over to you.
Thank you, Dr. Bedlack. Hi, Ben. For our first question, how might the immune system play a role in ALS?
The role of the immune system in ALS is complex, and I think that's why in the past there have been, several failures to try to modulate the immune system. Really, the immune system can be both good and bad. There are certain aspects of it that are good, for instance, T regulatory cells, which are being studied by several groups. But then some other cell types and some other pathways we think actively contribute to disease progression. And so what we're really trying to do is kind of separate out the good with the bad so that we don't get rid of the good aspects of the immune system while targeting the ones that we think are actually driving disease or making disease worse.
Thank you. And what is the role of NK cells in the innate immune system?
So NK is short for natural killer. So these are natural killer cells. These are cells that patrol the body looking for cells that are virally infected, are cancerous, or damaged. And it's their job to dispatch these cells. It's their job to kill cells that are, for lack of a better term, bad. And they can do that usually through direct cytotoxicity. They literally inject what's known as granzyme B, and they open the cell using perforin. And what they do is they tell the target cell basically to undergo what's known as apoptosis. It's programmed cell death. So these cells patrol the body, find cells that are damaged or infected, and tell them basically to turn themselves off, to sort of commit suicide.
So do NK cells attack motor neurons in ALS?
We think so. We don't have direct evidence just yet. We have a lot of sort of circumstantial evidence. In our own lab, we do have some preliminary data suggesting that NK cells directly target damaged neurons from ALS patients. Those are preliminary right now. They're not published, but I would say that probably yes. And there's a lot of evidence to suggest so. So I think in the years going forward, we're probably going to find that NK cells do target motor neurons, but we can't conclusively say that just yet.
What would keep NK cells from attacking healthy motor neurons?
So motor neurons normally express a molecule in humans called human leukocyte antigen, HLA. In mice, that would be major histocompatibility complex, MHC1. And what we found, or at least another group has found, is that this marker, which is normally protective, is absent on motor neurons in ALS. So normally in a healthy individual, motor neurons express HLA, and this basically acts as an ID badge and tells the NK cells, look, I'm part of the team, I'm healthy, I'm supposed to be here. When that marker is lost, basically those cells lose protection from NK cell mediated killing. And so another group has actually found that in ALS, the motor neurons, both in humans and in mice, lose that protective marker as disease progresses. So that makes them much more vulnerable to NK cell mediated killing.
What are some of the differences that have been shown in previous research in ALS pathology by sex and age?
Honestly, there hasn't been a lot so far. We do know that there are differences between men and women and based on older and younger patients in terms of the rate of ALS. This has been known for decades, but really no one has really explored why that is. There have been very few studies looking precisely at why older patients tend to get ALS versus younger patients, why it's more prevalent in men versus women, particularly in younger individuals. This is one of those things that's been sort of swept under the carpet or ignored because we really didn't have any idea why that was. So there's actually not a lot of literature out there on the differences between men and women and between the old and the young. We're not the first, but I think we're the first that are actively kind of looking at this as a major focus of our research.
What was the goal of this study?
So the initial goal of this study was to just show that NK cells were involved in ALS progression. That's how it started. But what we kind of found early on when we did these mouse studies was that we saw differences between male and female mice and how they responded to treatment. And at the time, we really didn't know what to make of those findings. However, as we began to explore other cell types, as we began to kind of get into NK cells in human patients, what we found is that we saw similar trends or similar patterns of age and sex-specific differences in our data sets. And so the purpose of this study was originally to look at NK cells, but as it kind of evolved, what we really wanted to show was that the role of NK cells is probably different based on a patient's age and based on their sex. So that's kind of what we're trying to get to. It's not just that NK cells are bad, but that the way that they work might be different between different groups.
Okay, and you first evaluated NK cell depletion in SOD1 mice. How were the NK cells reduced in the SOD1 G93A mice?
We used a commercially available antibody, so something you can just buy from the manufacturer. The antibody specifically targets a surface protein on NK cells in mice. And what it does is it binds to that marker, and then it helps the cell traffic to the liver where it's dispatched, where it's basically gotten rid of. And so what you can do is with this antibody, you basically inject it into the intraperineum, the belly basically of the mouse. It disseminates through the mouse's body, and it gets rid of a fraction of the peripheral NK cells. One of the key things about this antibody that we bought was that it's purified. So a lot of antibodies, when they're produced, they're actually produced in bacteria. And so when you get the antibodies, there's some residue left over that obviously can affect immune-based studies if you're injecting parts of bacteria into an animal. So this was specifically purified so that it did not have bacterial products in it, and it was very pure. And so that's what we did, is we took this very pure antibody, injected it into the mice, and that reduced the number of NK cells within the mice.
Okay, and what were your findings in the SOD1 G93A mice with regard to neuroinflammation when the NK cell activity was reduced?
So there were kind of two findings, one to do with the antibody and one kind of without the antibody. The first finding that we observed was that male and female mice are different just at baseline. If you take a mouse with ALS and you compare the two, males had higher levels of neuroinflammation than female mice. So that was one finding, because that's really never been shown. In the past, a lot of studies have specifically looked at male mice rather than female mice. This is one that combined the two, and we found that there were significant differences between the total number of immune cells in the central nervous system of male and female mice. What we found was that when we injected this antibody into the mice, when we depleted NK cell levels, that increased the survival rate of female mice, but not male mice. But at the same time, it reduced the inflammation in male mice, but not in female mice. So we don't really know right now what that mechanism is. We don't know how that works. We're looking into that. But what it suggests is that there may be different immune mechanisms contributing to ALS in males and females. There may be two separate pathways. Now, that's true in mice. We don't know for sure if that's true in humans, but our initial studies in the peripheral blood of humans suggest that may be the case as well.
Okay, and what were the differences in findings in the peripheral tissue versus the spinal cord?
So in mice, we didn't see a huge difference in the periphery. The periphery looked fairly similar in terms of immune composition, total cell numbers, that sort of thing. In the central nervous system, what we found was that there was an increase in ALS in a number of cell types, particularly microglia. They're the major cell type in the central nervous system. And we found that those numbers were reduced in male mice, but not in female mice. And so really all the major differences we saw were within the central nervous system itself, not in the periphery, at least in mice. And so that suggests that whatever differences are occurring between males and females may be specific to the central nervous system. It may be occurring within the spinal cord and not in the periphery.
Okay, and it is interesting that the microglia levels were higher in the male mice and were reduced as NK cells were depleted, but this resulted in no additional survival in the male mice. Is there more to be studied here?
Yes, there's definitely more to be studied. We are currently looking into that. We're looking primarily in human patients right now, but we also have some ongoing studies with mice using drugs that target NK cell function. So we're currently looking at that. We don't have those data just yet, but we are following up. And one of the things we do want to do in the near future is explore the underlying mechanisms contributing to these sort of discrepancies. Why do male mice naturally have higher levels than female mice? And why is it that when you deplete NK cells, why does that only seem to affect the inflammation in male mice and not female mice, but only affects survival in female mice, but not male mice? So there's something going on here, but we're just not sure what. But that is going to be one of the major focuses of our work in the coming years.
So Ben, this is Rick.
Before we get into the human data, which is also fascinating, I wanted to just ask you one last question about the mouse data. There's been a lot of treatment studies done in the same mouse model, and unfortunately, most of them have not translated over into humans. And I know there's some possible explanations, the fact that this model is based on a disease-causing genetic mutation, which most people with ALS don't have, the fact that we very often start treatments in this mouse model before symptom onset, which we cannot do in people with ALS. Do you think there's any reasons that your findings might be more likely to translate into people with ALS than your predecessors' findings?
Yeah, so the problem with the mice is always going to be there until someone comes up with a model that accurately reflects the majority of ALS. That's always going to be a problem. And that's definitely a limitation of the current study, is that we are using a mouse model that is very limited in terms of its, applicability to human patients. That being said, one of the strengths of the paper is that we do have human studies kind of in the second half of the paper that support the mouse study. So that's one of the strengths. The other strength is that we do find that there are differences between male mice and female mice. And this may, to some extent, explain past failures. If there are different mechanisms in male mice and female mice, it may be that when we take these findings in previous studies and try and apply them to human patients, they only apply to a fraction of the human patients. Maybe only males or only females are affected by the drug. And then when you go to run the study, you don't see a significant difference because only a fraction of the patients are going to be affected positively in any way, shape, or form. So I do agree that it is a limitation of our study. It's always going to be a limitation of any study involving ALS mice. But I think one of the strengths of this paper is that, one, we take it into humans, and two, we find that one of the reasons for these previous failures might be due to sex differences.
Great.
Thank you, Ben. So next, you evaluated NK cell subpopulations and surface marker expression in people with ALS. And you talked a little bit about this earlier, but how are NK cells activated in people?
So what we did is we looked at both subpopulations of NK cells. So within the global NK cell population, there are certain subpopulations that have certain surface markers, and you can distinguish those out using flow cytometry. But we also looked at surface expression of markers associated with trafficking and activation. And while we didn't see huge changes or statistical significance with the subpopulations, what we found is that in ALS patients, there was a very large, very significant increase in surface markers associated both with trafficking and with activation. So in terms of cell trafficking and binding, CD11A, CD11B, and a marker known as CX3CR1 were all upregulated on NK cells. In the case of CX3CR1, which is a receptor used by immune cells to traffic to the central nervous system, that was upregulated on average by 60% on ALS NK cells. In addition to that, we see that markers such as NKG2D, NKP30, and NKP46 were also altered, and we also saw increased levels. Now, these, unlike the trafficking receptors, are markers that are used by the NK cells to trigger activity. So previous studies have found that if an NK cell has higher levels of NKP46, or the other NKP markers, they are more likely to engage in cytotoxic activity. They're primed for activity. So not only are the NK cells more apt to traffic to sites of damage and inflammation, they are primed to kill cells. So that was our first major finding in the NK cells in human patients.
Thank you. And did you evaluate blood or CSF, and why?
So all of our findings were in peripheral blood. There are two reasons for that. One is logistical. It's much easier to get blood samples than it is to get cerebrospinal fluid, CSF. The other factor is ethics. We really didn't want to do a whole bunch of lumbar punctures or spinal taps on both ALS patients and control patients. When we did the study, it was very hypothesis generating. We were collecting a lot of data, trying to find patterns. And really, without having a kind of concrete mechanistic idea of what's going on, we really didn't want to subject ALS subjects and control subjects, for that matter, to this very invasive procedure. So going forward, if we have a really concrete idea of what might be causing these differences, we may eventually look at cerebrospinal fluid. But for now, we're looking entirely at peripheral blood.
Okay. And what were the differences that you found between men and women in the study?
So the first step, and I think we'll get to this a little bit later, is that we correlated changes in NK cell surface markers with changes in disease score. And so what we found is that the correlations differed based on age and sex. So if you correlate, for instance, the surface marker NKp46, what we found is that the amount that's expressed on NK cells changes over the course of disease. And rapid changes in disease progression, so a faster drop in disease score, correlated with more rapid changes in NKp46. However, we found that those correlations, those associations between disease progression and this particular marker were different in older and younger patients. And so we saw similar things with NKp30 in males and females. And so what we think is happening is, again, we think that different NK cell mechanisms or NK cell markers may be preferentially involved in disease progression based on your age or your sex.
And are your findings limited to the peripheral immune response?
Currently, yes. So we actually have some data from postmortem tissue. So we have a number of patients who donate their spinal cord tissue after they've passed away, and we look at immune infiltration. We have seen some sex-specific differences in our preliminary studies. Those aren't quite ready for publication yet, and I can't really comment on them, but we do think that there are differences within the CNS itself. But for right now, the only data we can conclusively say this with is in the periphery, in the peripheral blood.
Okay, and how did you evaluate whether there was correlation between the ALS, FRSR, and NK cell function and markers?
We created what's called a linear mixed effects model. So if you want details in that, I would have to talk with our collaborator, the biostatistician. But basically, in brief, what we did was for each patient and each surface marker, we calculated the slope of the change over the course of disease. And then we sort of normalized it based on different factors. So site of onset, time from diagnosis, that sort of thing. So it sort of normalizes everything and it changes it so that certain factors aren't affecting these associations. And then what we did was we stratified the data based on a patient's age or based on a person's sex to see how strong the association was between changes in disease and changes in surface markers was. And what we found was that these correlations differed based on both age and sex. So this LME model showed us that, yes, there were associations between NK cell surface markers and disease progression, but those associations were significantly different based on age and sex.
Okay, and are there any additional limitations of this study?
So the primary limitation is that it's a correlative analysis. It's associating markers with disease progression. It doesn't conclusively show that these marker changes are causing disease progression, only that they change as disease changes. So it's possible that some sort of factor upstream of both of these causes immune changes while causing disease changes. So that's still possible. We don't think that's the case, but it has to be taken into account. However, the nice thing about this study is it shows that even if that's the case, those upstream factors are likely different between men and women. The other major limitation of this study is that we have very few younger female patients in it. So we had for the human study associating changes in NK cell surface markers with disease changes. We had, I think, 92 patients enrolled in the study who had multiple time points and multiple visits that we could use for this analysis. However, only I think 7 or 8 of them were young female individuals. So ALS is very rare among younger females. That's one of the things we're looking at as to why. But that somewhat limits the amount of data analysis that we could do. So one of the things we initially wanted to do was, instead of stratifying it just by age or just by sex, we wanted to stratify it by both. So we wanted to compare older males versus older females, younger males versus younger females, and then, younger females versus older females, that sort of thing. Because we had so few young females, we couldn't really do that analysis, and we were somewhat kind of limited by the way we could stratify the data. Now, we plan to change that going forward. We just were awarded an R01 to continue the study and get more patients, more data, more markers so that we can really examine these demographic differences. But for the terms of this paper, that is one of the major limitations, is that that one group, especially younger females, we really didn't have as many samples as we would have liked.
Thank you. And is there any additional research that would grow out of these findings? I know you just mentioned a few things, but if there's anything else.
Yeah, so our group has multiple projects that have grown out of the study. We're looking at drugs that can target NK cell activity. We're making sure to look at male versus female mice. So we're not just using one sex of mice, we're using both and comparing them. We have a number of studies looking at peripheral cytokines. So cytokines are chemical markers that drive immune cell activity. So we're looking at, for instance, IL-15 and IL-18 levels in human patients to see whether or not those levels similarly correlate with disease progression rates and whether or not it's different in males and females and older and younger. And in terms of other groups, what we kind of want to get out there, the idea we really want to disseminate is that there are differences between males and females. There's differences between the old and the young, and these really should be accounted for when designing clinical trials, when designing studies. Males and females may be different, and that certainly seems to be true now with regards to the immune system. But that may be true with regards to other mechanisms that research groups are looking at. So if you are designing a clinical trial, the good news is now this may explain why your study failed. Maybe it was only effective in, a fraction of your patients, and you can go back and maybe check that. The downside is that I think this means in the future, we're going to need more people in each clinical trial, because if men and women react differently to therapies, if older and younger patients react differently to therapies, you may need to enroll a lot more patients in your study in order to be able to observe those differences in the one group that it might affect.
Thanks, Ben. There'll be some patients listening to us today, and of course, they're going to be wondering about how this might lead to better treatments for them. So do you see a path toward a clinical trial based on what you've learned? And what do you think the time frame for something like that would be?
So I think eventually, yes, this will lead to clinical trials. As I mentioned, we're currently looking at an NK cell modifying drug in mouse models that we hope to extend to human patients. I know there are a lot of ongoing clinical trials in other groups. For instance, there's the Healy platform trial. I think it's at Mass General, if I recall correctly. They are using a number of immune modifying drugs and are involved in doing clinical trials in those. And the way the trial works is that they'll do, a patient on one drug and switch them to another drug. And the idea is that you can get by with using a lot fewer patients using that strategy. So I think that this may lead to better treatments, especially if people are able to tailor their clinical trials to account for age and sex differences. And one of the things I also tell anyone who has ever performed a clinical trial or done any sort of mechanistic study on human patients is to go back and stratify your data based on sex and based on age. Because it may be that you actually had a signal, you did have a response, you just didn't see it because it was sort of drowned out by the noise of these other patients who would not respond to this drug in any way, shape, or form. It would only affect a certain segment of the population. So yes, I think this will accelerate clinical trials. I think it will accelerate drug development, especially with regards to immune modifying treatments.
Well, thank you, Drs. Murdoch and Sethi. I know I learned a lot from our discussion today. And stay tuned for more Create podcasts in our new authors series. And I'd also like to remind our listeners that we have other podcast series and lots of other great content on the Create Consortium's website. Take care, everyone, and we'll talk to you again soon.